All right. So this data factory resource is a cloud-based ETL service. All right. It's a data integration service which is provided by Azure, obviously. And data factory, it allows organizations to create data-driven workflows. All right. So they'll enable seamless data orchestration, data transformation, and movement across various systems at scale. All right. So it allows for data orchestration, data transformation, right? So when you talk about data orchestration, right? Data orchestration is it basically refers to the automated and the continuous movement or seamless movement and processing of data between different systems, right? So the all right. So when I say data orchestration and data transformation, right? Data ADF helps you with that. So what does data orchestration mean, right? So in very simple terms, data orchestration, it refers to the automated movement of data, all right, and processing as well. So automated movement plus processing of data across two systems, right? So you take the data, let's say from the data lake, and you transform it and you put it into the uh, let's say SQL database. So then this movement of data, right, and automating this movement of data is known as data orchestration. So Azure Data Factory will help you orchestrate this data movement. All right. So it will pull data from various sources. It can be from database. It could be through APIs. It could be on a cloud storage, and a real-time streaming data could be there. And then it defines and executes complex data processing workflows without any manual intervention, right? So that is what ADF lets you do. It lets you process your data plus move your data, right? Process will have transformations involved, movement of data from one place to the other. All of it will be with zero human intervention. The pipelines will work automatically. The pipelines will be responsible to get the data. The pipelines will be responsible to put the data, and the pipeline itself will define certain activities for the transformation of the data. All right. Now, to ensure timely execution of these tasks that you are going to define, right, to process the data and to move the data, right, uh, you will have, scheduled pipelines. You will have an option to schedule it at a daily, let's say at a particular time or a particular time interval, right? And you will also get to monitor the errors and the inefficiencies of these pipelines. All right. It will also help you maintain policies for access control, compliance, security. So basically, overall data governance and security measures. And then it is scalable, right? It can adjust dynamically based on the workload needs and optimize the performance across environments, right? So that is the concept of data orchestration, right? And data transformation, you already know. So with ADF, users can connect to a wide variety of sources, perform transformations, and then load the process data into a desired destination, right? So covering end-to-end ETL, right? Now, the primary goal of data factory is that it simplifies the traditional method of data integration. All right. It simplifies the entire method, unlike writing manual scripts now. So you don't have to write manual scripts anymore. Bye bye. All right. And you also do not have need to create a local compute. All right. That would process this compute intensive data processing task. ADF provides a managed service. All right. The moment you call it a managed service, what does this mean? What does managed service mean? All right. Managed service means, first of all, that it will be completely managed by Azure. All right. How the transformation happens, what steps are performed, that will only be described by the user. But to carry out those transformation, to create or to move the data, there is no human intervention required. Azure will take care of it from their end. Even the compute, even the compute within Data Factory is not something that you have to worry about at all. In your dedicated SQL pool, yes, you were worried about creating, selecting the proper compute, what DW units you should select, but that is not going to be the case here. You're not going to select the compute. All right. It eliminates the need for a complex setup, right, or a dedicated machine. Not required. All right. So there are certain core features of Data Factory. Let's discuss them one by one. Right. So features of Data Factory, first of all, it helps with the orchestration of data workflows, right? It enables the creation of workflows. Workflows basically is something that we use in terms of data engineering. We use workflows for pipelines. All right, this is another term that we generally use for pipelines. And when you go to Databricks, you will generally hear the term workflows only, right? We generally do not call them pipelines there. We call them delta live tables workflows, right? So we create these pipelines for orchestrating the data movement between sources and destination, and then transformation as well. All right. So there is scalable data transformation here. All right. So using ADF, you can clean, you can modify, you can enrich the data at scale without requiring extensive manual coding. All right. No manual coding required. All right. This is a UI platform where you define the transformation through some drag and drop activities. All right. So these activities is what you're going to define, and then you have to just configure those activities. If you remember from our discussion in Synapse, what we were doing, we just putting the activities and we were configuring those activities, nothing else. Right. Thirdly, it supports a wide range of data stores. It can help you connect to a wide range of data stores. It can help you seamlessly connect with numerous data sources such as database, file storage, cloud services, big data platforms, all of it, right? The fourth key feature is that you get a managed infrastructure. All right. So what does managed infra means? ADF eliminates the need for provisioning hardwares, right? You do not have to provision any hardware here. You don't have to manage any compute also here. As I said, there is no compute, no hardware required. There is hardware, obviously. Data processing requires hardware and compute, but this is not something that you have to manage. Managed infra, managed by Azure itself. All right. So the entire underlying infrastructure of your data factory resource and how the transformation takes place, it is going to be managed by Microsoft Azure. All right. It's very easy to use. Yes, if I was given a task to write a script to move a pipeline from one data store to the other, it becomes really difficult to write the code, right? Because first of all, you have to establish the connection to the data stores, then you have to transfer the file between the data stores, and you have to bring it to your processing platform, and then you have to write the code to process that data. On top of that, then once you're done, you have to connect to the destination data store and then transfer the file to the destination data store also. So this entirely on the whole is a very long code that you may have to write, right? And there will be a lot of errors also over time that you will face. But pipelines, on the other hand, they eliminate all of this manual coding. It's a very user-friendly interface. It supports for the drag and drop activities that you have. And ADF, in very simple terms, it simplifies the creation of a data pipeline also. All right. So imagine that you have a Parquet-based file. Let's say you have a Parquet-based file. Now, let's say this is stored in data lake, something that we have already seen, right? Your objective is, let's say, to extract specific columns from, let's say, this file, and you want to remove any rows or columns that contain null values. You want to load the cleaned and transformed data into a SQL data warehouse. Now, the traditional approach to perform this task would have been right before the tools like Azure Data Factory were there, this process would require significant manual efforts. All right, you might a developer needed to write a script file, example in Python, .NET, Java, whatever language, right? The script would, as I said, load the Parquet file into the local machine, extract specific columns, perform all the transformations, load the process data into a SQL data warehouse. Now the entire data set has to be processed in memory on the compute machine which is running the script, right? So when you are running the script on your own compute machine, there is also some challenges associated with it, right? First of all, there is a compute limitation, right? Large data sets, they often exceed the memory capacity of local machines, causing failure, right? Then it was also very complex. Writing custom scripts and managing errors, it requires advanced programming knowledge, and it was very inefficient also at times, right? Manual processes are time consuming, prone to errors, and they lack scalability. That is why Data Factory came in and changed the game. All right. It addresses all these challenges of the traditional approach, and it gives you a managed automated solution for data ingestion, data integration, right? So there's no need for custom scripts now. Instead of creating complex code, you can use ADF's visual interface to design the workflow. There is no local computer machines required. ADF will run all the processes on the Azure's managed infrastructure, right? It removes the need for a dedicated hardware, and then it seamlessly integrates. ADF, it offers built-in support for connecting to both the source and the destination, which in our example case is the data lake and the SQL data warehouse systems. But apart from this, it lets you connect to a lot of third-party systems also. All right. And finally, the most important benefit is that all of this execution is automated. All right. Data pipelines in ADF are executed automatically in the cloud. There is minimal user intervention required. So here also, you will find the same terms. First, link service, dataset, pipeline, activities, AIR. AIR stands for Azure Integration Runtime. These are all what? These are all artifacts that you have. Clear? So now let's go ahead and create an ADF resource itself and see how you're going to do that. Synapse is pretty different, right? Because Synapse offers you SQL pool, Spark pool, Data Explorer pool. Synapse pipeline is what you can say is similar to Data Factory, but then the differences also we'll see. Data flows also. You add data flows also here. Absolutely correct. Data flows also are artifacts. All right. But when you define data flow in the pipeline, it would be added as an activity only. All right. So you can also write activity. All right. So when you create the data flow in the pipeline, you add the data flow activity, correct? If you work with data flows, you can consider it to be a part of activities only, right? But if you want to write it separately, it's absolutely fine. Data flow is again a very big concept in data factory. Clear? Now we know that Azure Data Factory is a powerful tool, right? That is something that we already know uh, for your orchestration, integration of data workflows across various platforms. But you also have to understand the cost implication of the features which are present here, right? For effective usage, especially in scenarios that involves prolonged infrastructural requirements where you want to continue with data factory for a very long duration, right? So when you are analyzing the Azure subscription cost, right, you will see that, or you will notice that the Azure Data Factory, it incurs significant charges. All right, especially if you are using data flows. If you use data flows in your pipeline, then the cost is significantly higher. The mapping data flow, it allows users to design and execute scalable transformations of large data sets in a very code-free environment. All right, it's a key component for data transformation, and also, it's often a focal point in the when you try to cover the training or the certification related to data engineering, right? Data flows is something that everybody will ask in interviews as well. It is very resource intensive. That is why you have to keep an eye when you're working with data flows, right? It can drive up the cost. Yeah, sorry, I was checking if the screen is shared or not. All right, so it can drive up the cost, especially when infrastructure is kept active for an extended period, right? So something that may occur during activities like, you know, now the data flow activity, right? So an important feature which is tied to mapping data flow is again called as data flow debug mode. All right. So I'm just discussing these things before we start with the data factory itself. There is something called as a data flow debug mode. Now this debug mode, which enables real-time debugging of your data flow pipelines, right? This feature will provide you insights into the transformations, right? And will ensure accuracy, but it also contributes to the cost, all right? Because data flow debugging, it takes a lot of, or it requires a lot of computation, all right? So there are a lot of computational demands here. So running the data flow debug mode or leaving the infrastructure running unnecessarily, it can lead to higher charges. All right. So if you're using Azure Data Factory for short-term or standard operation, these costs they might be minimal, right? Just to practice, if you're doing it, the cost will be minimal. But if you're doing it for a long duration in an organizational setup, right, then it's going to cost a lot of money. All right. So to optimize the cost, it's critical to manage your infrastructure wisely, right? Uh, a key recommendation from my side would be to shut down the unnecessary infrastructure at the end of each practice session that you have, right? If you're working with the, let's say the free Azure account that you have, right? If you're working there, or even if you're working in your own subscription, right? Get rid of any unnecessary infrastructure as soon as possible, right? All right. So let's go ahead and create this resource and see what we're talking about. Right? Create a data factory resource. Now, this is something very different from Synapse, right? How you work with data factory is different from Synapse because first of all, let me create a new resource group. Azure Data Engineering batch 6. All right. The name would be NIC Data Factory. All right. The region, let's select as East US 2, right? And the version is V2. All right. V1 does not exist anymore. And that is all. That is all that goes into the creation of data factory. Now, what difference do you see from Synapse over here? Does this look different from Synapse? Yes or no? There is no SQL pool here, obviously, because you do not write code in data factory. You're not required to write any code here. The mandatory provision of having a data lake. Yes, absolutely. Earlier, it was mandatory for us to have a data lake, which is not mandatory anymore, right? So there's no data factory here. Git configuration is there, right? And we'll select on configure the Git later. Networking settings. So there's a self-hosted integration runtime. We'll talk about this later on, but just remember that sometimes the Azure integration runtime, it does not connect to resources from outside, all right, or data stores which are outside Azure. Azure integration runtimes works best for Azure-based resources. So if your file, your data is residing outside Azure, in those cases, you have to use a different integration runtime or different compute service. That is self-hosted integration runtime. So we'll discuss about this. And it says if you want to connect to the self-hosted integration runtime, you connect through the public endpoint for the data factory resource, right? That is fine. Now, if you want encryption using the customer managed key, right? Microsoft managed keys will be there. The data by default will be encrypted with Microsoft managed keys. But if you want to integrate, use your own keys for, let's say, the encryption process, right? So in that case, you can use your own keys, right? Let's just review and create this. All right. And this will be created very quickly. This resource does not require anything. It gets created within minutes. See, done. The moment we create it, it's done. Right? Now, here, one thing that you have to keep in mind that when you talk about the cost of using the Azure Azure integration runtime, the compute which is there, right? The integration runtime, the charges are based on the compute resources used to execute the activities in the pipeline. All right. For example, the copy activity in Azure Data Factory will use the Azure integration runtime to move the data securely and reliably. It's self-hosted integration runtime will use your on-premise, uh, let's say, compute, right? And SSIS integration, we'll talk about that later. So as of now, there's nothing that you need to know about Data Factory, and this is what gets created, the NIC Data Factory resource. Again, similar to your Synapse Studio, there is something called as Data Factory Studio that you have to launch. All right, so you can launch the Data Factory Studio like this. Just close this as well. And this is exactly what the Data Factory resource looks like. Does it look very similar to Synapse? So you get to create pipelines, you get to transform your data, right? These are quick, uh, I would say, quick ways to create or ingestion pipeline, orchestration pipeline, transformation pipeline, and then configuration of SSIS is something that we'll see later on. Now here you can Power Query is not something that we're going to cover, right? It does not something that we are worried about as of now. We are worried about the pipelines, we are worried about the data flows and the data sets, right? Now in the author section, you get to create the pipeline. Now, this pipeline creation page is completely different from what you had in Synapse, right? In Synapse, you would not have these pipelines, change data capture, data sets, data flows, Power Query section. You did not have these, right? In the monitor section, again, you can monitor all the pipeline runs here. You can monitor all the triggered runs, right? Whether it was a scheduled trigger, whether it was a tumbling window trigger, whether it was a storage event trigger, or whether you had defined your own trigger, right? So any pipeline that has been triggered except the manual trigger will show over here. All right. Change data capture is basically to load delta data, right? Incremental data load. How many of you heard the concept of incremental data load? Heard the concept? Yes. Incremental data load is a concept where you do not load the entire data set again to the cloud. You only load what's new, right? Whatever new data has been added to your database will be then taken ahead, right? So that is for incremental data loading. Then you have the integration runtime here. You have the default Azure integration runtime, right? The auto resolve integration runtime is the Azure integration runtime that we have, right? So it's running, it's always running. You do not have to, start it, stop it. It will continue to run, right? This Azure integration runtime, it continues to run. Then you can create a self-hosted integration runtime. It will show up here, right? You can create the Azure integration runtime is already there. And these two runtimes are the ones that we are going to work with. In the manage section, you will find everything related to the factory. Is there a way to expand this? No, but now this is the factory settings, right? How do you want to show the billing? By pipeline or by factory? All right, do you want to see the cost of each pipeline, or do you want to see the cost of each or the entire data factory resource itself? How do you want to see the billing? Then you can set up the staging location for the entire workspace itself. All right, here you have an option to set up staging for the entire workspace altogether, right? Connector upgrade, right? These are basically when you connect to an external data store, right? There, you may have some, connectors which are default, right? That you get by default, and sometimes you may need an upgrade on the connector, right? Let's say to increase the throughput of your data movement, or let's say to connect, to reduce the latency of data movement. Sometimes those platforms, they would require some upgrade in the connection, right? How is the connection established? Connection is established through link services, right? Link services, they allow you to connect to various data source, and you can see here, if you select, right, you'll find almost all the data source that you had in Synapse or even more here, right? So Azure based resources, uh, Sandra, Dataverse, Dynamic CRM, GitHub, right? Google BigQuery, Google Sheets, Hive Data Store, HDFS, right? HDFS is for um, your Hadoop systems, right? Hadoop distributed file store. So HDFS is there, Jira is there, MariaDB, Microsoft Access, M365, Fabric Lakehouse, Fabric Warehouse, MongoDB, right? ODBC, Oracle, PayPal, PostgreSQL. All these different stores are available that you can connect to. ServiceNow, Spark, right? Snowflake. You can connect to all different stores. Teradata also there, right? Teradata is also there. So these are all the different stores available, right? Connecting link service to Azure compute services, right? Whether say, let's say you want to connect to Azure Databricks from your data factory. So you can use this particular link service. If you want to connect to Azure machine learning services, using your data factory, you can connect it from here. Azure functions, right? So various other services also. These are Azure-based services. These are compute-based services. The Azure Synapse Analytics Artifacts, Azure Machine Learning Studio, Azure HD Insight. So we're not going to worry about all of that as of now. Then, uh, after link service, you have the integration runtime, right? One second. So this is where I can go ahead and create a new self-hosted integration runtime if you want to create, right? And it's a very simple process. I can just select that it's going to be a self-hosted integration runtime. And basically what you do in self-hosted integration runtime is that you select your own compute to, work as the compute provider. So you'll have your own machines. You'll use those machines as the compute provider for your pipelines, right? And if I want to transfer data from, let's say, my Windows machine to Azure Data Factory, then I can convert that particular Windows machine into a self-hosted integration runtime, and I can use that self-hosted integration runtime to do data movement between my on-premise environment and Azure environment. And don't worry, we'll cover all of that also. You have Microsoft Purview here. Now, Purview is a comprehensive suite of solutions which is designed to help organizations, right, to govern, to protect, and to manage their data across various environments, right? Basically, through Purview, you are integrating data security along with data governance and compliance as well into a unified platform, right? So this ensures that businesses can maintain visibility, safeguard their sensitive information, and meet the regulatory requirements, right? So Purview provides a centralized approach to data management. It addresses all the challenges such as data fragmentation, lack of visibility, and evolving compliance needs, right? Now it enables organizations to gain insights into their data estates, right? It can protect sensitive information across the life cycle of data, can govern the data as well across your on-premise and cloud and SaaS environments, and it can manage the risks and regulatory requirements effectively. All right. When you talk about security, Purview offers a lot of security solutions to help organizations, right, to protect their sensitive data, right? So you have something called as DLP, right, which is very common nowadays, that can be implemented through Purviews, that is called as the data loss prevention. All right. So it prevents any unauthorized sharing of any sensitive information. You have data security posture management, information protection, insider risk management, privileged access management, right? privileged access management will control who has access to critical data and critical data systems. So we'll work with Purview. We'll try to see what Purview offers as well. Then the same Git configuration is here, right? You can connect to your GitHub or Azure repositories, right? And manage the entire code over here that you have. Then you have the ARM template also. This ARM template, how many of you remember the concept of ARM template? Just tell me in the chat window. How many of you remember what ARM template was, what it did, how it worked? JSON file, right? And what did the JSON file do? Yes, basically not. See, that is Azure Resource Manager. The validation of resources is done by Azure Resource Manager. The ARM template is the JSON file that helps you recreate resources. All right. Now, if I want to go ahead and recreate this entire data factory resource somewhere, right? Let's say some other place I want to take this data factory resource and recreate it. So then what I can use is I can use these ARM templates. All right. Clear now? I can use the ARM template and what I can do is you can see the export button here. I can, click on this export button and it will download, the ARM template for me. And it's basically a zip file which contains two files, parameter.json, right? One is the parameter file itself and one is the template.json. So template.json and parameters.json together, they create uh, you know, uh, the entire infrastructure details are mentioned over here. So I can import on Azure portal. If I want to create a data factory resource, I can import it on the Azure portal. Or if I want to create a copy of this data factory resource itself entirely, then I can go ahead and export the ARM template from here. Then there are certain, triggers that I can add for my pipelines, right? It could be a schedule trigger, it could be a tumbling window, it could be a storage event, it could be a custom event, right? So we'll try to see what all these different triggers are. You have global parameters that you can add to your pipelines, right? So this is very important when you're working with tumbling windows. Data flow, we'll talk more on data flow later on. Credentials, credentials also we'll see. Customer managed keys is for your encryption, right? And outbound rule is for your data movement. All right. Now, this is fine. And then finally, you have a learning center here, right? So this will contain all the tutorials, all the videos that you can go through in order to learn data factory resource. All right. So it's very simple. If you see, let me just show you. If I want to create a pipeline, I'll just click on this plus icon over here and I'll create a pipeline, right? So this is how I'm going to go ahead and create the pipeline. So there are various activities here. You'll see some activities, which you had already seen in Synapse. Most of the activities are present in Synapse also, right? But then on top of it, it provides you with data flow and other things that can help you with very extreme and let's say very complex transformations. So the entire process is the same. If there is a copy data activity, you are going to go ahead and create the entire rule. The source you're going to define, the sink you're going to define, the mapping you're going to define, right, of data, and then the settings of copy data if there is any, right? So like this, you're going to again create the same pipelines, right? The process is exactly the same. We'll try to see some more examples when it comes to data factory. We'll see more examples. If I go to data flow, right, if I want to create a new data flow, so this is what the data flow interface looks like. Again, I can add a source, right? Source one, I need to first define the source. Where is this source, right? Where is this data coming from, right? Source options, all of that we need to define first. Once again, right? So where is this data set? About source one, where is the data coming from? So I can select a data set, existing data set, right? Or I can, connect to a particular data store and then I can define the data set. Then there are options like allow schema drift. What is schema drift, right? Infer drifted column types, validate the schema. What are these different options? That is also something that we'll see. Uh, Apart from that, I can add multiple sources here, right? So the difference between the pipeline and this particular data flow is that when you work with pipelines, see, you can only define a single source for your data, correct? You only define a particular single source. The data set is one. Is everybody able to see here? Or you want me to zoom in? When I select the source data set, I can only select one single data source over here. When I start working with data flows, I can define multiple data sources. I can define multiple sources, right? And then I can say what happens after this particular data has been fetched. So I can click on this plus icon. Now what I can do, I can create join of these different sources, right? I can say I want to perform join on the first source and the second source. What I'll do, I'll say that this is going to be a join. The left stream is source one, right? The second right stream would be source two or source three. And I want to perform full outer join, inner join, left outer, right outer, right? Let's select inner join. So basically, this particular inner join will, create an inner join between the first data source and the second data source that you have. Then you can, select particular rows. You can aggregate rows, right? You can filter it, you can sort it, and then you can put it to the sink also, right? So this will become my destination, right? So sink will have the sink data set where you actually want to put this data. So like this, you define the data flow. And if you enable the data flow debug here, this is what we were talking about. It will check the entirety of your data flow, how it is working, whether it's working fine or not, whether the configurations that you've done, they are correct or not, right? So before you actually trigger the data flow, you can go ahead and check whether it is going to work properly or not. Now, one thing that you would find different from Synapse, link services are empty. How many link services were there in Synapse by default? Two, right? So by default, we had two link services within Synapse, but here we do not have any. That is because it is not connected to any data store by default. Data factory is not connected to any data store. That is why if I go to my data lake, right? Let me go to the identity and access management. Let me check access if this data factory has access to my resource. Now, when I connected my Synapse workspace, right? At that time, you would have seen that by default, access was added for the Synapse workspace onto my data lake. Now it's a managed identity. I want to check it for data factory over here. I'll select the data factory resource. Now I'll see there is no role assignment for the data factory, right? So by default, data factory will not have access to your data lake. It does not have it. That is why when you're working with data factory based resources, you have to explicitly create a connection between the data factory and the data lake, because the default connection does not exist. So you do not have any link service here. Now, why do you think people prefer data factory over your traditional, let's say, scripts and all? Yeah. So the question is for everybody, simple coding, but there is no coding at all. All right. So I'll explain, and I'll give you a very convincing reason as to why, as an organization, you would spend money on data factory rather than, getting developers who would write the code for you. Now imagine a situation that, write it down as well. Imagine a situation where you were using your traditional computer programmers, right, to write the code for your data movement along with data transformation. And this is totally the ETL, right? Data movement. Either you're extracting data, you're loading data, that is data movement, and then transformation here. So ETL process. Now, when you use code, let's say you're using Python to write this program, you used a particular framework, you're using particular libraries. So what happens? These programming languages, these libraries, the frameworks, over the time, they evolve. Correct? Yes or no? Every programming language is evolving. You get Python 2, Python 3, then inside 3, you have different version 3.4, 3.5, 3.6. It keeps on evolving. And certain capabilities, they become obsolete as well after a particular duration, let's say 4 or 5 years. There, it's bound to happen that certain libraries, they will become obsolete. Certain technology within the code itself, it becomes obsolete. Older version will lose support. There would be performance improvement. There would be compatibility issues with the newer systems also, right? So if somebody had written code in Python 2 Can you imagine how much problem they would be facing right now to make their code compatible to all the newer systems? Do you understand the issue here? Yes, if the software is written in a very legacy language, right, it may struggle in modern environments. On top of that, as business grows, their needs will change. Code that worked for earlier requirement may no longer meet the current expectations, right? And security updates also. Have you seen there are regular security updates coming in? Yes or no? Security standards are changing rapidly. So therefore, the older code that you may have written, it may not meet the modern security standards which are there, right? So the systems are open to exploitation also now. The hardware also changes. Code might be written for hardware that's no longer widely used, so that makes it, incompatible with the newer systems. So that is why you would have heard of this term. Have you heard of this term? Modernizing code, migration and modernization. Have you heard of these two terms at least? Migration and modernization. No? All right. Migration means that you're, picking up your, let's say, existing workload from the on-premise environment and you're putting to the cloud environment. Now, obviously, the version in which, or the language, that framework, the library is used to create your application, it may not be supported on the cloud because the cloud will always support the latest technology. It will always support the latest version of anything. So therefore, your code will also need some modernizing from time to time. That means to bring it up to the standards of the newer standards that were released recently. So do you understand the problem? The code modernization is a big issue. And that is something which organizations are spending a lot on today, right? Because their legacy applications, they fail to work in the modern scenarios. Understood now the meaning of modernization? All right. So to stay relevant and functional, the code needs regular updates, right? And migration to newer systems also. Do you think all of this is required in Data Factory? Do you think all of this is required? All of this is a headache? The answer is no. This is not at all a headache in Data Factory. Why? Because eventually, when you use the UI to design the pipeline, all right, even though you have used UI based elements to create the pipeline, what works in the backend? When you create a pipeline, you define the source, you define the transformation, you define the destination. Eventually, in the backend, there will be code that will running, right? Code will be running in the backend. You have designed it using visual interface, right? But every visual interface will have a backend code, yes or no? Corresponding code will be created in the backend that will be executed. Now, who manages this code? Who manages the code? Who do you think? Who will manage? We are not writing this code. So who's writing this code? Microsoft is writing this code, right? So when you create pipeline to connect from one data store to the other data store, right? In that case, Microsoft in our case, right? So in that case, you don't have to worry about, the evolution of the code, which was a big problem if you were not using these pipelines. So organizations today want a solution that will work for a longer duration without any interruptions, right? And for that, this is perfect. Pipelines are perfect, correct? Because they would define the logic, they would define all the transformation, but eventually they don't have to write the code. And it's perfect for people coming from various different backgrounds, right? We can have a Java developer, a Python developer, a JavaScript developer, a .NET developer. Everybody could come in and create these pipelines with ease. All right. Now it's not like if only a Python developer can do this, only a Java developer. It does not matter which programming language you knows, the developer knows, right? They'll be able to create these pipelines with ease. All right. So is this clear to all of you? The basic introduction to the Azure Data Factory. All right then. So we'll stop here for the day. All right. And we'll continue from here tomorrow. Thank you everyone for joining in. So today, we have seen a lot of things in the Synapse workspace, right? We tried to cover the serverless SQL pool, the dedicated SQL pool, obviously the two most important pools there, right? For the exploratory data analysis and as well as building your warehouses. Now we'll be using, Synapse Again, it's not that we've ended Synapse. It's not that we'll not be using Synapse anymore. So we'll be using Synapse because now when we are working with Data Factory, right, it will continue to work as our data integration tool. So we'll try and understand what data integration means and what Synapse also, does with Data Factory, right? Because now we are going to start with another tool, right? Now we're going to start with Data Factory. So we will be trying and understand, try and understand how do I connect Synapse with Data Factory, right? So to do that, right, what we do is we from now onwards try and build our warehouses in my Synapse workspace. So I'll be using Synapse as a warehouse purpose for a warehouse purpose, and I'll be using Data Factory as a data ingestion tool. All right, that is what I will use it for. So let's try and understand what Azure Data Factory actually is, what it does, right? So I'll open Data Factories here. I'll click on create, and a very simple Data Factory resource I'll create, right? And it does not require a lot of things. Data Factory is very simple to create resource. If you see on your screen, there's not a lot of configuration that goes into creation of Data Factory. So I'll call it NIC Data Factory here. Region, I'll select, let it be as East US. V2 is the only version available. All right. Now, if I go to Git configuration, now how many of you are aware of the concepts of Git and Git based tools like GitHub, Azure Repos, Bitbucket? How many of you work with it? Okay, so we'll try and see what Git also is, right? The version control system, why is it required? And then when you talk about Data Factory, right? How does it connect to it and why does it connect to it? This also we'll try and understand because managing your code, right, is also very important. So we'll try and do that as well. Within Synapse also, we wrote a lot of code. So managing that code, managing the versions of those codes, right? We'll try and understand because if I say things now, you'll get confused since you do not know what Git is. So first we'll try and understand Git, then we'll cover that portion also. So Git integration of both Synapse and Data Factory is important for us, but we'll do it towards the end of Data Factory, right? Once we cover Git. Now, let's try and understand. First of all, let's create this resource and see what is it all about. In networking, if I go, there's a managed virtual network. Choose whether you want a default auto-resolve integration runtime to be provisioned on demand inside an ADF managed virtual network, or where do you want it. This is all very confusing right now. Very confusing, but it'll all make sense in a short time. Short time as in some 3-4 days, you will have a complete understanding of this, what it actually is, right? And what is it doing. Now, networking, connect via public endpoint. I don't want to, you know, go through this managed virtual network and self-hosted integration runtime. What does this even mean? I don't know, right? As of now, I don't know. Encryption, by default, the data is always encrypted. But if you want to use your own encryption, that is customer managed key, you can click on this checkbox. Then there are tags, not required here. Just review and create this. See, very simple. There's nothing, no data lake required, nothing required. Let's click on create, and it will not take more than uh, you know 2 minutes for this to be created. All right. So my data factory resource is created, and it did not exactly take more than 2 minutes. Let's go to the resource, and my obviously it takes me to the NICRG where my data factory is present. But this is not the default view. If I go to data factories, I'll be able to see my NIC data factory present over here. Yes, so I'll launch the studio. Yeah, and this is what the data factory looks like. Now here, if you see, it looks somewhat similar to my Synapse workspace, right? It looks very similar to Synapse workspace. It's not very different from it. There is an ingest section here also. There is orchestration over here, transformation of data here, right? SSIS is there. So there is an author section here. There is monitor. There is manage. and there is a learning center where you can learn more about, data factory. Here, I don't write scripts. Here, I don't develop scripts. So there is no develop section here, right? There is no data section here because I don't store any data in data factory. Data factory does not work as a data storage or a data warehousing solution, which Synapse was. And that is why if I show you what the Synapse workspace looks like, right? Let me open it. Right. So see, on the left hand side, there is a home section. There's a home section here also that brings you to this page and it brings you to this page. Then there is a data and develop section, right? But there is no data and develop section in data factory because in Synapse, I store the data. I have SQL pools. I store my data there. I create permanent storage. I create dedicated SQL pool and store my data. But in data factory, it's never a data storage solution. It does not store data in any form. All right. Coming back here, there is integrate section, which is for pipeline. And that same pipeline section over here is called as author section, right? So in Synapse, when I wanted to create pipeline, I would go to integrate section. Here, if I want to create pipeline, I go to author section. Then manage and monitor are already there. So manage and monitor are over here. And then there is a learning method. But if I go to pipelines over here, integrate section, I see only pipeline. But here I see so many things: pipeline, CDC, data sets, data flows, Power Query, right? What is the difference? What does it do? So to fully understand that, the first thing that we need to understand is what is data factory itself. All right. So let's try and understand first of all what data factory is, what it does. So we can then fully understand the capabilities and what it is used to do, right? So there's a lot of things that we need to understand about data factory before we jump right into creating these pipelines. Now, in the big picture, data factory, let me write it down here. Today's business, right? They run on data. That is a new oil for them. That is a new currency. Data is the new currency. But raw data, not of use, right? It's messy, it's disorganized, it's spread out all over the place, right? And to make this data valuable, I need to collect this raw data. Collect, clean, store. I need to collect it, I need to clean it, I need to make that data useful, and I need to store it in a place where I can use it or analyze it, right? To understand this process, let's simply think about a car factory, right? A car factory does not magically create the car from thin air, right? It has multiple processes. For example, a car factory uh, would have various raw materials. It will get its raw materials from various suppliers, right? There would be one supplier who would be providing steel, right? Somebody would be providing the rubber tires, right? So rubber tires would be coming from a particular factory. Somebody would be providing glass, right? And the company who's providing steel would definitely not be providing rubber tires and glass, right? For the windows. So various items need to be brought into a single place that is called as my car factory, where I can work with this raw material, refine it, make it better, and make it of use, right? All of these materials are brought into the assembly line, right? There will be a series of machines, there will be a series of workers who are going to perform specific tasks in a specific order, right? They press the steel into doors, they mold the rubbers into tires, they assemble everything onto the chassis, and the transformation process starts, right? So, what was the first step in the car factory? That was integration. Integration of my raw materials coming from various sources. Second was transformation. And finally, they keep it and keep it in the yard. They are, they have to deliver the finished product. Once the car is built, it is painted, it is tested. It's not left on the assembly line, right? It's loaded into a truck, and delivered to the customer or delivered to a showroom. ADF or data factory Azure Data Factory or Data Factory is nothing but a digital version of this. All right, it's a digital version of this factory, but it builds with data instead of steel, rubber tires, and glass. You can say that this is now my data factory, which will have data coming from various sources. This could be CSV data, this could be Parquet data, this could be JSON data. All of this data needs to be brought into a single place. That is the integration of data, and then transformation needs to happen, and then you load the data. So extract, transform, and load. So ADF is one tool that lets you do ETL, connect and pull the raw data from various sources, right? Transform, reshape, combine, enrich that data, and then deliver the clean finished data to a destination system, like a data warehouse or a database, wherever you want to store the data. And this entire process is known as ETL. You're already aware of it, right? What happens? Now, Data Factory is the master of this ETL process. It can also perform something called as ELT, right? Extract, load, transform. It's a modern approach where you load the data directly into the powerful system like a data lake and then perform the transformations on the data lake itself, right? So it's like dumping all your raw data into a massive high-tech workshop and then using powerful tools inside that workshop to build your car. All right. Why do we need data factory first, right? Imagine that you're manager of that car company, right? Retail company, and you have data everywhere, right? There is a sales transaction in an on-premise SQL Server database, right? I'll tell you. Let's see. If you are the analyst or a manager or anybody, right? So you have sales data that is present in my on-prem SQL databases, right? There could be clicks on my website that will be stored in Google Analytics with Google, right? I'll have a product inventory that is managed by, let's say, a cloud application, right? Right? And then there are customer reviews, which are textual data uploaded to your website or somewhere, right? Anyway, now all of these different types of data to answer a very simple question, which marketing campaigns are driving the most sales for the highest rated products? If that is the question that I have to answer, I need all of this, right? To answer this, I need to bring all of this data together into one single place where I can analyze it on the whole, right? So what you will do, you will build something called as pipelines. Now these pipelines will pull the sales data from SQL Server. They will get the website data from Google Analytics. They will combine this data to see which click led to which sale. And then it will load this combined valuable information into central data warehouse or a repository wherever you want to put your data, right? Now, there are several items in the data factory, right? So data factory helps you build pipelines or data pipelines. In very simple terms, they help you build data pipelines. What does it do? It takes data from the source, takes it through a pipeline, and puts it to a destination. So data goes from source, flows within to the destination. This is called as a very simple data integration where I just copied the data from source to destination. If there was a file here, the file went through my pipeline and it went to the destination. Very simple, right? But sometimes you would want to do some transformations also. T1. T1 is to remove null rows, let's say. Then there could be another transformation, T2. T2 could be to filter the data. let's say I want to analyze the data for a specific region only, then I'll filter my data on based on that specific region, right? So until now, any doubts? All clear? So my data is going from my source to my destination, and I'm doing two transformations here, T1 and T2. These T1 and T2 are called as activities. All right. Activity is like a single task that you perform on the data. All right. Activity, the single task that you perform on the data. It could be cleaning, it could be picking it up, it could be loading it could be anything, copying anything, right? An activity is the single processing step within a pipeline. So this is my pipeline, right? T1 and T2 are activities, and I'll circle them because I want to tell you about certain terms. So pipeline is there, activities are there. Apart from this, who is going to tell me what do we use to connect to source and destination? For a pipeline, what helps me connect to the source and destination? We've seen already in the synapse. Who's gonna tell me? You guys did not revise synapse. Connection, yes. To establish the connection, what did we use? If I want to connect to source and destination, what did we use?
I think it's a act. I don't remember that term, but
For
it's
my
kind of like,
pipeline to connect, I'll remind you. Remember now?
Yeah,
yeah,
yeah.
linked services. Yes.
Link services,
Yeah.
right? Link services help you connect your pipeline to data stores. These data stores could be either the data source or data destination, wherever you're picking the data from, wherever you're putting your data, the connection will be established through link services. Now, when I need to tell my pipeline, right, that in this source, this is the data that you have to pick. Yes or no? If I'm creating a pipeline, if I created a pipeline that takes my data from place A to place B, I also need to tell the pipeline what data to pick. Yes or no? Guys, very simple. You need to tell the pipeline that this is a CSV file and you have to pick that CSV file. Correct?
Yes.
Yes. So when I define file location along with file type, I am creating something called as a, what did we call it? Anybody remembers? Data set. Link service will take me to the main gate. But within the main gate, which room, which container to go to? What is the type of the file? That is all defined by data set. So four terms are mentioned here. Any doubts in any of these four terms?
If the destination is DB also, it's the same, like defining
Uh,
DB
uh,
location, right? I mean,
could you
what
repeat
is
your
the
question?
proper? No, no. If the destination is a DB database,
Huh, huh.
then the process
Then
is
also a
same,
link
like,
service is required. Yes,
yeah,
always.
and the data set also required.
Data set also required.
Okay,
Always required.
okay.
See, whenever you're moving data from one place to the other or you're copying data from one place to the other, it does not matter what transformation you are doing between the copy and the paste. But if you've copied the data from one place and you're pasting it at the second place, right? Always your source data and destination data will be defined. That
Yeah,
copy
because
it,
data
it is,
set, you mentioned define file location and file type. If it is a
yes,
DB, then what we have to mention here for data set?
database will, yes, it will have its own address. I'll show it to you,
Okay,
right? Whether it's an Azure SQL database, whether it's an Oracle database, whether it's a Amazon database, right? Whether it's an on-premises SQL database, where you can put address to everybody, right? You will have server address. A database will have a server address. So that is
yeah,
the location. Then
okay,
within that server, which database to go to will define the location of my file or location of my data. So I'll not call it file. because I think it's confusing. Define
Yeah,
the data location.
correct. Yeah. Now got it.
Got it? Data location and data type. Now I think it's making more sense. Yes. So you have data sets, you have activities, you have pipelines, you have link services. Now, if I want this pipeline to run at a specific time every day, what do I need to create? I need to create something called as a trigger. All right. A trigger will define at what time, at what interval, with what frequency the pipeline executes itself, right? Autonomously runs itself. Clear? This is clear to all of you? What
So
you see on
only
your screen. Mhm.
trigger we can use for execution, or we can use on demand also. Like I wanted to run
On
now
demand
itself.
also. On demand
Okay.
also.
Okay.
On
Okay.
demand also. Trigger is basically running the pipeline. To run the pipeline, you need to trigger it.
Scheduling.
Now this trigger could be trigger now. That is when you want to run the pipeline now itself. You want to manually trigger it. That is trigger now. Or it could be a schedule trigger. It could be a tumbling window trigger. It could be a storage event trigger. When we do triggers, right, you will understand different types of triggers available in Data Factory. Clear?
Okay. So
Yeah. So now what you see on your screen are 5 items. One, or let me put it in order. One, pipeline. Two, activities. Three, link service. Four, dataset. Five, trigger. These 5 are called as, one second. They're called as your artifacts. Artifacts are used to define a pipeline. And to define a pipeline, what you need are 5 components. One is the pipeline itself. Two, activities. Three, link service. 4, dataset. Trigger. These 5 artifacts are the only things that go into creation of a pipeline. One, I will create a pipeline itself. I will say I want to create a new pipeline, artifact created. What all activities do I need in that pipeline? What all transformation, what all data movement I require, I can define by activities. Where my data is present, where my data needs to be pasted, I define it by link service. What is the location of the data in that particular system, and what is the type of data, I define by data set. And then when to run the pipeline, whether now or at a particular time, or let's say if a new file is added to the storage account, trigger the pipeline, that will be defined by trigger. From 1 to say 5, you will be able to, execute a pipeline on its own. Now, to run this pipeline, can I do it without compute? Can I run this pipeline without compute? Can a pipeline execute without compute? No, right? So therefore,
Yes.
compute is also required. But since it's ADF, right? Since it's Azure Data Factory, you don't worry about compute. Microsoft will take care of this compute here. And that is my 6th artifact, if you want to call it, but that is its name is integration runtime. Once I select the integration runtime, that is the compute required to run the pipeline. I create the pipeline, I add activities, that is individual transformation. I give it the link service to connect to the data stores. I give it the data sets to define what type of data is gonna be, required from source and destination, right? And I know the trigger and I have the compute. My pipeline will execute. All of this is together called as artifacts. Artifacts are what make your pipeline. All right. Let's see. Let's see more of this portal now. Data set now you understood. Pipelines you understood. Data flows are like transformations only. Treat them like activities. Power query not required now. Change data capture is still in preview. You have to worry about pipelines, data set, and data flows. These three are the only important things for us. If I go to manage section, link service, integration runtime. All right. Triggers. Three of them are present here itself. Let's go to author section, go to pipelines, click on this, click on new pipeline. So first of my, let me go here. So first of my artifact I have created, that is the pipeline. So I'm on pipeline number 1 now. I'll call this copy data pipeline. All right. Simple pipeline. Close this. Now, first done. What is the second one? Second one is the activities. So from the list of activities here, I will select my copy data activity. I know we have done it before. It's just, to revise. So 2 of my artifacts done, copy data activity done, right? Let's say I want to pick my data from my data storage account, data lake. Let me go to the container. Let me delete the file from sync because this is where I want to put the data now. So I want to pick up the data from this data container and I want to put it into the sync. So what is present in the data container? I think there should be 3 files here. Now the next thing that I need here is to select the file activity log 1. I need to move it, all right, from my data container to my sync container here. Let's see how to build that pipeline in Data Factory now. I'll call this copy data activity, right? So this is the activity, this is the actual data movement which is happening. Apart from this, there are different transformations also that I can do, right? In general, you will see there is get metadata, lookup, running a stored procedure in the database, executing a script, right? That is there. If I want to run a notebook in Databricks, right, I can do that. If I want to run a job in Databricks, I can do that. If I want to run an Azure function is basically used to make API calls, and also if from the pipeline I want to make an API call, I can use Azure functions. I can use Synapse, run a notebook within Synapse, right? I can use data lake analytics, right? Run usequel. I'll discuss what usequel is. If I have machine learning, right, I can execute machine learning tasks. I have filter, for each, if condition, switch condition, until, right? If I want to put these iterations and conditions, I can do that as well. Now, let's call this copy data from data to sync, right? From data container to sync container. That is the name of the activity that I've given. This is an activity. The entire canvas is the pipeline, right? So if you see, this entire canvas that you see is the pipeline. We go to the lowest number of zoom. So if you see here, from here to here is your pipeline, and within the pipeline I have one activity. That is my copy data activity. Now I will have to go to the source. The problem with Data Factory is that within Synapse, so you got default link services. If I go to manage section, if I go to link services, these are all default link services. I don't have an option to delete them, right? I can open it, but there is no option to delete it. There is no option at all to delete it. So these are link services that come inbuilt. But in Data Factory, if I go to manage section and I take you to link services, there are no link services. Why? Within Synapse, link services was defined for 2 default places. One was Synapse itself, and the other was the data lake that you linked your Synapse workspace with while creating the Synapse workspace itself. When I was creating my Synapse resource, at that time I have to link it to a data lake. So it creates a default connection to that data lake. And then since Synapse is used for data storage, it will create a connection to itself also if it needs to store data in itself, right? But Data Factory does not have any storage. Data Factory is not connected to any data lake. Therefore, by default, there is no link service. So let's create that link service to my storage account now. So my storage account is present in Azure, right? I'll call it Azure Data Lake Gen 2, right? So if I search for it, I get Azure Data Lake Gen 2. You were asking for databases. See how many different databases are there. Spark, SAP Table, PostgreSQL, MySQL, Oracle, MariaDB, Hive, Google Ads, right? Amazon, uh, and then Azure-based databases are also there, right? Azure SQL databases over here, managed instances here, right? This is fine. Uh, Warehouse in Microsoft Fabric is also there now, right? For us, it's a connection to the data lake. So I'll select data lake here and click on continue. So I'm creating a link service. I'll call it NIC data lake linked service. All right, because it's helping me connect to my NIC data lake that I've created and connect via integration runtime. So which compute to use to connect to my data lake? Use this auto resolve integration runtime. That is the compute. Integration runtime is the compute. There is only one available. I'll select it. How do you want to authenticate onto the storage account? I want to authenticate. I can use account key. I can use SaaS token. I can use a service principal. I can use a managed identity. Let it be account key because the data lake is in my subscription itself. So where is the account present? Within my subscription. Which subscription? This subscription. What is the name of the storage account? This is the name of the storage account. All right. Now, if I click on test connection, let's see what happens. So connection is now successful. That means I am able to connect to the data lake very easily. I don't have to worry about it. So I'll click on create. So this link service is now created. So my link service is now created successfully. There is no usage of it as of now. That is why the related section shows 0. But this link service could be deleted just like any other link service that I would create in Synapse, except the default ones. Now, link service created. Let me publish it. Okay, publishing error came from my pipeline because I have not defined the pipeline here. So let's come here. Let's start now defining the source. So when I define the source, what do I define? I define my source data set. What is source data set? Basically, letting the data factory to know or the pipeline to know where is this data present. First of all, the location of the data, how to connect to it, right? So I'll tell you what the data set is all about. Data set is nothing but it answers 3 questions, right? First, where is the data present? Second, or let me put it like this in order. First, how to connect to the data source, right? Where is data located in this source, right? So if I let you enter a building, you don't get to know where the actual person is, right? You need that address also. So how to authenticate on the main gate of the building, and then where in the building is my person located? And the third question that I need to answer, or the third statement here is, what type of data is it? Yes, 3 questions. Data set will always answer only these 3 questions. Answer to the first question. What is the answer to the first question? How to connect to the data source? How do you connect to the data source? Who helps you to connect to the data source?
Link services.
Absolutely correct. This is my link service. Where the data is located in the source, I can say within the data container, it is activity log CSV. Then what type of file it is? It's a delimited text where the column delimiter is equal to a comma like this. Let's see if this is the information we have to provide or not over here. As of now, there is no data set defined within my data factory, right? Click on new. Where is this data present? The data is present in my data lake. Where did the data lake go? This is my data lake, right? What is the type of data present? It's a delimited format. How do I connect to this this location? Then I have to select my link service, data lake link service. And I'll call this data set as source data set, right? So you saw the three questions. The first was, where is the data present? It is present in my data lake. What type of data is present? It's a delimited text data. How to connect to that data store? Using the link service. So I'll call it source data. Now, when I have the link service, I can specify the path of the file, the actual location of my data, right? So it's present in the data container and it is the activity logs 1 CSV. So I've given the file path itself directly. Click on OK. Done. Source is done. Let's see more configuration. So there is now a source data set created. This data set is nothing but a combination of my link service along with the description of the location of the data and the type of data. I can preview the data from here. So my data is present now. So file path I've directly given. I've actually mentioned which file to pick up. So therefore it knows about the file path here. And this is fine. The rest I don't want to discuss as of now. Let's go to the sink. Sink is where you put your data, right? So after any transformation, so as of now, I pick the data. I could have had another activity here that would be cleaning my data, right? But that is not what I want. What I want is for this data to be put into the data lake again. Now I have source data, but my source data points to a specific file in my container. So I want to create a new data set. All right, this will be the destination data set. This will define where the file will go, in what format it will go, and how will I connect to that location. So the file will go into the data lake. The file will go into the in the delimited text format only, or let's say the file will be converted to a Parquet format during this movement. Let's say one transformation is happening. Click on continue. I'll just call it destination data set. All right. Now the link service. Now the thing about link service is, right, let me show it to you. Every house will have a main outer gate, right? Maybe not in flats. In flats, your the security personnel sitting in the on the ground floor, we can call it that location, the lobby of the flat, right? The lobby of the building. Or in a traditional house, you would have seen it's mainly like this, right? The house is built here. Here you will have the main gate. This could be your garden, right? Something like that. So the link service does not take you inside the house. It will never take you inside the house. The link service will always bring you inside the main gate and make you stand here. So it will always bring me to the source and make me stand at the, let's say, if it's an apartment, it will bring me to the apartment lobby. All right. If it's a villa, it will bring me to inside the main gate, just inside the main gate. That is what the link service does. It does not tell you that now you've entered the main gate of the house, that you have to go to that room or this room, nothing like that. It only takes you as far as the main gate because the authentication happens here. If your guard is sitting at the main gate, he will authenticate. The guard at the lobby will authenticate. After this step, there is no authentication, right? That is why it only takes you to a point once you have authenticated onto that source or that destination. But that is the property of link service. It does not take you to a specific location. Instead, it takes you to just inside that source, right? Or your data store, whichever it is. So when I say link service is required, I'm just going within that main gate. Once I'm within the main gate, file path will help me decide where I have to go. The link service took me to the main gate. Now using the file path, I have to define where I should go. So I have to put this data into the sink container. So I'll select sink and I'll click on OK. That is it. Destination data set, link service is this, and file path basically helps me to define where I have to actually go. Click on OK. Done. Copy behavior, I will say preserve the hierarchy. We'll discuss about it. And this is also fine. Mapping, not required because there is no, schema present at the destination. So there is no mapping required here. Settings, if I want to enable staging, the same staging is there, right? Logging also, if I want to do fault tolerance also, if I want to, skip incompatible rows or something like that, right? Skip missing files, skip forbidden files, like that I can do fault tolerance also, but not required here. No user property is also required. This is fine. So my pipeline is now created. And always, once your pipeline is created, you have to save this pipeline, right? Saving the pipeline could be done by clicking on this publish icon over here. Once I publish this pipeline, three things are getting created: the pipeline itself and the data sets. The link service was already created, right? The integration runtime is already created, up and running. So you are actually creating just three new things: the pipeline and the data sets. All right. The pipeline will contain the activities also, obviously. So successfully published. That means my pipeline has been now created. Now comes the final, not final, but penultimate, uh, artifact, that is to add the trigger. So as of now, we've seen pipeline, we've seen link service, we've seen activities, right? Three of them we've seen, correct? Pipeline, link service, activities, and data sets. Four of them we have seen. Two are remaining. One is the trigger. So I can click on add trigger here. Trigger now will execute the pipeline route right now itself. If I want to create a schedule trigger or something like that, I can do it from here. I can create a schedule trigger, tumbling window trigger, storage event trigger, custom event trigger, right? I can define the custom event, what event it will be. I can schedule the pipeline, right? I can say uh, in the Indian time zone, you start it at a particular time and it will run every, let's say, 15 days, right? At what time do I want this to run? If it's gonna run every 15 days or if it's gonna run every 1 day, right? So if I mention 1 day over here, so this will run after every 1 day at a given time, right? You can specify the time over here and you can specify an end date also to this schedule trigger as of now. But I don't want to create a schedule trigger. What I'll do is I'll close this and I'll click on trigger again and I'll say trigger now itself. So I want this pipeline to run right now. All right. Let's click on OK. Let's see what happens. Let's go to the notifications here and it says pipeline run has succeeded. Now I can click on view pipeline run here, or I can go to the monitor section to monitor my pipeline, right? So let's go to monitor, and within monitor, I'll be able to see my pipeline run over here. So it says copy data activity succeeded. Now there are two things here. One is the input and the other one is the output. What was input to the file, the copy data activity or this pipeline, right? What was the input for this pipeline? It went to the Azure blobs, right? And then let's see, delimited text, right, was taken from my Azure blob storage, right? And within the sink, Parquet sink that I created, right? Because it's a Parquet file, right? Again, blob. So this was the input. What was the output? Data read was some, what is it? I think 20 lakh bytes or something, right? 200 or I think 2000 KB or something like that, right? And data written is 236,320. I think when I open the file location, right, then it will make sense. Even I'm not sure. I think this is bytes itself, right? So this many bytes read, these many bytes written. This is 6 digit, this is 7 digit. So you can see that there is a compression happening, and that is what the benefit of having your, what do you call it, Parquet based file is, right? We've seen that already. File read was one, file written was one, right? So one file was read, one file was written. How many rows were written? Read 5,436 rows of data were read and 5,436 rows were written. All right. How much duration it took? It took 11 seconds. What was the throughput? And then this is the output. This is like the output log of your entire, uh, you know, copy data activity or the pipeline, not the activity, but the pipeline that executed. And then I can see the details, right? Okay, so now it's, I think, 2 MB. Yeah, so it's 2 MB of data versus 236 KB of data, right? So I was correct. So 2 MB of data was read and 236 KB of data was written, right? If I go to my sync here and refresh it, I should be able to see the data here in the Parquet format. So activity log dot Parquet, right? So my data was read in the CSV format, but written in the Parquet format. This is one of the transformation that we've already seen in the past, but I just wanted to repeat it for you so that you know how to do it within Data Factory also. It's the same process, it's not different. It's the same thing, right? So does the artifacts and the component of the pipelines make sense to you? Because this is very important. The components of the pipelines are very important, right? Link services, integration runtime is the compute that was used, right? Purview, Fabric, not required as of now. Not required. Git configuration will do, ARM template will see, right? Triggers will see, global parameters will understand. That is all, right? Obviously, we'll have to do a lot of different pipelines we'll create, right? Some 10, 12 pipelines, different pipelines we'll create with different activities, different data flows we'll create. We'll try and understand what is mapping data flow, how does that work, right? So all of that we'll do. Don't worry. Whatever we discussed today, is that clear to you or not? Any doubts in that? The concept of data factory, the concept of a pipeline, and the artifacts of the pipelines. Is that clear?
Yeah, sure.
Yeah. All right. So tomorrow we'll now see different transformations that you do with the pipeline. How can I transform my data in a different way, in different manners, right? We'll try and see how I connect to, let's say, a SQL database, read the data from a SQL database, and copy that data in a CSV format in another location, right? So that also we'll see. So different transformations, right? Conditional statements, everything we'll see within Data Factory. All right. As of now, just remember to create the pipeline itself, you have pipeline, you have activities which are nothing but transformations within the pipelines. You have link services that let you connect your pipeline to data stores. You have data sets which basically define the location of the file along with location of the data along with the type of data. And then you have triggers that will trigger the pipeline itself. And then you have integration runtime, which is the compute that powers the pipeline. And that is all that goes into creation of a pipeline. All right. So I'm able to see the copy data pipeline running here. Fine. So tomorrow we'll see all of that. Today we'll stop here. All right. Thank you. So today we'll continue with Azure Data Factory, right? Yesterday we discussed about the basics of Data Factory. Yesterday we tried and understand what the Data Factory resource helps you do, right? It lets you move data from one place to the other. Today we'll continue on that path and we'll try and understand how you can move more data, right, in different ways. First of all, the sole purpose of using Azure Data Factory, right, is that you want to copy data from one place to the other, right? So that is why very many projects you'll see, even if you go and find many interviews on YouTube, right, where people have interviewed for Azure Data Engineer, they will always tell you one simple thing, that to move the data from one place to the other, they used Azure Data Factory, right? They would say that they had data from various sources, they had to bring it to the data lake, or they had data from various sources which they had to bring into their database, or they had data in various sources which they had to bring into their warehouse. So in that case, they are using something called as data factory. So the primary purpose, right? And we'll go to transformation and different types of transformation and everything we'll see. But first, we have to understand the two parts of ETL, that is E and L, right? How to extract data from various sources and how to load data to various sources. Once you understand that about the Azure Data Factory, then we can add transformations. There are many. If you want to delete the data as source, if you want to get the metadata, if you want to do a lookup activity in your table, if you want to run a stored procedure in your table, if you want to select specific rows, data flows, right? Data flow transformations are there. So everything is there within Data Factory. But first we'll focus on copying and pasting data, right? Copying data from various sources, putting that data into various sources. Once we get that clarity, once we have that information, we can very well go ahead and then look at the transformations and different other activities, right? Conditional statements, putting multiple activities together, everything we'll see. So anybody has any doubt from yesterday's class where we discussed about this copy data activity that we had? If I go to author within my pipeline, I'd be able to see the copy data. And in data sets, I'll be able to see two data sets here, right? Now, if you want, you can edit these data sets. You can rename them, whatever you want to do, right? You can do that. But when you're creating the pipeline, you always have to keep one thing in mind, that you can either define the pipeline and then the data sets, or there is another way of doing it where you define the data set first. For example, let me open PPT and let me show it to you. See, yesterday the method that I followed, yesterday's method was very simple. I created the pipeline, and within the pipeline, I created my source and destination data set, right? That is one way of doing it. There is another way of doing it, which is you can just simply define your data first. You know where the data is, how to connect to it, and what is the type of the data on one place. That becomes your source data set. When you know what data you have to pick, let's say I know that within the data lake, what I'm trying to say is, when you know that your source data is very simple, right? It's a CSV file present within the data lake. You know the name of the data lake, you know the name of the container, right? And you have a link service already existing for that source, and you know the destination, right? You know the destination, that the data has to be saved as a CSV. The data needs to be saved into a SQL database, let's say, for example, and you have a link service to that SQL database also. If this is the case, right, then you can define data sets also independently, right, before defining the pipeline itself. So I'll tell you what I'm trying to say here. Earlier, I clicked on this new pipeline. I came to my new pipeline, then put my copy data activity here, and then started defining the source and the destination data set here, because this time my source data set will change. This is data sets from the previous pipeline that I had created. Let's say I don't want to use this. I want to use the Parquet data set, because here my source data set was CSV, destination was Parquet. If you remember the yesterday's pipeline that we created. So obviously I'll have to create a new data set here. So what I'm doing, I'm coming to the pipeline and then creating the data sets. There is an alternate way of doing it as well. The alternate way of doing it is you create the data sets first. All right. So what we'll do now, I'll show you how you can create that data set. All right. Independently. So let's do one thing. Let me go to my database. So what I'll do now my step would be to copy data. So now I'll try and copy the data from my one location to another location. This time I'll read data from a Parquet file. Close this. Yeah, I want to read data from a Parquet file, right? And this Parquet file is present in my data lake. And where do I want to copy this data? I want to copy this data into a table within my SQL database, right? So today we'll try and see this particular scenario also, where we want to move data from a file to a SQL database using Azure Data Factory. Let's try it out. All right, step by step we'll go. So I will define first of all my source data set, obviously, because what it will take, you already remember, the pipeline requires multiple things. It requires, first of all, is your data set. So you need to define the source data set. right? And I'll put my source data set underscore P2 over here. Why? Because this is pipeline number 2. So for me to identify which data set is being used in which pipeline, or which data set was created for which pipeline, this becomes really important. Well, that is why whenever you're defining also your pipeline, you give it a code so that in future identification of the pipeline becomes easier, right? If you just start giving English names, right, there is no primary key there. So P2 here works as the primary key. All right, P2 will help me identify. It will be unique for every data set. It will be unique for all the source data sets. It will be unique for all destination data sets, and it will be unique for my pipeline also. So source data set for pipeline number 2. The second thing that I need to define is the link service. Now, link service is optional. Please don't get confused. Optional in case if it already exists. So in case I have the same, I have to pick the data from the same data lake, right? I was going to pick the data from the same data lake. That is why a link service already exists. So this is optional. That means I can select the existing link service also. I can reuse the link service. The third thing that I need in order to create is the pipeline itself, right? I need the pipeline. So let's start creating these three things. Now, if I go to my data factory, I have to create data sets. Now, creation of link services could be done from two places, right? When you're creating link service, you can create it in two places. All right. The first place is when I come to data sets and I say I want to create a new data set. So the moment I want to create new data set, I'll show you both the link services creation in the source and the destination data set. So now my file is present where? My file is present in my data lake. If you remember, I wanted to move the Parquet file activity log01 from the data container in my data lake to a SQL database, correct? Within my data factory, I will say that it exists in the data lake. What is the type of the file? It is a Parquet based data. Click on continue. I'll call it source dataset underscore P2. All right, P2 for understanding that it is pipeline. It is going to be used in pipeline number 2. Link service already exists. So this is the first place where I could create the link service. If it does not exist already, I can click on new and create one over here itself. So the first way of creating the link service is to create it, within my data set. When I'm creating the data set, at that time, I can go ahead and create it. If not, if it already exists, I will select it from here. Then if I browse, it will show me the containers. So it is in my data container and it's the activity log01 Parquet file that I want to copy, right? Click on OK. From this connection that got established, it will get the schema also of the file, right? So this is my source dataset P2. If I want to test the connection, if I want to preview the data, I can do that. All right, so this is my Parquet data present in my activity log1.parquet file. This is the link service which is being used, right? So this is the first way of doing it. So my data set is created, and you see, if you remember, when we were doing dedicated SQL pool and serverless SQL pool there, when working with Parquet files, we had to mention the compression used or the compression type. So there is two, gzip and snappy, right? Generally, we use only these two. So let it be snappy, right? Snappy codec is very well sufficient to read Parquet files and to encode Parquet files also, to decode them also and to encode them also. Snappy codec will help you do that. So my data set is created. I'll publish it to save it. Let me publish it. Now, the second way of creating the link service is to go to the manage section. When I go to manage section, I have a section there for link services. I'll open link services here. And since my destination is now a SQL database, so do I have a link service connecting me to that SQL database? The answer is no.
No.
So yeah, go ahead.
No, I said no. Yeah.
Fine. So the link service does not exist as of now. So I need to first create that connection to the SQL database, right? Before I can put my data into the SQL database, I need to be able to connect to that SQL database. So I'll click on new, and now I'll say that my location is a SQL database here, Azure SQL DB. I'll select it. I'll click on continue. I'll call this NIC SQL DB linked service. Oh, it's not typing. Let me do it over here. NIC SQL DB linked service. All right. So this link service will help me connect to a SQL database because I have selected SQL database. So it will ask me SQL database specific questions, right? Because when I want to connect to different data stores, I will have different types of questions. For example, if it's a data lake, it will ask me for the data lake location, or the URL it will expect would be of a data lake. It will expect account key, right? The access keys that we had. But when I select it to be Azure SQL database, then it will ask me SQL database specific questions. For example, server name. Now, the server name would not come when I'm creating the link service to the data lake because there is no server there. But in the database, there is a server. So I'll select Visual Studio Code. Now, version, I will let it be 2.0, which is recommended for the link service for SQL database. All right, this is a new version. You can select one also. It also works in the same manner. Nothing different, right? I'll select the server. So NIC SQL Server was the server that I had created. If you want to see in my database, NIC SQL Server is where this database is hosted, right? The server name is NIC SQL Server.database.windows.net. So I'll open my query editor, and there are chances that it will not let me connect to the database if my IP address has changed. All right. So if in case my IP address has changed, it will deny this connection. If not, this will be fine. All right. So it says it's not available as of now. Let's try and debug this situation. If I go to overview section now, and if I go to my server, so you can go to the server just by clicking on the server name. Now this is where you will have to do some hard work, right? Because of the security features. If I go to security and I go to networking, in public access, I will have to add my current IP address. Now, if you see the previous IP address that my system had, right? Because it's a dynamic IP address, the public IP address that you get, right? It's a leased based IP address, and your internet service provider will change it regularly, right? So the last time when I used this database, I think it was last week. At that time, this was my IP address. And the current IP address that I am using is this one in the box here. So what I can do, I can add it and save it, right? If you don't want to, let's say, do this every time, you can add a firewall rule itself, right? You can give a range of IP address. See, generally what happens is when you're working with IP addresses, the first 3 bytes generally remain constant. It can happen on the same network, it can happen sometimes. And this last byte changes, right? So when I say byte, I hope everybody understands that IP addresses are 4 bytes. This is byte number 1, this is byte number 2, this is byte number 3, and this is byte number 4, right? So I can give a range here. I can do 0 to 255, right? So now it will allow all the IP addresses from 0 to 255. That also I can do if I want, right? So I can save that also. So this will also work for me. Why? Because my IP address falls in between of this range. All right. Fine.
Yes, I have one question here.
Yeah,
This
go ahead.
IP address is a static in real time also. It will be dynamic, or it is going to be project specific static.
See, configuration of IP address, whether it is static or dynamic, depends on people who are doing the administrative task. All right.
Okay.
Within Azure, you get both the types. All right.
Okay. Got it.
Within Azure, you will have a static IP address also, and you will have a dynamic IP address also. So if I show you and I go to public IP, there's a resource called public IP address. All right. So if I go to public IP addresses, let me create a new one. So you have two options here when you create a public IP address. Standard is, I think, the one that they're giving now. So within standard, you get static. All right. Within standard now, they're giving static. I think they got rid of the dynamic some time ago. Because basic SKU is not available here. So within basic, I get dynamic and static both. All right. So dynamic is only available for basic SKU. So static means it's a higher cost because I'm giving you an IP address that will never change for you, right? So both are there. Static is also there, dynamic is also there, right? So you can.
But we created a static one or dynamic one? Which one we created for this?
For my
work?
See, when we
Yeah.
created, right, we were creating it for virtual machines. As of now, virtual machine is the only resource that we have connected to IP address, right? So there are a handful of resources in Azure that require IP address. All right. Most of them, they don't require IP address. Most of them would work with, if I show you, see, a virtual machine requires IP address. Then there is a firewall resource that requires an IP address because firewall will also have an IP address, right? When people want to connect to your resources, they will first connect to the firewall. A VPN will have a IP address, right? So there are multiple resources that have a IP address, but there are some resources that don't have an IP address. For example, my storage account. If you see, storage account has something called FQDN, fully qualified domain name. Storage account name .blob.co.windows.net. They have a URL. All right. Similarly, your server, which is the SQL server that I'm talking about, right? Or your Synapse SQL pool. They also have a SQL server, right? So they have what you call is a fully qualified domain name. If I go to my SQL server, right, I have added it. Let me go to the overview. You will see over here, let it load. Let me go to the database itself. I'll show you. This is the URL of your server. This is what you get. You don't get an IP address, right? So I'm not talking about Azure IP addresses here. This IP address that you add here in the server is your IP address. All right. Now, if you see, last time with the IP address that I had added, it was something else. And this time the IP address that I have added is something else. So that means the IP address is changing. Yes or no?
Yes.
And this is my IP address. When it says client, this is my system that I'm using, its IP address. All right. So when I'm trying to connect to the SQL database, the connection is being established from my machine. And in my machine, I'm using this IP address. So I will be allowing this IP address to connect to the SQL server because I want to connect to it and explore the databases. Clear?
Yeah, clear.
So this is your IP address and this is dynamic. And in the standards queue, you already saw that there is an option for static IP address also. But that is not something that we have to worry about. It's the job of network administrators and Azure infrastructure administrators to worry about, right?
Correct.
Yeah. Yeah. Now here, if I come back to my data factory, I wanted to connect to my SQL server, right? So SQL server is already there. I'll select the database name. I have selected NIC SQL server, and within my NIC SQL server, I have hosted this NIC SQL database. So I'll select that. Authentication, I'll do the SQL authentication. Let me remember what the username was. I think it was SQL admin or something. If I go to query editor, it is SQL admin. I'll copy the username and I'll put the password that I had kept for this login. But before that, let me open the SQL database myself also. It should be able to connect now. Yeah. So now no issues with the connection. If I go to the tables, I would be able to see some sample data here, but I want to create my own table. All right. I'll not be putting data into these tables directly because I want to create my own table and then put the data there. So to do that, I'll come back here first of all. Right. We'll do that later. First, let's create this link service that you are working on. And that is all that which is required. If I click on test connection, let's see what happens. So connection is successful. I will create this. Now, in case you get the error that this connection was not successful, what you have to do is you have to go to your SQL database again, right? So you go to your SQL database, open it, go to the SQL server, right? And here in the networking section, please check this exception. Allow Azure services and resources to access this server. All right. Sometimes if this is unchecked, right, then here this link service, right, that we have created, the SQL database link service. If I try and test the connection, it is giving successful because I have a managed identity already created. I got the details from my SQL database here itself. That is why it is getting successful. But if you, in case you find it, difficult to connect to it, make sure you have saved this particular exception here, right? This is fine. Link service is now working. So those are the two ways of creating the link service. First, when you create the data set, create the link service there itself. Second, you create the link service by coming to this manage section and then going to link service and create it. So my source data set was created within the pipeline, source data set for P2. Now let's create the destination data set. But how can I create a destination data set until and unless I have the table ready in the SQL database? Do you understand that? Is that clear?
Yes. Yes.
First, I need to have the table where I need to put the data. As of now, I don't have the table, right? So what I'll do, I'll go to my query editor and I'll put the code to create this table. Create table pool activity log. Let me run this. Query succeeded. If I come to my tables and I refresh my database from here and I go to tables again, I should be able to see pool activity log here somewhere. See, pool activity log table now exists. So these are the columns there. So my table has been created. If I want to see the details of my table, I can just run a simple select query, select star from pool activity log. Now, SQL as a language, is it case sensitive? Is SQL a case sensitive language?
No.
It's not. So select star from the table will work exactly, right, as select star from pool activity. Both of them will give you the same result. If I show you, let's run this first one. So there are no rows here. If I run this, it will do the same thing. There are no rows here. So one thing you have to keep in mind that SQL is case insensitive. If I make some changes here, make it a capital E, make this a capital F, does this affect, or this will also work in the same way?
It works.
It works, right? Again, if I run this, I'll get my details. So now my table is there in the SQL database from what I had drawn here. The table is ready here, but I don't have the data set as of now. I'll have to create the data set for it. My Parquet file is present in the data lake and I have created the data set also. Let me go to Data Factory now to create my destination data set, the data set for this SQL table. So I'll click on data set again. I'll select new data set, and this time it is my SQL database. So it's Azure SQL database. Click on continue. I'll call it my destination data set for pipeline number 2. Simple. The link service, we already created an IC SQL DB link service. I'll select that. Now, which table you want to put your data into? You can select it from here. I will have the pool activity log table right here. I'll select it, click on OK. Right? Now everything is there. I can preview the data also here. Click on preview data. You will be able to see empty table, right? Correlation ID, operation name, everything is there, but it is empty. There's no data as such present in the table as of now. And this is what we need to work with. We need to put the data over there. If I test the connection to my SQL database, I can do that here. Connection is successful. So everything works. If I click on schema, I'll be able to see the entire schema of my table, right? And if the schema is not visible here, you can just click on import schema, and through the link service, through the connection that you have established, it will fetch the schema here, and you will be able to see the schema of your table. If I go to source dataset and I open the schema, I'll be able to see the schema over here also, right? Now, if I want to import the schema in this case, because it's not a table, right? It's either from the connection to the table or from a sample file. Let's say I have a sample file, I can import the schema from there also if I'm unable to import the schema from the connection, right? But it's already there. Now let's publish the destination dataset also. So when you publish now, since source dataset was already published, so whatever new has been created or whatever edits have been made or whatever changes have been made, only they will be visible here. Let's publish this. So what do I have to do now? I need to now copy data from my file that is in storage account, NIC data lake, container, data container, activity log 1 Parquet, right? So this is the file from which I need to pick the data, and this SQL database table dbo.pool activity log is the one that I need to use. So I think there are two databases here. We are currently, you can use a qualifier like this, or you can just give a statement like use, right? Use the database name. So you can use the database name and that will become your default database name. So now data sets are created. So this is another way of creating pipeline that I wanted to talk to you about, right? So I told you first method, go to pipeline. And what I'll do is I'll change the name of this pipeline. I'll call this underscore or P1 underscore. P1 underscore copy data, right? So we understand. And in these data sets also, we'll change it later on, not required as of now. I'll create a new pipeline now, right? I'll call this P2 underscore copy data from Parquet to SQL, right? And I'll save this because I'm copying the data from a Parquet-based file to a SQL database now. Obviously, copy data activity is the one that we have to use for any extract or load functionality. This is your way to go. Copy data activity is the E and the L of ETL. The rest everything is T. Rest everything that you see here is generally T. All the activities that you see, right? If I come here, the activities, data flows, general activities, these are all transformation or getting information. But extraction, that is moving the data into my location where I want to process it, and loading the data into the destination will always use copy data activity. Now, like any other pipeline, I need to give some details here also. I'll call this copy data Parquet to SQL. That is the name of the activity that I've given. Coming to source, now I don't have to work from here. So this is the other way that I wanted to talk to you about, that now I don't have to go and create a new data set. I already created the data set. I knew where my data is, in what format my data is. So I can just simply select source dataset underscore P2 and it will come here eventually. I can go to sync and I can just select the destination dataset P2. All right. Now here you will get some configuration. Insert, upsert, running a stored procedure. If I want to run a stored procedure before I start writing, I can select it from here. Upsert is basically updating and insert together. We'll come to that later on. As of now, it's just insert. Bulk insert, table lock. So if you are inserting very high quantity of data, do you want to lock the table until unless the entire copy activity has been completed? You can select yes or you can select no, right? So when you select yes, it will not perform any other activity or it will not perform any other query on the table until unless this is particular created. Table, I'm using the existing table, right? Any pre-copy script that I want to run here, right, within my database. So I can do that also. Auto create the table will create the table with the same schema, right? The source schema into my database. But I already have the table, right? Not required. If I go to mapping, I will click on import schema now. And this is where Azure Data Factory will automatically map the columns of my table. So now you see it has automatically mapped it. If there is an incorrect mapping, let's say I want resource group to go into the resource, right? I can move it down, I can move it up, or I can select that this value from the resource group should go into another value, right? As of now, there it shows no result found because all the columns have been mapped. So no column remains. If let's say I delete this, now you'll see resource group and resource both are remaining, right? So I'll import the schema again. So one by one, you can start mapping all the columns. So resource is now mapped. If I delete resource, resource group, the resource type column, rest are mapped. If I come here, right, I'll be able to see the columns which have not been mapped as of now. Here also, I'll be able to see the columns which have not been mapped as of now. So I can say event initiated by should go into the column resource. I can do that. And now here I will be able to see event initiated by also because it remains unmapped. But Microsoft Azure will automatically do the correct mapping by looking at the column name. And in this case, the column names are same, so it does not have to do anything, right? And the mapping is successful. That is it. My pipeline has been created. I will publish this. Yeah, so it's published now. Any doubts until now? Until this step, any step that you are not comfortable with, you did not understand, data set, link service, anything that is creating a problem for you. Now it's time for us to trigger the pipeline. So I'll click on add trigger, trigger now, click on OK, and the pipeline run starts. Let's go to the pipeline run. So it brings us directly to the monitoring section. All right. So I'll go to the pipeline runs again. I don't know why it's not updating immediately. It should, it ideally does. All right. So I'll go from here only, then view the pipeline run. Okay. So it says the pipeline run has succeeded. All right. My copy data Parquet to SQL has succeeded now. I can see the input. Input was a Parquet source, right? It was present in my data lake. All the information, you can find it over here, right? It's all present here. And output is my files read, right? Data read, data written, files read, rows read, rows written, and duration for this, uh, transfer. How to validate this transfer? There is only one way. I have to go to my SQL database and check whether my table has been populated now or not. So if I run the query now within the result section, I should be able to see the data within my table now, right? So this is the data which has been copied from a Parquet based file to my SQL database. Now the same thing I want to show you within Synapse also. So within Synapse, data storage is possible in which SQL pool? Dedicated or serverless? Dedicated only, right? I can only store data in the dedicated SQL pool. Serverless SQL pool does not allow storage of data. So I'll go to Synapse, right? And just giving you a recap. And here, if you want to create a dedicated SQL pool, you have to go to the manage section on the left-hand side. Go to SQL pools. Data pool is one that we had already created, but it is paused right now. So what I'll do, I'll resume it. So last time we did not delete it, we paused it. So it's getting resumed now. So this resumption will take some time. And in the meantime, right, I want to show you one more thing about the data factory. Now, this time, my destination will change. All right. Why my destination is changed? Because it will not be table anymore. It will not be a SQL database. It will be a table, but not in the SQL database, obviously, right? So this time, now it is dedicated SQL pool within Synapse. So now I want to move data from a Parquet data lake to Synapse. My question to all of you here is, do I need to change the source data set now?
No.
No. Why? because I'm using the same source data set, so I can reuse this. That is the beauty of Azure Data Factory. You can reuse your data sets. All right. If the same file needs to be copied to multiple locations, I can define the source and I can reuse that source. But now the destination, for the destination, do I have to create a new data set?
Yes.
Absolutely. Why? Because as of now, I have multiple data sets created here within Data Factory. If I go to the author section, there are two destination data set. One is for my NIC data lake itself within the sync container, and the other one is for the SQL database. I don't have a destination data set created for my Synapse dedicated SQL pool, right? Now, as of now, this destination data set is sync folder. If my destination was not the sync folder and was the target folder, do I use the same data set or I create a new data set?
We need to create.
We need to create another data set because one data set will only point to one location and that is it. If the location changes, I cannot reuse the same data set. So I can reuse the source data set because the file is the same in the same location present in the data container, right? Because I need to pick up the same file from the data container. So my source data set can be reused, right? But since this is Synapse, my destination data set will now change. So data pool needs to come, into effect. It needs to start before we can proceed. So we'll just take a 2-minute break. That I first need the table here. Until and unless I have the destination ready, I cannot create a connection to it, right? So first thing that I need to make sure is that the destination table is created. So I'll go to my Synapse develop section. Within this, I have multiple SQL scripts, right? If I go to the data section, I'll be able to see my tables also. I think I would have created a pool activity log table here. Let's see. So there are chances that the table might already exist. If not, we'll create it again. Let's just see. It's taking so much time. So pool activity log now exists here with the same columns that we require, right? It'll have the same columns. So what I'll do, I'll go to develop section. I'll click on a new SQL script and let's check first of all whether table has data or not, right? So I'll say select, typing, select star from pool. Oh my God, I do not remember. Okay, everything is captured, right? Let me go to the SQL script again. Pool activity log, capital P. So this is case sensitive, right? The name of the table and everything. Pool activity log. Let's see if there is any data present here. We'll select this, run it. Can anybody tell me why I'm getting this error?
Maybe IP address change.
No. Here IP address not required because I'm trying to access data which is present in Synapse from within Synapse. So there is no connection being established here, right?
Using master database.
Absolutely correct. I'm not using the data pool. I need to be in my dedicated SQL pool and then run the query. So these are minor mistakes, right? Good that you caught it. We're trying to access the data after a very long time, right? All right. So there is data. Now, what query should I run to delete the data from this SQL database? Who's going to tell me?
Table or drop
Hmm?
table. Delete
If we
table.
drop the if we drop the table,
It will remove the structure as also.
it will remove the schema also, right? A very simple query to delete data.
Okay.
It's delete from pool activity log. If I run this, let's see what happens. Delete from table name will delete everything in the table. It is done. Let's do select star now. So now the table is empty. Somebody said truncate also.
Yes.
Who said
Can we
truncate?
use I said
Yes,
truncate?
yes. Truncate also. Truncate will also delete it. So now my table is empty. I have an empty table within my dedicated SQL pool to which I need to copy my data. Let's do one thing. Let's make it a bit fun. Let's now copy data from SQL database, not the Parquet file, but I want to now copy data from my SQL database to my warehouse. That will also come, right, where you have to move data from SQL to a data warehouse, right? SQL is my Azure SQL database here, and data warehouse is nothing but my Synapse, right? Dedicated SQL pool is nothing but a data warehouse. So let's try this. So this will be my pipeline number 3. Here I will have P3 underscore source data set and P3 underscore destination data set. Let's see how it works. Are you all ready for this? Do you understand what we are trying to do now, everybody? We move data from data lake to data lake. We move data from data lake to SQL database. Now we are going to move data from database to a data warehouse. Various scenarios. Let's see. SQL database is there, right? Synapse, within Synapse, I have my pool activity log. Let's come to data factory now. Now I will go the prior method, that is to create the pipeline and then define the data set. So I'll go to pipeline. I'll call this pipeline number 3, P3 underscore copy data. Why is it not typing? P3 underscore copy data SQL to warehouse. Or let me say SQL to dedicated SQL pool, right? So that is my third pipeline that I'm creating. Let's see. I need to copy the data. So I'll use the copy data activity here. Very simple. Let the name be this only. I don't need to change the name. Source. Now, do I have a source data set for this?
Yes.
I can use this destination data set because it points to the same table. Yes or no? Even though I have named it destination data set, but what is it? It is nothing but my SQL database and a specific table within my SQL database. It points to a specific table. So I can reuse it. But let's create a new one because the name might be confusing to you. You may think, why am I using destination dataset in the source settings? It's just the name that we have given. All right. But it points to the same data that I want to pick. So I can reuse it. It's totally fine. But let's create it again. I'll go to the SQL database, click on continue. I'll call this my source SQL DB. Not like this. I'll call it P3 underscore source data set, right? This is what we wanted. Link service to my SQL database already exists. Table, I need to pick up the data from pool activity log table, right? So let it load the table using the link service, reload it, and now I have the pool activity log table. So my data will be picked from pool activity log table in my SQL database. I already have the data here, right? Fine. Click on OK. Coming to the destination. Now, there is no destination data set that points to this data pool within Synapse. So I'll click on New and I'll select here Azure Synapse Analytics, right? I'll go to Azure. Now, within Synapse, there are multiple places. You can select Synapse Analytics over here also, and there is one more. Okay, I think they removed it. So they had one dedicated SQL pool also over here, right? They're always making the changes. It's fine. I'll call this Synapse linked service. Sorry, this is the data set, right? So I'll call it my P3 underscore destination data set and the link service. I'll have to create a new one because for Synapse, there is no link service already that exists. I'll say Synapse link service like this. Auto resolve integration runtime is the default compute that we get, right? Version 2.0, let it be. The Synapse workspace is within my subscription. And now This is the server for my Synapse workspace. All right. There are two SQL servers here. One was created for my database and one was created for my Synapse workspace. So I'll select the SQL server which hosts my Synapse workspace, that hosts my data warehouse. Database is data pool, right? And username, I'll have to go to Synapse now. Let me open Synapse from here to get the username. I'm not sure what the username I had kept for my Synapse SQL server. So you can get the details here. It's not a problem. I'll show you. When you come to the overview of the Synapse workspace, let it just load. If you see, the SQL admin username is SQL admin user. You can copy it from here and I will paste it over here. This is the username for this SQL server and the password that I keep for all my databases. Fine. This is done. Let's just test the connection. Successful. Click on create. In case this is not successful, you can go to Synapse and you can allow access to, if you go to identity and access management, I can give access to my data factory resource, right? So I'll click on add a role assignment. Privileged roles is a contributor. I want to give contributor access onto this Synapse workspace. To whom? To basically a managed identity, because Azure-based resources come under managed identity. It's not a user, it's not a group, it's not a service principal. Select member. I'll select my subscription, select the managed identity. It's my data factory, and I'll select NIC data factory and give that access. So for me, the access already exists because it's within my subscription. If not, I could give access to it from here. Coming here, let's select the table name. There's a pool activity log table name within my Synapse, right? When I'm creating the data set, there's only one table there. So I'll click on OK. So my destination data set is also now defined, right? I can use the copy command. I can use the bulk insert, whichever one I want to do, right? Bulk insert will also work. Copy command will also work. All right. And no other configurations need to change. Within mapping, again, I can check the schema mapping again over here. So everything is fine. So I'll publish this. Now, three things are getting published. What happened? All right. I think we'll have to create a data flow for this. All right. Yeah, I got the issue. They have made it only possible for data flows. So what we'll do is copying data from SQL databases. We'll try it with data flow. I think they've changed it now. Synapse, they've introduced something called as Synapse link for SQL. All right. So Synapse link for SQL. Earlier, we used to do it with this only. I think it's a recent change that they've done. Yeah. So post the release of Synapse link for SQL that happened in May, I think they have deprecated the previous option. So fine, we'll see Synapse link for SQL also. Today, for this pipeline, let's do one thing. Let the source be my Parquet file itself. Let it be the Parquet file. So from Parquet file to Synapse, right? I'll show you how you can move data from SQL database to Synapse also. That will be done using data flows. All right. So I'll show you, I'll give you a hint. This is something that we are going to use. So this is fine. Let's publish this now. So publishing is successful. Let's add a trigger. Let's trigger this now. Click on OK. All right. While this pipeline is running, I'll just quickly show you what we will use to move data from SQL to my Synapse dedicated SQL pool. So this is where we add the source. So the source would be now my P3 source data set, that is my SQL database, right? And here as a sink, I can put my sink to be P3 destination data set. It's not created as of now. Wait, okay. I need to refresh this. Okay, so I'll come back to this sink over here. We can click on new and it would be my Synapse Analytics. Click on continue. Link service, I'll use Synapse. Table, I can select DBO pool activity log. Click on OK. All right. So what I'm doing, taking the data from my table and putting it into my destination data set into this table. All right. So I'll this is called as a data flow, right? This is a completely separate topic. We'll have a different discussion on this. But as of now, let's go and check whether my pipeline was able to execute or not successfully. If I go from here, open my pipeline, it says the run is successful. If I see the output, I can see uh, data read, data written, rows copied from my Parquet-based file into my Synapse. Now, if I run select star again, I should not be getting the empty table, but instead I should be getting populated data over here. All right. So this is a way of copying data from data lake to Synapse. Now here, right, it did not work because I think they've deprecated the copy data activity for Synapse. So what we use data flow, right? This will pick up the data from the source. So you can see it is copying 11 columns and it is pasting those 11 columns into the sink into my data set, right? So data set, I can open and show it to you that this is a pool activity log table. Now, if I want to run this, all I have to do is I have to go to the pipeline, create a new pipeline. In transformation, instead of copy data, let me use data flow. And within data flow settings, I can select the data flow that I have created, data flow 1. That is it. Parameters not required. All right. So this will also work, but I don't want to confuse you with data flows as of now because this is a topic for later on. So I'll remove this pipeline, right? So from what we discussed today, is everything clear? How to move data? We saw several things, right? I think we saw how to move data from data lake to your SQL database. We saw how to move data from data lake to Synapse, right? We tried to move data from SQL DB to Synapse, which we failed at, right? So we'll find a solution for this, which is already there, the data flow that I showed you, right? So any doubts until this point? Now, up to now, you should be very familiar with data set, link services, pipelines. Yes or no? Are these three things clear to you? How do you define source and destination data set? How do you define link services? How you create a pipeline using these two, right? Integration runtime and triggers also, right? Even though we have only seen trigger now, so partially to run the pipeline currently, trigger now button you've seen. Integration runtime, triggers, other types of triggers, schedule trigger and all. This is still remaining. You may not have a complete clarity on this. Where does this compute come from? Can I replace this compute? Can I have some other compute? So we'll see all of that, right? If you go to manage section, if you go to integration runtime, yes, you can have your own compute also. Azure or self-hosted integration runtime. So here you can use Azure. Use this for running data flows, data movement, external and pipelines activities in fully managed serverless compute in Azure, self-hosted. Use this for running activities in on-premise private network. If my data is present in an on-premise environment, right? How do I copy it? Where will the compute come from? So that is self-hosted integration runtime. This also we'll see. Always clear your environment. All right. Post your usage. So with that, we'll stop here. We'll continue from here tomorrow. We'll see some more data movements, as I told you, data flows and all. And then we'll see transformations. How does Data Factory transform your data? So that is where we'll see a lot of different activities, right? As of now, if you see within Data Factory, we've only used a single activity, right? That is the copy data, but we'll see more. We'll see mostly delete, get metadata, lookup, stored procedure. We'll already see, right? There's a section for it. Setting up a variable, we'll see how you can do that as well, right? Set variable and all will be definitely used when we are doing this tumbling window trigger, right? It's a concept. We'll understand it first and then we'll run it as well. And then conditional, if condition, for each, filter, switch, this also we need to understand. And the best part here is data flow, right? When you go to data flow, that is where you do a lot more transformation, right? Once you add the source, right, you can add multiple transformation. You can create a new branch, you can create a join, union, lookup, create a new column by creating a derived column, select query, running aggregates, add a surrogate key column, right? Pivots, unpivot. There's a lot of things here. Flatten, parse, stringify, converts your JSON or CSV data, right? Parse your string data into JSON or CSV. Choose columns to flatten and flow to the next stream, right? We'll see what this is. Filtering, sorting, and then sync obviously here, right? So there are a lot of things for us to cover in Data Factory. There's a lot of transformations that we need to do. Most of them we'll do it in the class itself. All right. So thank you for joining in today. I'll see you guys tomorrow. Thanks a lot, everyone. We'll begin with today's session. Until now, we've seen some basic functionalities of what Azure Data Factory can do, right? Very basic understanding of what Data Factory is capable of, how it works, right? How it can copy your data, move your data from one place to the other place. Now, today, what we'll try and understand is, first of all, a component of it that is called as the integration runtime, right? So until now, I've just given you a brief idea that integration runtime is nothing but the compute that works behind the scene. Now, understanding this compute is also very important. All right. And where does this compute come from? How you can use it, right? Can you reuse it? Are you going to use the same compute again and again? These questions you will have. Factory, let me launch the studio. One thing, that you see here is that there is this orchestrate button here, right? Lets you create the pipeline. It will directly open a creation of a pipeline for you, the orchestrate button, right? Uh, Transform data will bring you to data flows, right? Because in Data Factory, the higher level of data transformation is done through data flows. It's done through something called as data flow. I'll show you a very simple data flow today, right? And then this is the ingest button, which is nothing but the same way we created a pipeline in Synapse. Now, this ingest button and the creation of pipeline from here, author section, is the same thing, right? Do you guys remember? We did this in Synapse. I'll show you quickly again. So if I'm using the built-in copy task, run once. I don't want to schedule it. I don't want to use tumbling window. I don't want to discuss all of that right now. Click on next. Select the source type. So it's my data lake storage, right? There's a link service that already exists for it, NIC data lake link service. And which file do I want to copy? I'll just bring it here, go to my data folder, and I'll copy the second Parquet file that I had, right? So this is the file that I want to move, activity log 02.parquet. Click on OK. So this is done. Source type is data lake, connection is this. Now, once you have the connection established, you can quickly go and check for the file that you want to move. Now, it could be a binary copy also, it could be a recursive copy also. I'll explain you recursive copy when we, cover the folder, movement of the folders of data around. But let's this be a binary copy as of now, or you can select, let it be recursively also, because here we do not have many folders, but the idea behind recursive copy is that you go to folder one, then you go to the folder within it, then you go to folder within it, then you pick up the file, and then if there is no other folder, you come back to the parent folder, you pick up the file. If there is no other folder to go into, you come back again to the parent folder. So that is how recursively worked. This is fine. Click on next again. And the configuration, what is the type of the file? It's a Parquet file, and compression, we'll have to select something. I'll select Snappy Codec. I can preview the data over here. I can see the schema of the data here, right? Close it and click on next. So this was source configuration. Now we come to the destination, right? This is the third step. Where's the destination? Let it be also a data lake storage. The connection, I'll use the same one. And the path in which I'll paste this is the target container. I don't think there is anything in the target folder. Let's open it. So it's an output.csv is there, but let's just copy that. And copy behavior, I'll preserve the hierarchy of the files, right? If multiple files are getting copied, we preserve the hierarchy of the files. So this is fine. Uh, Nothing much required here, right? Uh, Click on next, and okay, so it's now pasting the file in delimited text. I don't want it in delimited text. I want it in Parquet format only, and the compression we'll use is Snappy Codec. Click on next again, and this is also fine. And finally, if I click next, it will trigger the pipeline. So this is one way of creating the same pipeline, right? So once this pipeline is created, I'll show it to you. This is basically validating and publishing the pipeline itself. And if I come here, I go to my data lake storage, which is an IC data lake for me. Containers, still getting validated. We'll wait for it to be completed first. We will start it again. It's still working. All right. So validation is now done. It will create the data set, it will create the pipelines, and it will run the pipeline. So we'll just wait for it. Yeah, so this is done, right? Very basic pipeline. It's, within Synapse also we saw that from the main page, there is this section to, build these small, very quickly you can build the pipelines here. The UI is also a bit different. But if I go to the monitor section, right? Let me go to the monitor section. Will I not see the pipeline run here? Let's see the data. I'm able to see the data here. Pipeline run, what happened? I don't know why it's not showing the previous pipeline runs. Only one is showing here, the one that I created right now. So I'll open it, and this was the pipeline that got created, copy MB, right? Name is copy pipeline RNB. So if I go to author section, I'll be able to see this copy pipeline RNB, and everything is the same. There's a copy activity here, there'll be source defined here, there'll be sync defined here. So it's basically the same thing, just that you create it from the home page here through the ingest button. It will directly create a copy data activity for you. Orchestrate will directly open a pipeline for you, right? It will not take me to this UI. It takes me to the same place, but with this UI. All right, it lets me do the same thing. And then transform data basically takes me to data flows. What are data flows? How they work? We'll definitely see that. There are a lot of transformations that you can do with data flows. Until now, everything is clear or not? Yes or no? I don't think I need to publish this. This pipeline it's a redundant pipeline anyways. What I wanted to discuss today with you is this integration runtime, right? So this is something that we want to understand. Let me just open PPT. Integration runtime. We call it Azure integration runtime because the type is here Azure. All right. You will see a different name here. You will see, auto resolve integration runtime, which is also fine. You can call it auto resolve integration runtime also, but the name that we generally use is Azure integration runtime. All right. Now this is basically the compute that powers my pipeline. All right. It powers my pipeline. It provides, it basically provides the compute which is required to do the transformation, to do the heavy lifting, to move the data from one place to the other, right? And in our situation, it is, provided by Azure itself, right? So this is one serverless compute. When I say serverless, you already understand that serverless compute means that there is not going to be, a dedicated compute here. We are not going to mention that this is the compute that we want, right? Now, in very simple terms, the helper, the data helper is my integration runtime, right? Why do we need to move data? We've already discussed about it, right? Data is a piece of information. It could be anything. It could be, the data, the text present inside a book, the number present in a sales report, the photos and videos that you click, the list of, let's say, birthdays in your family, if you noted it down. All of it is data, right? And especially in the world of business, data holds a very significant, value or importance. A company, might have data about its customer, product, sales. We're already seeing that, right? And this information or this data, it helps the company to make, good decisions. Now, why do we need to move this data? That also you understood. right? Through Data Factory, we are doing it, and it's basically, I want to bring the data to a single place where I can share the data, I can create backup of the data, I can analyze the data, right? So basically, for multiple purposes, I need to move this data. The integration runtime is your helper that helps you move this data. When you need to move a lot of heavy boxes, right? When you want to move this data, right? What comes for your help is Azure integration runtime, or we famously call it AIR within my data factory. All right. Within data factory, we'll sometimes call it AIR as well. So when we need to move these data from, let's say, one place to the other, right? What do you do? If, let's say, there are a lot of boxes, right, that I want to move from my old house to a new house, what do I generally do when I have a lot of boxes? I get a packer and mover, yes or no? What do they bring with themselves? They bring all the manpower, they bring a specialized vehicle, a truck or something, they bring all the equipments which are required to pack the items, right? Bubble wraps, tape, um, boxes, they'll bring everything. So the packer and mover is the company that will come with the trucks, equipment, workers, labor, and they will get the job done for you, right? Here also, for the packer and mover, you will define the source. You will tell them that this is the address where you have to pick the data from, and you will also define the address or my destination that you have to take it to another place, and this is the destination, right? And you define the configuration also, that the source is basically a flat on the fifth floor. So you come prepared, you'll have to move data from the fifth floor, and this is the flat number, and this is the type of data that I have. I have a sofa, I have a fridge, I have a washing machine, I have a bed, I have an AC. So you define the type of data, the location of this data, that is your source, right? And you let the packers and mover know that. And the destination also, you do the same thing, that I want this items or these items to be taken to my destination. So exactly same thing we are doing in the data factory also. We are defining the source and we are defining the data. We are defining the source, saying that the data is present in this particular location, in this particular resource. In our case, sometimes it was a data lake, sometimes it was a SQL database, sometimes it would be a warehouse of sorts, right? Sometimes it could be an Amazon S3 storage, right? So what you see in Azure, right, the data lake that you see, the same thing in AWS is called as S3, right? So ADLS, Azure Data Lake Storage, is equivalent to Amazon S3. It's the same concept, right? The storage account. So this is how you define it, right? Now, integration runtime is basically the packer and mover in data factory. This is the job that the Azure integration runtime does in reality. Understood? Any doubts? Any doubts here? In the world of Azure, in the world of Azure Cloud, when you need to move your data, the helper that comes to, help you on this movement or data, even if you have to transform the data in the midway, right? Sometimes, what do you mean by transformation? So basically what will happen in the source, right? You may have a box of a new bed, right? Which might need to be assembled into the new house, right? So that assembling is nothing but the transformation of, um, you know, um, how you get it, right? I think most of you would have seen how you get now products in IKEA. They would give you all the individual components of it which you need to assemble, right, on your own. So that kind of data also you may have, right? Those kind of items you may also have. So that is your transformation of data that happens in the uh, this time this will happen in the destination. So it's more of an ELT, ETL, right? More than ETL, it's an ELT, right? You extract, you load, and then you transform it in the other place. So this helper is part of the bigger service. AIR is a part of bigger service called Azure Data Factory. And, in short, Azure Data Factory is where you plan to move your data. Integration runtime is actually the helper that does the moving for you. Data can live in many different places, right? Where does the data live? The source could be a lot of different places. And I'm not talking about flats and all those things now. We have moved away from the analogy. Now we are coming to the places where the data actually resides within an organization. It could be on premise, right? Or on premises also sometimes you call it, which is just a fancy term used for in your own building. It's just a fancy term for this, right? So if the data resides within your own building, it means that the data is on the computers and the servers that you uh, basically own and you manage in your own office or in your data center, right? The data could also be present on the cloud, just like my ADLS, right? Data lake storage. The cloud is not actually the sky, all right? It's a network of huge, powerful data centers, which is owned by companies like Microsoft, Amazon, Google, right? IBM also has a cloud. Oracle also has a cloud. So many companies are, coming together and building this cloud infrastructure, right? So when you store data in the cloud, you are actually renting a small space from on their computers, on Microsoft's computer, right? So the challenge is moving data between only these two different places. This is the only two locations that you will be concerned with while moving the data, right? Either you have to move it from the company's own servers or you have to move it from a cloud service provider. If I show it to you, let's see. When I start creating, let's say a very simple copy data activity, right? Let me create a new pipeline here. And within the pipeline, I'll use a simple copy data activity. So when I start defining the copy data activity, right, I go to source and I click on new. Now you see very clearly, it's either Amazon, it's either a cloud, network or cloud storage, right, where your data is present, Google Ads, BigQuery, or it's a file system that is on premises. So either it's hosted somewhere on Azure or it's in a database which can be accessed online, available online, right? Or it could be a file system, right, where you can connect to your lakehouse or you can connect to Oracle Cloud Storage, right? You can use FTP, you can use the file system, or you can use a generic protocol, right? HTTPS, ODBC, REST APIs to get the data. It could be NoSQL databases like MongoDB, like Cassandra, or it could be present within a service like Dynamics 365, Jira, right? M365, SAP, Salesforce, SharePoint, right? So basically, the different sources and the destination, all of these systems could either be used as a source or a destination that you saw on your screen, right? Just now. It's either present on the cloud or is it present in your own environment? All right. Let me get rid of this pipeline. I don't want it. Data flow also, I don't want it. This pipeline one also, I don't want it. And this default pipeline that got created, I don't want that as well. You understood? Data could either be in your own environment or the data could be somewhere on the cloud, right? There are three types of helpers that you get, right? For example, a packer and mover may tell you that we offer three types. One is basic, second is standard, and third is premium. Now, this would be, in my view, a very wrong analogy. I'm just trying to tell you that there are three levels to it, but it's not actually a level. All right. It's not basically a level. It's more about who can access what. So a basic plan may only get it from a villa, right? A standard plan may only get it from, let's say, an apartment. And then the premium could be villa plus apartment, right? So what type of place can I access? Based on that, there are three types of helpers that the Azure gives you. The first helper is what we call as the Azure Integration Center. So this is the first type of helper that you get, the one that we're discussing about. And it already lives, this helper already lives and works inside the cloud, right? It is managed completely by Microsoft. all right, managed by my Azure. So you don't have to worry about setting it up or maintaining it. There is no maintenance. There's no settings. There's no config that you have to do. Nothing from your end, nothing required. It's already there. If you plan something, it will do it, right? So until now, in any of the pipelines that we created, have you ever seen that I'm doing some configuration on the movement part? Did I do any configuration on that part? Shiva, Ravi, did we ever try and describe how the data will be moved, or did we worry about that? Basically, we define the source and the destination. But did we ever worry about the compute that is going to move this data? Yes or no?
No, we didn't worry about that one.
We absolutely had no role to play in that, right? And that is what Azure Integration Runtime does. It is available already. You don't have to do anything. Any pipeline that you create from scratch, this will be the default compute. And it's essential for moving data between your on-premise computer to Azure cloud. This type of integration runtime is very important or is helpful, right? When you want to move data from one place to another place, but these places are on the cloud or Azure cloud.
So both the data should be in the Azure cloud.
Yes, in the cloud. Both your data
Like
should
the-
be in the cloud.
Okay.
All right. Then Azure integration runtime is the best thing that you can work with. So if you remember, let me show it to you. So what we are trying to understand today is over here, if I go to manage section and I go to integration runtime, where did it go? Yeah, I am on integration runtime. I'm searching for integration runtime. If I click on new, you see Airflow is in preview stage. It's something new which has been added, not being used, right? I'll tell you what Apache Airflow is. But basically, it's the three over here. Azure, from a self-hosted, and the next one is Azure SSIS. All right. So these are the three that we need to first understand. What is, if I click on Azure, right? If I click on this one and click on continue, that I have to select either of Azure or self-hosted. And if I select Azure SSIS, then it is the SSIS itself. So let's understand what this is. Now I told you that when you use Azure integration runtime, right? Core Azure integration runtime it's the default, it's the most common, it's the easiest to use integration runtime. All right. It's a fully managed service. For any cloud service, if you use the term fully managed, it means that you don't have to manage it. Azure will do it on its own. So it's a fully managed service, most common, easiest to use, and Microsoft takes care of all the underlying infrastructure for you. All right. Fully managed means Microsoft will worry about the infra that will be provisioned for this data movement and transformation. I don't need to create, I don't need to manage, or I don't need to update any virtual machines or any servers to do this task. This is what is called as a serverless system, where I don't have to pay for any servers, I don't have to provision servers, I don't have to create compute. All right. So it's a fully managed cloud workforce. When you use Azure integration runtime, you are actually telling Azure that I have a task to run. Listen, Azure, I have a task to run. Please provide the necessary computing power in the cloud, right? So compute power you have to provision in the cloud for me to perform this task. That is all we tell Azure. And then Azure will handle everything in the behind the scenes, and it finds basically the available compute resources to run the task and then releases those resources when the job is finished. You never have to worry about the hardware, the operating system, the software updates. So it's a hassle-free system, on-demand workforce that is always ready to, it's always available, right? And it is best for cloud to cloud data movement. Azure Integration Runtime is best for cloud to cloud data movement. All right, it's designed specifically to for tasks where the data source and the data destination are publicly accessible on the internet. All right, so that makes it the perfect choice for any data operation that happens entirely within the cloud, right? So if you want to, let's say, copy data between different Azure services, for example, moving files from a blob storage to a data lake, we use Azure Integration Runtime. If I want to move data from a blob storage to a SQL database, I use Azure Integration Runtime. If I want to move data from other public clouds, all right, for instance, pulling data from Amazon, right? So from AWS to Azure, if I want to do data movement, I will use Azure Integration Runtime. All right. If I want to connect to cloud-based software applications, many modern applications, software as a service options, right? They expose their data through public endpoints. So Azure Integration Runtime can connect to services like, Dynamics 365, Salesforce, SharePoint, and get the data from it using Azure Integration Runtime. If you want to run some data transformation also in the cloud, Azure Integration Runtime will provide the compute. So when you use features like, mapping data flows and all to visually design the data transformation, like filtering, joining, aggregating the data, the Azure Integration Runtime is basically your engine that executes these complex operations on a scalable cluster of computer in the cloud, right? So there's zero maintenance. There's elastic scaling, on-demand scaling is there. So if Azure Integration Runtime automatically requires more power, it will scale automatically. I don't have to do it. It is available globally. It is available in every Azure region around the world. So whether my data factory was created in East US, Central India, West India, South India, does not matter. Azure Integration Runtime is available in all different regions, and it is very cost effective because serverless compute is always cost effective, right? Because it's on demand service. You only pay for the compute resources while your task is actively running, right? When your pipeline is idle, you are not paying anything for it. You're not paying anything to run it, right? So it's very cost effective also. But there are certain limitations also, right? So when you talk about the limitations of Azure Integration Runtime, right? So then you have to talk about uh, that it's essentially, the primary limitation for the Azure Integration Runtime is that it cannot by default reach into private networks, secure networks, right? It lives in the public Azure cloud, and it can only access endpoints that are also publicly available on public internet. It cannot access a database server running in your office or a virtual machine inside a secured Azure virtual network. For those scenarios, you need a different type of helper. And that type of helper is called as a self-hosted integration runtime. All right. So type 2 is called as self-hosted integration runtime. All right. So first was Azure integration runtime. This is self-hosted integration runtime. So now from AIR, we come to something called as self-hosted integration runtime. So it becomes now SHIR. All right. So this is the second type. The good thing about self-hosted integration runtime, because it acts like a secure bridge between your private network and Azure cloud. So it's a bridge between private network and Azure cloud. So basically, the limitation of Azure integration runtime is, where how the self-hosted integration runtime overcomes that limitation. All right. So what happens is, unlike the Azure integration runtime, this self-hosted integration runtime is a piece of software. All right. It's a piece of software that you will install on the computer. Which computer? The computer that will be your source for data movement, the computer that holds the data, right? For example, I'm sitting here. If the data is in my computer, I will install SHIR on my machine. I will install this software on my machine, right? wherever it is, inside your data center, within your office network, wherever, it acts like a local agent on your machine that can, receive instructions from the cloud, but execute them locally, right next to your private data. So if anything needs to be done to my data present in my own machine, it will receive instructions from the cloud, it will do the transformation on my local machine, and it will use my local machine's compute, my CPU, my RAM for this data transformation. So it's a private on-premise workforce. The self-hosted integration runtime is actually a gateway that you install on your machine. And if this is my machine and I install SHIER, sorry, here. So ADF, which is present on the cloud, can talk to my machine here using that SHIER. It can connect to my machine. If ADF wants to connect to my local machine, it has to do so through SHIER, because the compute AIR, Azure Integration Runtime, will not be able to do it. It will not be able to connect to local machines. All right. So when you're running a pipeline that needs access to, let's say, on-premises data on my system, the data factory will send the instruction through this secure channel that gets created between SHIER and ADF. So we install SHIER and we connect it to ADF. So this secure channel gets created. Now, this secure channel will work as a data movement, bridge between my computer and ADF. So if any data transformation, requires data from my local machine to be picked and sent to ADF, or, or to a different cloud storage. Actually, not ADF, but ADF wants to pick that data up and transform it and send it to some other location. This secure channel will act like the connection to do that. All right. So basically what you're doing, you are giving access to ADF to your own systems. All right. The self-hosted integration runtime, it's like a hybrid scenario, meaning any situation that involves moving data between a private on-premise environment and the public cloud, the self-hosted integration runtime will come into effect and help you with that. All right. So this is used for scenarios where you want to, let's say, move data, from on-premises database to Azure. So this is one of the scenario. Move data from Azure to your on-premises storage and vice versa, and vice versa. Vice versa, why? Because if you want to send from on-premises to database to Azure, you can use self-hosted integration runtime. If you want to send from Azure-based database to on-premises database, that can also be done, right? Second, if you want to move from Azure storage to on-premises storage, or from on-premises storage to Azure storage, that can be done, right? If you want to access data that is present or that is secured with, Azure virtual network, right? Any virtual network could be configured in a way that it does not allow public access, right? So if data is protected behind a virtual network, that also you can access through this self-hosted integration runtime. All right. And if you want to run custom activities, custom scripts in your on-premises environment, right? If you want to execute custom code or scripts on your local machines as a part of data factory pipeline, you can do that using self-hosted integration runtime, right? So it gives you secure access to private data. It gives you control over execution environment, right? Since you provide the hardware, because, when I use self-hosted integration runtime, it configures my system in a way that any transformation, if it needs to be done, the compute will be taken from my system only. So my system will have some CPU, some RAM. That CPU and RAM will be used for data transformation purpose. With high availability and scalability, right? You can install the self-hosted integration runtime software on up to 4 machines, all right, and link them together to form a local or a logical group, right? So you can install it on 4 machines and create a single group out of them, right, and provide that connection details to Azure, and then Azure could connect to all those 4 different machines simultaneously, right? So this type of integration runtime you generally use when your data is on premises. And one more benefit that you get is, let's say I have this machine in my local environment, right, in my on-premises environment, and that machine has certain compute available. Let's say there's a lot of RAM available, there's a lot of CPU available that I'm not using. I'm not using it at all. So why not use that same CPU and RAM that I have available lying idle, because I have the ownership of it, right? So I don't have to pay any rent. Since I own the CPU and the RAM, obviously it is better to use or to transform data using this compute rather than the Azure integration runtime, even though it is very cheap, even though it is very cheap and it will not cost you a lot. But again, if you can do it for free, why not? Right? So just like Azure integration runtime, this also has some limitations. The main trade-off is that you are responsible for managing the infrastructure. It is your compute now, it's not Azure's compute, right? So you must provide the compute, you must maintain the compute, right? You have to patch the servers or the virtual machines where the self-hosted integration runtime is installed. You're also responsible for ensuring that the machines have enough CPU, enough RAM available, right? Yeah. Now, after this, we have the third type, right? Which is the Azure SSIS integration runtime. All right. So you can call it ASIR, right? AIR, SHIR, and ASIR. So it's a very specialized type of integration runtime. All right. Do you know what is the full form of SSIS? How many of you know the full form of SSIS? SSIS stands for SQL Server Integration Services. Now, SSIS is basically a traditional data integration and workflow platform, all right, which is created for data movement only as a part of Microsoft SQL Server, and it has been used for many years. And many organizations have invested heavily in developing some complex the SQL Server integration services packages over the year, right? So they use SSIS for data movement between databases, right? And it basically, the integration runtime over here, it provides three types of data movements, all right, or it provides multiple ways for these organizations to actually lift and shift. Lift and shift is basically a migration strategy where you lift from the source as it is and move it to the destination as it is, right? So they can lift and shift their existing SSIS workloads to the cloud without having to redesign them from scratch. So as it is, I move it, right? I pick it up and I move it to the cloud. So for us, it's not that important, right? The SSIS packages and all, right? Because it's for database administrators to work with. When you set up an Azure SSIS integration runtime, right, you are actually provisioning a dedicated cluster of Azure virtual machine. All right. And this cluster of virtual machines are configured to run the SSIS engine, all right, which is a fully managed environment for executing your SSIS packages. And you choose the size and the power of the virtual machine in the cluster itself, and Azure handles the setup and management of the environment for you. All right. So there are a lot of use cases for this. There's only one use case for this, right? The sole purpose for this integration runtime is to run SSIS packages in Azure. It allows companies to continue using their existing SSIS packages while taking advantage of the cloud, right? Now, if I want to do this, if I want to use it, right, auto resolve integration runtime is there. You can go ahead and you can ask for SHIR download, not show download. Oh my God. It's SHIR download. So the moment I type SHIR download, download Microsoft integration runtime, right? So this is the software, right? Microsoft integration runtime is what you need to install on your machine for it to become a self-hosted integration runtime, right? So I'll show it to you on Monday because it's a long process. I'll not be doing it on this machine. I'll not be setting up this on this machine. What we need to do is we'll create a virtual machine. We'll have some data on the virtual machine, and we'll try to move that data from a virtual machine to my Azure environment, right? And that virtual machine will act like a standalone, compute. I could treat it as an on-premises system also because the same process I will also have to follow. But when you want to use SHIR, this is the software that you need to install on your machine. All right. So you select this one, 5.57. I think they've installed one recently because earlier we used to install this 1 GB file. So they've reduced the size of it. Fine. Then click on download and it will give you the options. Which one do you want to download? You can select the latest one, 5.57, and you can click on download. And it will start downloading the, I can save it, right? And it will start the download process over here. So I don't want it as of now over here. I'll install it in a virtual machine. All right. So integration runtime, is it clear to you? The three types of integration runtime that we covered?
Yeah, yes, Shreyas. Like I have a doubt. Like if
Go ahead.
we have data in on-prem, like for example in our laptop or our Windows, and if there is a requirement like open in the if you want to run that in the virtual machine, how to
So
do
you want
that?
to
Like
move the data from on-prem to virtual machine.
not like a virtual machine to another any
Machine.
destination source, like any
See,
destinations, not only like a virtual machine itself, but any destination. Can we do that through sending it to
SHIR.
first to the virtual machine and then from there to the
See, why do you can, when you can correct the source and the destination directly, why do you want an intermediate location? Is it required to have that intermediate location? If required, you can do that as well. You can configure it in a way. You can create two pipelines. Pipeline one, move from A to B. Pipeline two, B to C. Or in the within the same pipeline, I can define multiple copy data activities also.
Okay, got it. Like I'm a bit confused with the virtual machine and this one. So
I will create a virtual machine. I'll show you how you move data. See, generally you do not store data in a virtual machine. Generally, your data will always be in data lake. Trust me. All right.
okay,
When you deal with cloud, when you deal with data on the cloud, 90% of the time your data will be in a data lake because that is the de facto, uh, you know, uh, primary data source or data destination that you use. So generally, your files will always be in a data lake. If it's not, unstructured data, if it is semi-structured data, also it will be in a form of a file, JSON file and all. If it is structured data, it will be present in a database, right? So either it's a data lake or a database. Ideally, data lake can contain structured data also, but let's assume that it's in a SQL database. So you already understood how to connect to them, right? Using ADF. Now moving the data to whichever destination. Destination also we have seen there could be many, right? Within Data Factory,
yeah,
we saw that you have a whole list of destinations that you can select from depending on your requirement. Now, what we needed to understand was my source and destination for this particular compute can only be Azure or cloud-based, right? So if the data movement is cloud to cloud, this integration runtimes work best. This is the compute that I will require. But if the data is present on my personal machine, will this compute be able to access it? The answer is no, right?
no,
That is why we will download this software on that machine, install it, and set up a self-hosted integration runtime. So on Monday, I'll demo it to you how you download it, uh, create the self-hosted integration runtime, link it to your data factory, and then transfer your data from on-premises environment to to your data lake. Let's say I want to pick up a file and put it into the data lake. So how do I do that? So I'll be able to do it from here. All right.
got it. Yeah,
All right then. So we'll stop here. All right. I don't want to start a new topic. Uh, but Monday we'll see this particular demonstration. And the second important thing that we need to see on Monday is data flows, right? Because now we need to start with data flows. And this is one way for you to connect to multiple sources. Let's say in a normal copy data activity, right? You've seen that I define one source and one destination. Yes or no? We define one source and one destination. With data flow, I can define multiple sources. I can click on add source. I can again click on add source. I can again click on add source, right? So there are multiple sources of my data. How do I define the source? the same data set. I can select a data set, right? Let's say source data set 1 is over here, right? In the second one, I select another data set which already exists, so data set P2, right? In this next one, again, I select a data set, source data set RNB, right? So you see, these are all three different data sets that are defined. Two are Parquet, one is CSV, but all of them contain 11 columns. Now from these sources, I can perform multiple activities. I can create a join of these multiple sources. I can create a union of these multiple sources, right? I can create a union. I can create a join like this, right? And then I can define over here. Once you create a join, right, we need to have something called as a left stream, right stream. So right stream I can define as source 2. You see, the moment I define it, source 1 and source 2, join is getting created. There are total 22 columns because I have created inner join, right? I can create full outer join, I can create left join, right join, whatever I want from this data, right? So like this data transformation is done visually, right? So data flows is the way in which you can use visual designers to define your transformation and transform your data as well. So this is something that we'll see on Monday. All right. So we'll stop here for the day. Thank you everyone for joining in. I'll see you guys on Monday. The majority of section that we have seen within ADF is data movement in different ways. Data movement either from CSV to Parquet conversion from one place to the other, moving data from my storage account to a database, right? These are the things that we've seen. Until now, we've not seen how do you move a JSON file. I'll show you that also. Once data movement is finished, right? Once this data movement part is finished, we will move to data transformation. All right. So initially, our goal is generally to understand how data moves between different places, right? Post this, we'll try and understand how the data transformation happens. And to do this data transformation, what we've done is we'll be having these three files. Let me show you the files first. If I go to my storage account and I see data lake, so I've now created another container within my data lake. All right. So now I have another container over here, and it is called as customers orders. All right. So this is the name of the data container. And within this, I have several files now. All right. These files, let it load. Yeah. So there are some 5 files that I have. All right. Now, all of these 5 files, they are basically containing data. There is customers data, which is present in the JSON format, right? So you can see .json over here. There is order items, which is present in the text format. Within the order item table, I have, order ID, I have line item number, product ID, unit price, quantity. So every order that is placed is over here. If I want to show you, wait, let me open this. Go to the edit section. Yeah. So order ID, line item ID, right? Product ID, unit price, and quantity. So in order number 334, there were 3 items. 1, 2, 3. Line item is basically the number of items which are there in a given order. So order number 334 here has 3 items, 1, 2, 3. Product ID is 26, 46, 12. Unit price 48.75, 39.16, 10.48, and the quantity 144. Similarly, order number 337, again 3 items are there, so line item 1, 2, 3. So just explaining you the data set that we have. Then there is orders column. Orders column basically contains the order ID, order date and time, what time the order was placed, which customer placed the order, what is the status of the order, from which store was this order placed, right? And product, you can understand it contains the details of the product, product ID, product name, and the price of an individual product. This is also in JSON format. So if I show you product ID 16, product name is, let's say, women's socks, and the price of that product, right? If I have to show you the customers.json, how the customer information is saved. So in customers, I have customer ID, name of the customer, and email address. That is all, right? And then finally, I have the stores.json, which contains details about the stores, such as the name of the store, right? What happened? Yeah, the name of the store, the store ID, what is the web address for that store, right? And let me check other information also. I think there is latitude and longitude details also present here. So store ID, name, online, web address is this, latitude, longitude, right? And so I have multiple stores over here, a total 23 different stores I have, right? All over the world. So there's one store in New Delhi, one is in Mumbai, one is Bangalore, right? Johannesburg, Madrid. So you understood what this data represents? This is a complete data that is collected by an online store. And this is gonna be my raw data. What you see on your screen is going to be my raw data. Now, this raw data needs to be transformed, right? So what I'll do, I'll copy this data from, let me show you. Yeah. So here I have my raw data. I will move raw data from the data lake into a cleansed format, right? Then I will bring it to a structured format, and then I'll bring it to a format where we'll be able to do the analytics on this data. All right. So for example, cleaning would involve removing, let's say, columns that are not required, or giving data type to my table. Then trying to get rid of multiple data sets here, right? For example, after this I will move to, so in the raw I have orders, I have order items, right? I have stores, right? I have products, I have customers. So what I'll try is I'll try to reduce first of all the number of tables, or the number of data sets that we have to deal with, right? For example, cleaning will involve removing the columns of which are of no interest to me, which I don't require, right? If there is any let's say new column that I need to add, such as date format. In orders, everything is in JSON or a text or Parquet-based file. Now, Parquet-based files will retain the data type, but JSON and text formats or CSV formats will always store everything in the string format. So I need to bring the data to proper format also. Now, once I have the data cleaned here, I make it structured, right? I try to reduce the number of tables, I would say, or the number of different data sets that we have, and we'll finally have only orders column, we'll have stores column, right? And we'll have products column. All right. These are the three columns that we are going to have. All right. And in the analytics, right, the final step where we want to do analytics, there we'll use aggregate functions and try to create two different data sets. One will be orders per month per store. All right. So store name and the year, the month, and the total amount of sales that every store is doing in a month. Store sales by month, right? And the second table, or the second data set that we'll try to create over here, is products orders monthly. So that will be product sales by month. So analyzing each product and then analyzing the stores also, how well they are doing, right? So this data set which I finally create, will be stored in, let's say, a warehouse where the analytics team could directly deal with it. Cleaned format, we might take it from one folder in the data lake, put it into another folder into a data lake, right? And moving this data from one place to the other will always use the copy data activity, CD. All right. So moving the data around is what we need help with, what we need support with. Now to continue with this, right? Something that now to continue with this, what we'll require is, first of all, there's one thing that I have not shown you, right? The movement of a JSON file. So that is also very simple. Now, today, I want to show you, I want to go a step ahead into my data factories. Until now, we were doing with single copy data activities, right? We were working with single copy data activities, doing it for one file, What if I want to copy data of all the different types of files that I have, right? What if I want to do it, in that particular format? Or let's say, what if I want to make my, uh, you know, uh, data factory studio more clean, right? I want to clean this up. So how I can do that is, let's go to the author section. Within the pipeline, you have seen, right? You have different types of pipelines. I don't want these, right? I really don't want to use them. So what I'll do is, because we are now working with an exclusive data set, right? The customers orders data set. So let's create a new data factory. All right. It'll just take 1 minute to get created. And NICRG. I'll call this NIC data factory 2. All right. Why I'm doing this is because I want to show you something which may not have been possible in the previous case, right? Let's review and create this. It does not take anything else. Let's create this. What we'll try to do. And one more thing I wanted to show you is, what if I want to group these data sets and the data sets that we have, source data set, destination data set. So what I can do is I can create a new folder here. All right. So this is one way of cleaning your data factory environment, right? If I have, let's say, 100 pipelines running, and those 100 pipelines have, let's say, one or two copy data activities, in each pipeline is there, right? Because obviously when you're using ADF, you would be moving data from one place to the other. And moving data requires copy data activity. Copy data activity requires source data set and destination data set. Then you would have a list of 200 data sources over here. How are you going to keep a track of it, right? How do you make sure that uh, you have it in a proper structured manner? Now, one thing what you can do is, within pipeline, you can create a new folder and you can call it pipeline 1, right? Something like this. But I don't have to worry about this. I can create something like copy data pipelines also, which will just tell me that this particular folder contains all the copy data activities. Similarly, I can create a new folder here called source, right? So I know if I have defined the source, it would be in this folder. So within datasets, now I have this folder. I can pick the source data, and all the datasets that relate to the source dataset, I can drag and drop it over here on this folder. So this is also source dataset. I'll move it here. This is also source dataset. I'll move it here. This is also source dataset. I'll move it here, right? So now for all the 4 pipelines that we have here, right? I have the 4 datasets, source datasets, and I've moved it in a single folder, right? Similarly, I can create a new folder called destination, right? And I can have all my destination data sets in one folder. Now, having it in this folder does not affect your pipeline. All right. You don't have to worry about your pipeline. Do we have to change any path anywhere? Do we have to make any changes here? No. If you defined it in a folder, it is fine. It will directly take it from the folder itself. I don't have to say that this data set over here is present in this file, in this folder, and how you have to go. So nothing like that required. So deployment is complete. I can launch my NIC Data Factory 2. What I want to show you today is how can we go ahead and create multiple copy activities in the same pipeline. Until now, what you were doing, one or two pipelines or one or two copy data activities you were keeping in every pipeline. Now my requirement is to put all the copy data activities in the same pipeline, right? Let's see how we're going to achieve that. Yeah. So quickly we get to it. I'll call this new pipeline. And in this new pipeline, what I'll do is, what I want to achieve here is, I have multiple files here. Within target, do I have any file? Yeah, we have 2 files here. I'll delete these files from my data lake. And within my IC Data Factory 2, let me close the first one, right? I'll not be using this. Over here, what we'll do is now we'll start adding copy data activity, right? So either you can search on top the copy data activity and you can put it over here, right? That is one way of doing it. Then obviously you have to define the source data set, the destination data set, and you're already aware of the process, right? I can have multiple copy data activities here, right? Let's see how many files do we have. So we have 5 files, right? So I can create 5 copy data activities, all right? And I can call it customers, order items, order. So let's call this one customers copy data activity. All right. I can say customers copy. All right. Second one I'll call as orders copy. Third one I can say order items copy, right? Fourth one I can say products copy. Third one is store data, stores copy. All right, simple. I can give it a name like this, and I'll call this copy data or copy customers order data, something like this, right? Now there's a button over here, auto align, right? If this looks, if this doesn't look good to you, you can click on this button auto align, and they will all come in one single order, right? So let's go one by one. I have to show you, right? This is all of them arranged in a single line, right? So we'll go with the first one, that is customers copy. My customers data is in JSON format. So let's define the source data set. And the data is present in my data lake gen 2. I'll click on continue. The data, my customers data is in JSON format. So I will select JSON over here. Where is JSON? This is JSON. Click on continue. So I'll call this customers source, or let's say source customers data set. All right. The link service, I don't have any link service because it's a new space. So I'll create one Azure Data Lake storage. I'll call it Azure Data Lake, and I see data lake. All right. So I know which data lake this corresponds to. Everything is fine. I'll select my subscription from here, and I see data lake, and I can test the connection. Leave everything to default. Click on create. All right. Now, what is the file? I'll browse the file. It's in customers order. And since this is a customers one, I'll select customers.json and click on OK and OK again. Right. So the data set for the JSON has now been created. So until now, we have not seen JSON. I can preview the data here, and you'll be able to see the JSON data present here. All right. So this is the sample data. I have all the customers data present in the JSON format. Now, our transformation that we'll do will involve moving this data from JSON format to some other format. All right. Generally, for analysis, we try and convert everything into Parquet format. You've already seen how efficiently Parquet stores the data. Querying the data in the Parquet format is also very easy, right? It's done within seconds. So we'll be using that. So currently I'll keep it as JSON only. I'll call it destination customers data set, and link service already exists. I'll select it. I'll click on OK, right? Copy behavior, preserve hierarchy, nothing else required. Let everything else be default. Mapping also not required because I don't have any file or any table created on the destination side. So mapping does not matter. So customer is done. Same I can do with orders also. I'll create new, go to data lake. I'm creating the data set for all of them, right? Click on continue. Now orders is present in which format? Parquet format. So I have to select Parquet. Click on continue. I'll say source orders data set. Use the same link service. Select the file. It's orders.parquet. Click on OK. Click on OK here. Select it again. Click on OK. and click on OK again. Done. Sync again. Wait, what was that? Source, destination. All right. Sync, new, again in data lake, click on continue. Now again, this is in Parquet format, click on continue. Destination, orders, data set, right? And then link service is the same. Select the folder. I want to put it in the target folder. Click on continue. Okay, done. Nothing else required. Copy behavior. By default, if you do not, select anything, it will select preserve hierarchy only. So let this be. This is also created. If I remove the activities and I go to data sets, I just wanted to check one thing, destination customers. All right, see. Now, in the destination data set, I did not define where this file will go, right? So this is what I was wondering. File system, directory, file name. File system is basically your container name. So if I select, it has to go to target and click on OK. We'll see within target, there is no other directory and I have the file name over here. So as of now, the file is not there. Therefore, it will not be. I can wait. I'll need to publish this before I close it. Fine. Order items, source. I defined it in the wrong one. So what I'll do is I'll go to orders and I'll select the existing data sets. All right. Source orders data set, and in sync, I'll select source destination data set, destination orders data set. All right. Yeah. I think I had used it separately. Now over here, I cannot use this. I have to create a new one. So my source in order items is now going to be in data lake only. But order items here is text format. Then click on continue. Now you'll see, you don't see text format over here, right? If you do not see the format that you're going for, select binary copy. All right, just copy the file. So I'll call this source order items data set, link service used, again Azure Data Lake, and the path of the file is in my customer's orders and its order items. Click on OK. One thing I wanted to ask you, all right, since you've been seeing Data Lake from a long time now, if I go to sync and I select existing data set, destination data set of an existing type, will it work? Can I select an existing data set? Will this work for me? Selecting an existing destination data set. The answer is no. Why? Because here we have defined specific file types. All right. Therefore, I cannot use that directly. Right. So what you have to do? I have created source, right? I have to create order items, right? Yeah. Source I have defined, order items dataset, sync I have to define, new. It's in Azure Data Lake, binary copy, click on continue. I'll call this destination order items dataset. And we'll stop at these three. All right. We'll continue with other files later on, but we stop with these three activities first. So this is order items, right? Click on OK. I am selecting a file in destination. I don't have to select a file. I just have to select the target folder. This is destination, right? So just the name of the folder where you want to put it. Click on OK. Done. So one pipeline, 6 data sets, publish all. Now this is giving error. Why? Because I have not defined the last two activities. Stores copy I'll remove. Products copy I'll remove. I have defined customers and all these, right? So this is fine. Now I can publish it. Before publishing, you can do this validation. So what you see on the right hand side is basically the validation error, right? In products, source was not defined, sync was not defined. In products copy, the source type is required. So it is giving me error based on the two activities which I had not defined, right? So if you want to know it before publishing it, just click on validate and it will do the same thing for you. Validation here also does the same thing. Now we can run these activities all in a single pipeline together, right? I can do that. Let me remove the size here. Yeah. So customers, orders, and order items. I have three, I can auto align them over here. I can bring the view to focus on all the activities that I have, right? I can do that. Now, wait for it to be published. Still getting published, I guess. Yeah. So publishing is complete. My pipelines are now saved. Now the folder structure that I had told you about, right? I can do that. I can go to author, the data set. I can add a new folder here. I can call it source. And I can create a destination folder also. Click on create. So source will go to source here. Source will go again to source. Source will again go to source. The destination data sets could be put together in the destination folder. So I can see source is defined as my data set over here, right? And I will use it. Let's publish everything. It's basically the location of the data sets have been, uh, changed. So it's just that, nothing else. So like this, my pipelines could be created, chained together. I can say when one is successful, then go to two. When two is successful, then go to three, right? So like this, I can chain my pipelines also together, right? So you'll see 4 buttons here. You can, change this also by clicking. Where is this? Yeah, sorry. By clicking here, you can see the first one is on skip. If this activity was skipped for some reason, let's say if you have an if else condition, right? During if else conditioning that you do, we'll see later on the conditional loops and everything within data factory. But when you apply this if else, right, sometimes uh, the else condition might not work, or sometimes the if condition may not, you know, uh, basically run that activity. So this activity will be skipped. So what to do when this activity is skipped? Do you want to perform an action? What to do when this activity executes successfully? What to do if this activity fails? And what to do if I do not worry about whether it failed or it succeeded? I only want to see that it has to be completed, either failed or skipped or anything, right? So basically, on completion means that the activity has been completed. Whether it failed or succeeded is a different story altogether, right? So like this, you can chain your pipelines together. Between them, you can use Azure functions. You can run a Databricks notebook also, right? You can use any activity that you see here, right? For iteration and conditions, we have filter, for each, if condition, switch condition, right? I can run, let's say, these activities. We'll see what lookup is, what get metadata is. We'll see it later on. I can delete the data from my source, right? Let's say after the copy has happened from source, the raw file, you have copied the data to the target container. What if you want to get rid of the existing files, right? What if you want to run an Azure function? So all of that could be done from here itself. For now, I think I made some changes. We'll publish that also. So now let's try and trigger this pipeline. Add trigger now. Is it still publishing? No. One thing I would have to check whether uh, my data factory has access onto my storage account or not. So I'll go to access management. I'll click on check access for a managed identity. Which managed identity? Data factory. Which data factory? The second one. So currently there are no roles now, but I think the authentication happened through, you know, the account key. That is why role-based access control is not effective there. That is also fine. Let's add a trigger now and click on OK. Right? So this is what we have seen until now. I know it may sound a bit redundant, right? but it's fine. We've seen this already. The next thing that we need to see is the transformation. How am I going to do the transformation? For transformation, what I'm going to use is something called as mapping data flows. These data flows over here help you with transformation of your data. All right. Data flows are advanced activities. These are all activities. When I create a data flow, right, you will see when I create a new data flow, this is basically an activity getting created. I can use this within the pipeline. I can use this data flow within the pipeline. Data flow is very effective. It is very efficient. It does all the heavy lifting very easily. All right. It can process big data. Data flows can help you process big data. Why? Because in the backend, data flow uses Spark. Now, as of now, you're not aware of Spark. You've not discussed Spark, but it creates a Spark cluster and it converts your transformations into PySpark code, the Spark code, right? Not necessarily PySpark, but code that is understood by the Spark architecture. The code within Spark could be written in Python, which is PySpark. It could be written in Java. It could be written in Scala. It could be written in SQL also, right? Spark infrastructure understands multiple languages, not just one. Therefore, in the backend, it converts your data or your transformation that you defined into Spark code. And that Spark code is processed on a Spark cluster. Now, Spark programming is generally used for big data transformation. So you can understand the kind of compute and the efficiency with which your data transformation would happen. For example, if you remember, last time we created a fact table. How many of you remember? Siva, do you remember? Theory? We created a fact table. Yes or no?
Yes.
Yes. Now, if I have to create the fact table using a data flow, right? How do I do that? I'll come back to this, but in the meantime, the previous pipeline run is successful. If I show you copy data activity, one also successful on success. Since the first one, customers copy was successful, order items also got copied. Since order items was also successful, orders table also got copied, or orders data also got copied, not table, the data, the file. If I go and see my target container now, I should be able to see 3 files here: customers, order items, orders, all in their specific format. This is what data movement was all about, right? Now we come to data transformation. And for data transformation, I will show you a glimpse of data flow today, which will be unrelated to these files as of now. We'll try and build the fact table using the data flow, right? Now, when you want to build a fact table, you have to do inner join, right? You are creating a join between the two tables and then taking the common data based on the sales order ID, right? If I have to show you, let me go to my SQL database that I had created. And I think before I do that, I'll have to add my current IP address to the server so that it lets me authenticate onto the SQL database. So let me open that. So if I go to settings, security, networking, and I see the firewall rules, right? So my current IP is 167.103.118.163. So I'll add it and I'll save this. Then I can now go back to my database and try and access it. So this is done. Let me go back to the database, open the query editor, enter the password, click on OK, let it load. Currently, I'm not available. Fine. Sometimes, the firewall rule may take some time to get implemented, but this is fine. I'll have some sample tables also here present. Now, let me open the query for creation of the fact table, right? So this was my fact table query, right? So I'm selecting sales order ID, order date, customer ID, subtotal, tax amount, freight, total due, order quantity, product ID. This is from header detail table, and this is from sales order header table, and this is from sales order detail table. So DT is from detailed table. So order quantity, product ID, unit price, discount, line total from the sales order detail table as DT. So if I execute this, I'll be able to see the data. What happened? Maybe I had selected a few lines. This is fine, right? So I'm able to see the fact table that I created. What if I want to, create this through data flow? I want to create a fact table using data flow. Now, this data is coming from two tables. So if I have to show you here, first table is sales order detail and the second one is sales order header. So what I do, I'll add a source here. So two tables are there, therefore two sources required. I'll go to source one. I'll call this header table. And the other one I'll call as detail table. Right? Since there are two, sales order header and sales order details. So details and header table are now there. For header table, details table, header table, let me make it like this. Now, where is this table present? Those details I will be defining from the source type. So what I'll define right now is the data set. I'll tell you what inline is, but currently let's define the data set for this source. Do I have an existing data set for this source? The answer is no. So what I'll do, I'll click on new. I'll select my Azure SQL database, this one, click on continue. I need to create a new link service for the SQL database. I'll select my subscription. Server name is NIC SQL Server. Excuse me. The database name is NIC SQL DB and authentication. Username, password I need to select. Let me open another tab here. I think SQL admin user was the username that I had. Let's just cross check it once. What is the username and password for my SQL database? Password I remember, the username only. So let me go to SQL databases, SQL DB here. All right, let me go to the server. Server admin is SQL admin. So I'll copy the name and I'll put it over here. Who's the user? The SQL admin. Password I'll put. And rest I'll leave it as default. I don't need to make any changes here. I can test the connection. Successful, I can create this link service. Now, I'll call this header source. Link service is the same. And the table that I'll be using is sales order header table. All right. I'll select the table name like this. Click on OK. So in header table, header source, I've selected it. There are 22 rows in total. 22 columns in total in the header table. Let's go to detail table and do the same thing. New data set, again present in SQL database. Click on continue. I'll call this details source. Link service, I'll use the existing one, the Azure SQL database link service. And the table I will select. Let me select this first. Sales order detail, right? So table is now sales order detail. I've selected that as a source. So now source I have defined for header and detail table, right? Here there are 22 columns. Here there are 9 columns. What I need to do now is if I go take you back to the query, right? So I had an inner join between the two tables, right? So first thing that I need to create is an inner join on sales order ID because sales order ID is common in both the tables that we have. So I'll click on this and I'll click on join, right? So now I want to create a join. I'll call this inner join. I'll just name it inner join. It's going to be of the type inner join also. So left stream and right stream. When join happens, you have to keep something on the left, right, and something on the right. Like you see these two circles, right? The left circle and the right circle. So left circle is already defined as header table because I clicked on the plus icon over here. So now the right stream, I'll select the details table. So now the join is created between the two. Header table, detail table, And the type of join that I want to select, inner join, the columns which are common, right? When you select inner join, you're basically saying the columns should exist in both. Now in both of them, the primary key is sales order ID. So I'll select sales order ID here also is equal to sales order ID in the other table if I want to show it to you, right? So this is the join condition, all right? Sales order ID over here. No space, fine, right? So inner join, sales order ID column. This is done. So my join is created, 22 columns here, 9 columns here, total of 31 columns I received. Let's do the filtering now, right? I can select specific columns, right? So when you're running a SQL query and you want only specific columns to be displayed or selected, you use the select query. So I'll also use the select query here. All right. Now, within my select query, I can define which all columns I want. Now, in the select query, if you see, the rows reduced to 28 because there are certain columns which are common in both of them. So they will be removed here. So now, what all do I want? So if I go to my SQL query, I'll see I need one sales order ID. I'm only taking sales order ID once, right? Whether from the detail table or from the header table, it does not matter, but only taking it once. So let's take the header table sales order ID, right? So header table sales order ID I'm taking. So I'll let this be. All right. Now, revision number. Fact table does not require revision number. I'll remove this. Second thing that I wanted was order date, customer ID, subtotal, tax amount, freight, and total due. Order date is required. Due date is not required. I'll delete this. Ship date again not required. I delete it. Status not required. I'll delete it. Online flag not required. I'll delete it. Sales order number not required. I'll delete it. Purchase order number again not required. Delete it. Account number not required. Customer ID is required. Let's see. Sales order ID, order date, and customer ID is required. So I'll keep customer ID. Ship to address not required. Bill to address not required. Ship method not required. Credit card approval code not required. Subtotal is there. Tax amount is there. Freight is there. Total due is there. Subtotal, tax amount, freight, total due. Coming down, comments not required. Now, row GUID. See, wherever you have common columns, there the name will be header table at the rate row GUID, right? Because it was present in both the tables, so I selected only one, right? What I'll do, I'll get rid of row GUID also. I'll get rid of modified date also. Sales order ID, do I require it again? I have already selected it once, right? And since it's after an inner join, so common ones only exist. So I can get rid of the second instance of sales order ID. Total due is there, right? I'll get rid of sales order ID. Then I have order quantity, product ID, unit price. So order quantity, product ID mapping is there, unit price is there. Unit price discount is also there. And line total is the only thing now required. So till line total I need it, I'll get rid of row GUID and modified date. So in total, how many columns did I require? 1, 2, 3, 4, 5, 6, 7. 7 from the header table. 8, 9, 10, 11, 12. So total 12 columns are required. So if I start counting from here, 1, 2, 3, 4, 5, 6, 7, 8 till order quantity. 8, 9, 10, 11, 12. Total 12 columns are there. And you can see that over here also, the 12 columns that we needed. Now the only thing that I need is a place where I can keep this data. All right. Let's keep this data into my, one second, where should I keep it? I think in my Synapse, I had created one table Let me see. Should I want send it to Synapse? If I go to manage, is the data pool still there or is it deleted? All right, so I have created a fact sales table here. Yeah. Let me refresh this. Within table, you would be able to see one fact sales table. Yeah, this one. So there are no rows over here. Let's try and put this data into that same table. All right, from here. So what I can do is after I have selected the data, I can create a sink. All right, sink. Sink will help me define how I can put the data, where I can put the data, right? So I can create a new data set also. I want to put it into a database. Let's see if I can put it into a data lake. Let's see what that returns. If I want to save this data in the delimited text format. Let's see. Let's have it in the data container. All right, so I have 3 files there. I'll put this also. I'll call this fact sales. Let's try this. Because they made some changes recently. Let schema be none. Click on OK. Let me edit this once. Fact sales.csv is the file name now, not cdv, csv. Right, in the CSV format. This is fine. Let's publish this. Wait, let me check the data flow. Okay, sync is created, right, in the delimited text format. Fine. Let's publish this and see whether we are able to achieve this or not. All right, and we can do one more thing. I can click on plus again and I can add, another sink, right? I can define one sink for my SQL database also. Right, the table is fact sales. Where did it go? This one, fact sales, right? The last one. Click on OK. Mapping also you can see, right? Auto mapping is selected. So let this be auto mapping. In the next one, I'll show you how you can map it. Let's publish this. And what I have to do in order to run this, all right, what I have to do in order to run this particular data flow is that I cannot trigger the data flow itself. I cannot trigger this over here. It needs to be triggered through a pipeline only. So let this get published. Okay, publish now. Click on close. Come here to author section, expand it, create a new pipeline. I'll call this data flow demo. I'll add a data flow here. All right, so you just have to add a data flow activity, and here you don't have to do anything. You just have to select the data flow. So data flow 1 was the one that we had created, right? So if I go to data flow 1 is there, right? Compute size is small, parameters not required for this one. We've not done parameters as of now. I can publish this. And let's try and execute this. Let's see what happens. Also, one thing I'll do is I'll go to dataset, the SQL dataset, right? Let's edit this once. Not the link service. Is fine. And the delimited text data set. Fine. Correct only. So I'll go to the pipelines now, the data flow demo pipeline that I wanted to run, and I'll click on add trigger now. Let's see what happens. Whether the pipeline fails or it runs successfully. I'll go to the pipeline. So data flow activity is now running. I can see the inputs here, right? So what all is the input, header table, details table. And I can click on this icon to see the current flow run also, right? So there are two sinks, sink 1, sink 2. Both are currently in progress. Both are in queued. I can refresh the status from here, right? I can click on the header table to get the diagnostics from it. I can see what happened in the join, right? So it'll run slow because it is currently configuring the compute which is required to run the backend. All right. See, with data flow now, it will take some time when it gets started because, as I said, the infrastructure needs to be created first. Almost 2 minutes it will take in 2 to 4 minutes it will take in the provisioning of the compute cluster itself, because as I said, right, in the backend it runs the Spark cluster. So just give it some time. I'll just have a glass of water and then we'll see.
So Shreyas, we can able to see how many rows it currently processed.
Uh, See, the thing is that so now it shows succeeded, right? If I show you now the data flow details, now you will be able to see, all right, how many rows
Okay.
were read, how many rows were written, right? So this is the two sources that we had, right? Details table, I can see 542. Orders table, the join, right? Then the select query, and finally the sync. So if I go to my storage account and go to NIC data lake, and I think I selected data container, right? So this is the thing that it has done. I think I had selected partitions. So it has saved the data in partitions. So you'll see multiple parts of the data, right? So if I go to the edit section, all right, I think there is some data settings that I did not do, but it's fine because we'll be working with, okay, so here I have the data. So it has created multiple different types of partitions based on a particular column, I think, right? So some 158 partitions were created. So it's fine. If I go to my database and see the table, oh my God, again, the IP address has changed. I just gave you a brief about, data flows. We are going to go into a lot of depth of data flows. 184, yeah, IP address has changed. To tell you in brief, right, what all we'll be covering, we'll be seeing the select transformation, the partitioning, cast transformation, how to do import projection, right? How to create a derived column, right? Raw to clean data flow, right? Uh, Partitioning the data set itself, filtering and sort transformation, aggregation transformation, join transformation, conditional split, all of that we'll see in our data transformation. All right. If I go to the SQL database again and try and run it again, I think this time it should execute and I'll be able to see the fact sales table, sales order ID, order date, customer ID, subtotal, tax amount, freight, total due, order quantity, product ID, unit price discount, and the line total, right? So this is how I can create these fact sales table. So today I just wanted to give you an introduction as to what you can do, right? So fact table creation, I can do it like this. I just wanted to show you that data flows are used for data transformation. Now the real data transformation will start with these 5 files. All right, so from tomorrow onwards, we'll start on a mission where we'll have different types of data, right? Uh, in raw format types because they're all in different formats. And we'll start cleaning it, structuring it, and bringing it to an analytical format, right? Trying to create some aggregations and all, right? So we'll do all of that with these 5 files and we'll completely use data flow so that, and we'll try to use as many as activities as we can within the data flow. So understand what all different things that you can do with the mapping data flows, because mapping data flows is the more, it's more powerful than Synapse. When in Synapse, you would have not seen data flows, right? Synapse supports data flows, but data flow in itself is a, property of ADF. That generally uses, you have a different defined section for data flows over here, right? So derived columns, conditional splits, all of that we'll see. Today is something known as self-hosted integration runtime, right? Now we've discussed it before. I told you that there are multiple types of integration runtime, and one of it is self-hosted integration runtime. If I take you to Azure Data Factory, right? Azure Data Factory, or you can just search for data factories also, right? Data factories, V1 is not there anymore, V2 is there. MCT subscription. Let's click on create. So today I'll show you something very interesting, right? Just wait for it. code. Wait. So I'll select a resource group, NIC resource group, let it be. The name of, I'll call it as NIC data factory, data factory 1. Region, and let it be East US. Version, let it be East US 2. Oh, sorry, East US version, let it be V2. And let's just review and create this. Let me click on create. And while this is getting created, I will create one more resource, and that is a virtual machine. All right. I'll create something called as an SHIR VM. All right. So this is to show you how you create a self-hosted integration runtime. What is self-hosted integration runtime? I'll touch upon that also. I'll explain it to you from the very basics. All right. But before we get into self-hosted integration runtime, to understand what is integration runtime, right? One thing that we need to understand is what all resources are required. So basically what I'm trying to do here is, let me draw the scenario for you. It's getting created, right? Virtual machine, create new virtual machine. Or I think I can use the same Terraform VM also, not a problem. So I'll start it. All right, it's currently stopped. Click on start. All right. So what we've understood until now is that data movement along with data transformation, what does it require? It requires compute. Compute means CPU and RAM. Without compute, I cannot move the data, right? It's not that I do not need any processing power or CPU or memory. And without that, I can just move my data from one place to the other, right? Even when you write a very simple program, right? Whether it's a Python program or a C++ program, right? C program. Even those programs to execute, they will take some of the memory, right? You would already know that even if you want to run very small programs, right? Let's say calculating something or doing something, it will take some memory. So these are much larger operations, correct? These are much larger operations. Data movement and data transformation is a much larger operation if you compare it to a simple, uh, let's say addition, sum function or subtraction function, right? So therefore, compute is required. Now, while creating the Azure Data Factory resource, at no place Azure asks you to create compute. You are not asked to create any compute, right? For example, when we created a virtual machine, I create compute. When I create a SQL database, I create a compute, right? When I create a dedicated SQL pool in Synapse, I created compute. So in majority of the resources, I will have to create my own compute. But that is not the case with ADF here. So any resource you create, you have to define the compute also, right? If you remember in SQL database, we created the serverless SQL compute. In virtual machine, I select how much how much CPU I want, how much RAM I want. In dedicated SQL pool, we created something called as uh, DWU, right? Data warehousing units, right? So the DWU was there. We can select from multiple options that you have. So any resource you create that requires compute, Azure will ask you to create the compute. But I just created Azure Data Factory resource in front of you, and all I gave was just the name, right? If I show it to you again, this virtual machine is started now. Let's connect to it also. Let me download the RDP file. If I go to data factories, right? This is the data factory that I created. If I click on create again, just to show you, basic details asks for subscription, name, region, version. Git configuration is basically to connect it to a version control system. Networking is there. Advanced section is there, but that already talks about encryption. Tags are nothing but you apply a key value pair to for the billing purpose, and then review and create. So at no place Azure Data Factory asked me to create a compute. And that is the whole benefit of using Azure Data Factory, that Azure will provide the compute from backend. All right. So Azure provides the compute. This compute is never fixed. It depends on your logic, whatever data movement you've defined, whatever data transformation you've defined. Based on that logic, the compute will be provisioned. If there is a requirement to scale up or scale down the compute, who will take care of it? Azure. Azure will take up, any scaling if that is required. Azure will take care of it from the backend itself. You don't have to do anything. This type of compute that Azure provides, Azure provided compute in Azure Data Factory is called as Azure Integration Runtime. Correct? Now, within the Azure portal, this name may also be used as Auto Resolve Integration Runtime. All right. Now, this Auto Resolve Integration Runtime will have something called as a type, and the type will always be Azure. Therefore, we also refer it to Azure Integration Runtime. All right. So the compute that Azure provides you by default for your data movement, for your data transformation is called as Azure Integration Runtime. It's the name of that compute, right? So if I go to my data factory, let's see, I already created data factory resource. Let me open it. Let me launch the data factory studio. Now within data factory, if I go to the manage section on the left hand side, there is something called as integration runtimes. All right, this is where all your integration runtimes, whether it's the Azure integration runtime, the default one. Now you see this is auto resolve integration runtime and the type is mentioned as Azure, right? It is currently running. It will always run, but it is not attached to you. Its billing is not attached to you. All right, it will always run. And related section shows 0 because it is not being used anywhere. Now integration runtimes are used by many services, right? Within data factory, whenever you create a link service, it will use Azure integration runtime. Link service will define the integration runtime because that is where you are connecting to data stores. All right. So link service is helping you establish that connection and it will also help you with data movement and data transformation. All right. So now what happens here is, let's see. Link service, you understand? Sherry, you understand what link services are?
Yeah, Shreyas, I'm following.
All right. Link service is basically from your ADF. There are multiple types of sources, like I want to put data into a warehouse. I want to put data into a data lake. I want to put a data into the database. Now this could be Azure SQL DB, or it could be Oracle DB, right? Multiple types of databases are there. Or let's say I want to put it into Snowflake, right? Another data warehouse. So this is one connection. This is one connection. This is one connection. This is also one connection. This is also one connection. Now from ADF, what you do is the service that lets you connect to these different data stores is called as a link service. We've already created many link services, right? We have connected to a SQL data warehouse also. We have connected to a data lake also. We have connected to an Azure SQL database also. These 3 link services we have already seen, correct? Now, Azure integration runtime is good when you want to connect to cloud-based resources, not link services. The integration runtime, the Azure integration runtime, which we also sometimes call as AIR. So this compute is really good when your data is present in a cloud environment, right? When you want to, let's say, get data from a SQL database hosted on Azure, if you want to get data from any other places, right? So it's really good. But when you want to get data from on-premises environment, then this Azure integration runtime is of no use. All right. It doesn't help in that case. Whenever you want to get data from on-premises environment, this Azure integration runtime is now useless. All right. You cannot transform your data, you cannot move your data from on-premises environment using Azure Integration Runtime. So what we have to replace it is something called as SHIR. S stands for self, H stands for hosted, integration, runtime. Let me write self also in caps. So SHIR stands for self-hosted integration runtime. All right. Self-hosted because you need to install it on your machine in the on-premises environment wherever you want to create that connection. With Azure Data Factory, you install an application. The name of that application is also very simple. It's Microsoft Integration Runtime. So we have this application called Microsoft Integration Runtime that you need to install on your machine. So we'll try and understand, all right, the self-hosted integration runtime now in more depth, right? Now, we all know that for many years, companies have put most of their data, right? All of their information and most of their information in their own computers and own servers, right? Companies tend to do that. They were not forced to do that. That was the only option also available because before 2010, cloud computing was not very popular, right? So historically, companies have always used their own computers, their own servers, creating their own data rooms, right? Or server rooms, as you call it, or data centers, you call it, right? And they have been keeping this data there. And these machines, wherever they store it, right, it's physically located within their own buildings, within their own campuses, whether it's an office building, or a special computer room, as we call it, as a data center, right? And this environment where you are using your own computers, your own servers, is called as on-premises, right? Own computers, own servers in your own location is called as on-premises. This is how you define on-premises, right? It's like your house, everything inside your house, your furniture, your bed, your kitchen, right? Everything is yours, right? It's your private physical space, and that is what the organizations also wanted, their private physical space, right? Now within your house, you will have walls, you will have doors, you will have all the locks and everything. In the same way, also companies on-premises network also will have its own secure space. It will be protected by digital locks. It will have firewalls, right? Security will be there. Now, then came cloud, correct? And when cloud came, we started using, instead of private personal physical space, we started using something which is a shared public space.
So,
That is the
Shreyas,
cloud.
so what
Mhm.
will happen when this application goes down, like the Microsoft integration runtime, right? So we will
It
be
generally,
having multiple agents in one environment, like a one
Mhm.
run environment, or
See, generally, when the pipeline execution starts, integration runtime is important, correct? If integration runtime is, let's say, down, that means your host itself is down. All right. So the pipeline execution will fail. It will obviously retry again. All right. And then if the machine has gone down, then it's a separate scenario altogether, right? Where you have to worry about getting your machines up and ready, right? Backups of your machine, whatever it is, correct? All right. So as long as the
Mhm.
machine is working fine, the integration, self-hosted integration runtime, the agent will also work fine on the machine.
Okay.
All right. Yeah, fine. So then we had cloud, right? Where everything is now managed by companies like Microsoft, or AWS or GCP, right? And when your company, it uses cloud, right? When it's renting a small secure space on these big data centers, right? So there's a wall between the two worlds now, right? Now we have a challenge. The on-premises world is a private and a locked world, whereas the cloud world is a public and accessible over the internet world, right? And there's a firewall also between them. So this wall is designed to protect the private office network from public internet. That is what you do. All right. Just 1 second. Yeah. Now, with self-hosted integration runtime, right? What are you trying to achieve? Right? What do you want? So what happens when a company wants to move their data from this private cloud to the public space? But then in between, I have the firewalls also, right? They might want to copy their daily sales record from a server which is kept in their office to, let's say, Azure platform, right, for more powerful analysis. So how do they get their data safely through that security wall, right? Because this firewall between the public and the private space, right? It is designed to protect your private network, correct? Firewall is always designed to protect your own network, not the internet. I don't want to protect internet, right? I want to protect myself. So it's a locked front door into your house, into your network. Now, Azure integration runtime here, what it does is the default, right? The built-in integration runtime, which is the Azure integration runtime. It's really good, right? And the limitation also we discussed. One major limitation that it lives and works entirely inside the cloud world. All right, Azure integration runtime totally works in the cloud world. All right, it is a worker who's already inside this giant secure storage facility, right? The Azure cloud. And this worker is excellent at moving boxes from one storage unit to another storage unit, right? Within the same facility. Within Azure, it will be able to do it. Within cloud, it will be able to do it. If your data is already in Azure and you want to move it to another place in Azure, the Azure integration runtime is a perfect tool for the job, right? And that is what we've been doing until now. We've been moving data from data lake to data lake. We move data from data lake to database, right? We've done that. But what happens when you ask Azure integration runtime to go to your private office and pick up a box of data? The worker can't do it. All right. They will walk up to the front door at your office building, that is your firewall, and find that this door is locked. I cannot go. I cannot leave the local area. Right? They don't have the key, and the security guard would let them go out also. So the Azure integration runtime has no way to reach inside your private on-premises network. All right. And that is where the self-hosted integration runtimes comes in. Since the cloud worker can't get in, we need a new strategy. What if we could hire somebody who's a trusted worker who's already inside my office building? If somebody is already inside my private and personal space, right? They can move the data, right? They can do it, right? We could give them special communication to go securely to the cloud, and their main job is to handle the data inside the secure walls of my private network. And that is what self-hosted integration runtime is. It's not a physical person, of course, right? It's a small secure piece of software that you install on your own computers or on your own servers inside your private on-premises network. That is why we call it self-hosted, because you're doing it within your own network. You are installing it within your own network. Therefore, self-hosted integration runtime, because it provides compute. All right. So once installed, it will act like your trusted insider. It is your bridge, your gateway, your secure messenger that will connect your, let's say, private office network to the world of Azure cloud, right? And it will be able to do that. How does it do it? So you might be wondering, right? If my office firewall blocks all the incoming traffic, how can Azure Data Factory talk to self-hosted integration runtime? So because what we are trying to achieve now here is, this is your home. This is your machine. On this machine, I am going to install this SHIR, right? This is cloud, right? Obviously, it's not a cloud. It's a physical location where the data center is, but let's assume it's cloud. Here I have my ADF, and I want to access data from my on-premises environment into my ADF, right? So this connection of home and cloud is made possible by SHIR. It is made possible by this. Now, the self-hosted integration runtime does not wait for the cloud to call it. It knows that a firewall would block that incoming call. Instead, as soon as it starts running, the self-hosted integration runtime will make an outbound call. It will start making these outbound calls to my Azure Data Factory. All right. So most firewalls are configured to allow outbound traffic, right? They generally try and block the inbound traffic, but you can allow outbound traffic, right, from your firewall in order to activate it. All right. So that is fine. Now, let's see how you install this on a machine and then connect it to your data factory. So I'll show you. So to demonstrate this, I have one virtual machine which I will treat as a personal computer. So this Terraform VM, I will treat this virtual machine as a personal computer. Let's click on connect. So I'll connect to the virtual machine and then I'll show it to you. So I have the virtual machine up and running now. I'll just bring it to the screen. Wait. All right. So this is my virtual machine. All right. This is Windows Server Edition. So I'll just close this server manager. This is fine. So if you search for Microsoft integration runtime like this, so this is a VM, right? I'm opening the Terraform virtual machine here. If I bring it here, you would be able to see, right? So this is a virtual machine. I'll maximize it. So I'm within a virtual machine now. So within this virtual machine, I searched for Microsoft integration runtime. Let me put download also. So download Microsoft integration runtime and click on download. So then it will give you a version to download. I think we can go with this integration runtime. Right, this is the latest one, 5.57. I'll download it. All right. So let's install it now on my machine. Click on next, accept, click on next, install. All right. So it's done, right? So integration runtime is installed. Now what this integration runtime is going to help me achieve is, so what I said was that this is a virtual machine that I have created. This virtual machine will act like my personal computer, and I'll treat this virtual machine as my personal computer, and I'll show you how you can connect. So what we did, we installed an application here called self-hosted integration runtime, right? Not the self-hosted integration runtime, but Microsoft integration runtime. I installed it on this machine. Now this software will help me connect to ADF. All right, let's see how. Okay, let me establish the connection with the computer again. So the good part here is that the computer, whatever we were running within the machine, right, it'll still be up and running. It will not be a problem there. So there's multiple ways of connecting to it. One is I can just copy the public IP, open the remote desktop connection on my machine. So I'll paste the public IP address over here, 4.247.16738, 4.247.16738. If I click on connect. So in Data Factory, what you need to do is, in order to connect your Data Factory over here to this virtual machine, right? So this is the virtual machine that we created. Let it load. What you have to go to new, and in new I have to go to Azure self-hosted. Click on continue. Select self-hosted. Click on continue again. I'll call this SHIR, right? All right. Let's click on create. All right. Now self-hosted integration runtime is created. The authentication key, what it is used for, let's see. If I come back to my virtual machine, let me open internet and sign in without your data, confirm and continue. Continue without Google data, this is fine. Confirm, start browsing. Download Microsoft integration runtime. I'll select this. Let's download it and install it again. Download, select the version, click on downloads. It will be done within seconds. Minimize this. So here we get two keys. All right. Then there is the name of the node itself, auto update, sharing, right? I'll tell you all of this. Let's just have the virtual machine ready first. Okay, so I think it's downloaded now, or it's getting downloaded. I can go to the file system within my virtual machine. It's here. Let's open it from here directly. Preparing to install. Let me get rid of the server manager also. Click on next, accept, next, next, install. Just give it a minute. It will be installed. Just wait for it to get completed. All right, finally it's done. We'll click on finish. And now my integration runtime will open up. So we'll have to configure it. So this is your Microsoft Integration Runtime Configuration Manager. This is what you're going to use to connect to your data factory. Now the only thing it asks for is the authentication key. Where is the authentication key? Authentication key is over here. All right. You can use either key 1 or key 2. Anyone you can use, or you can regenerate the authentication key also in the same manner we did it for the storage account. Let's copy key number 1. All right. And go back to my virtual machine, and I'll paste this key over here. All right. Let's click on register fast before any more problems we face. Right. So what you have to do, you have to click on register and see now SHIR VM is connected to SHIR. All right. I'll finish this. Let's click on finish. And when I come back now to my data factory, right? Let's see. If I close this, I am able to see my self-hosted integration runtime over here. It'll take some time, right, for it to be available. Within, I think, some 5-10 minutes, it will show as available, right? Because it's taking up that time over here to set up. We'll click on finish, and it's done. So it's now connected to the cloud service. Once this is finalized, if I go back here now, right, and if I refresh it, within some time, it will start showing as available. Let it initialize completely. All right, so it's running finally now. Limited running, all right. SHIR self-hosted, this is fine. You can see the details also, right? So it's now running, all right. So my self-hosted integration runtime at least is running now. Fine. So we'll stop here, all right. I'll see you guys tomorrow. Thank you for joining in, guys. All right, so now it's running, right? It's in the running state now. If you refresh it, now we are going to use this self-hosted integration runtime to move a file from my on-premises to Azure environment, right? So I'll go to storage account, and I'll quickly create one new storage account. Again in demo RG, I'll call this demo data lake 001. Right, it's there. East US standard instead of geo redundant, locally redundant storage. And within advanced, I'll go and enable hierarchical namespace to create this as a data lake. All right, not just a normal storage account. We'll just take 2 minutes to get created. We'll just wait for it. Click on create here. We'll just wait for it. It's almost done. So this is also done. Let's go to the resource. Containers, and add a new container here. And I'll call this data container. Click on create. This is done. Now one thing I'll do is I'll go to access control, and I'll give my data factory access to this particular storage account. So if you search by blob, you'll get storage blob data contributor. So we've already done all of this, right, in the previous sections when I was showing you how you give access onto your storage account. So So it's a managed identity. If you select the members, you will be able to see the managed identity from the drop down. So there's a data factory resource here, and I see data factory. Click on select. What I'm giving storage blob contributor role to an IC data factory onto the storage account. Just review and assign this. And one more change I'll make is in the setting section, I'll go to configuration now. So here I'll have public access disabled. I'll enable it, blob anonymous access, and save it. All right. So if I go back and come back here, I should see, okay. So this happens sometimes. That is why I went back and came back. Even after saving it right, it does not get saved in the first attempt. So you have to try again. In second, it will always work. So then, now coming back to my data factory, I'll create a pipeline now, right? So I'll click on create new pipeline. And here I want to add a copy data activity to move the data from my on-premises environment to, so I'll call this on-prem copy, right? So that is the name of this activity that I've given, or sorry, pipeline that I've given. And my source now, I'll have to create the data set along with the link service. So I'll click on new. And now I will be connecting to a file system. All right, I'll select file system, click on continue. The file is in text format, so I'll select binary copy, click on continue. On-prem source. On-prem source. I need to create a new link service. And this new link service is basically to help me connect to my on-prem. All right. This link service that you'll be creating here will help you connect to your on-prem resource. All right. So for this, what you have to do is you'll have to go back to your virtual machine now. All right. So let's open the VM. One thing I'll do here is this connect via integration runtime. I'll select my integration runtime now. All right. So instead of selecting the default Azure integration runtime, we have to change the integration runtime because now we want to connect to the virtual machine here. So let's remove this. And what I'll do is I'll copy this path, C data. All right. C data will copy and I'll paste it over here in the host with the location of wherever you want to connect to. All right. Now the username and password for that virtual machine, I'll say VM admin was the username, right? And password I'll put. If you test connection now, let's see what happens. Let me load. This username and password is your virtual machine username and password. All right, this is a username and password for the virtual machine that you created. So when we're creating the VM, right? If I run this again, see, it asks me to enter the username and password to connect to the VM. So this is VM admin and the password. All right. So the connection failed. It says access is not allowed. Now, what is this access? Who's blocking this access? So what we have to do is, in order to enable this access, this is basically a folder path validation that we need to change. Now, where this needs to be changed, it needs to be changed in the virtual machine itself. All right. So when I go back to my virtual machine and I go to desktop, I go to this PC. If I go to C drive here, after C drive, let's go to program files, right? In program files, I'll be able to see Microsoft integration runtime. I have to open it. I have to go to 5.0, right? And here I have this shared folder. All right. So within this shared folder, I need to run a command. So if I want to open command prompt in this location, right? In some machines, you will find it over here, open a command prompt in this location. Or what you can do is you can click over here and just type CMD and hit enter. So what it does, it opens a command prompt in that very same location wherever you are. So I'll zoom in a bit. Now you have to put in a command here. All right. That command, you can save it. All right. It will work with all the machines right? Whichever machine you are using, you have to use the same command. So what's the command? It's dot backslash. Let me type here. It's dot backslash dmg cmd. All right, dmg cmd dot exe, and then hyphen capital D disable, capital L local, capital F folder, capital P path, capital V validation. All right, you will have to run this in this location. So you either open command prompt and then traverse to this location, or you can, as I said, right, just go to C drive, open C drive, open program files, open Microsoft integration runtime, open 5.0, open shared, and just go to this top search bar. No, this path, wherever you have this path right on the top. You just type cmd and you hit enter, and it will bring you to this command prompt over here. And here you have to type this command dot backslash dmg cmd dot exe hyphen disable local folder path validation. That's it. Just hit enter, and it's done. All right, this is now done. If I open my if I open over here my data factory again and try to test the connection again, let's see what happens. It'll take some time because now it's not just validating within the Azure resource, it's now trying to validate onto a virtual machine. All right, so it'll take some time. Until now everything is clear or not, whatever we did. Now it says connection successful. All right, so why is this connection successful? Because I went to that shared folder, right, and then I executed that command dmg cmd.exe disable local folder path validation. I'll create this link service now. So it's created. So I'm now in C data. If I try and open browse this location, I'll be able to see my file. All right, the file that I had kept in that location. So once the file loads, right, you'll be able to directly see your on-prem environment through your data factory, through cloud, through Azure, right? So what are we doing? We are connecting to that virtual machine now. See, sample text, it's present here. Click on OK. So this is the file that I'll be moving. So my on-prem source is created. I'll go to the sync, a new sync data set, and I want to put it into my data lake storage. Click on continue. In the binary format itself, I'll put this as cloud destination, right? Sorry. So on-prem source, cloud destination, new link service required for data lake. I'll select my data lake here. Let me select the subscription first. Then let me select the storage account, demo data lake that I created, and let's click on test the connection. Rest everything you leave as it is default. So create this link service. So now I'll just select the container where I need to save this. So I need to save this in the data container. I'll select it and I'll click on OK. And this is done, right? My pipeline is created. I can click on add trigger now to start this. What happened? Okay, wait, sorry, I did not publish it. So first you have to publish it, right? Without publishing, it does not get saved. Once it is published, we can run it and see the changes. So publishing is successful. Let's trigger it. Trigger now. Click on OK. So it's now running my pipeline. I can view the pipeline run. So this is my virtual machine, right? This is inside my virtual machine. So what I'm doing, I'm within the virtual machine. If you want, I can minimize this also and increase the size like this so that, you know, it does not look as a part of my system. All right. Now here, if I go to my folders and within C drive, I have created this folder called, where did it go? Where's the data folder go? I think it will be on the top. Yeah, data folder is here, and this sample text present in my virtual machine. What I'm doing, I'm trying to move it to Azure. So now it is also successful. I can see the output. data read, data written, files read, files written. Let's go to the storage account and confirm whether the data movement between the on-prem environment and my cloud environment happened or not. All right, so if I click on data, I am able to see the sample text. If I open this file, I should be able to see the text that I had written when I go to the edit section. This is the demo for SHIR. So is this clear now? How do you install the integration runtime on personal machines and then make use of it in order to connect to Azure and then move your data between on-prem and cloud? Is that clear? So for any interviews, if you sit right and the interviewer is asking about data factory, and the question is how do you move data from your on-prem to cloud using Azure Data Factory? How do you do that? You use something called as a self-hosted integration runtime, right? You install the integration runtime on the machine from where you want to move the data to Azure, and then from that machine you just create a link service and it will help you connect to that location wherever your data is, and the Azure pipeline, data factory pipelines basically will help you move that data from place A to place B. Is this clear? Does this make sense, Shiva?
Yeah.
All clear on moving data between on-prem and cloud now?
Yeah, like even for like a cloud to on-prem also the same, like instead
Same
of
thing, same thing, same thing,
same
same
thing,
thing.
right? Yeah.
Absolutely. All right. So if
Yeah.
I want to do the same thing here and move my data from cloud to on-prem, I can show you the reverse also. Let's do one thing. Let me open the virtual machine, and let me delete this file. Yes. Now what I'll do, I'll go here. Let's create a new pipeline, not edit the same one. So here I'll say this is cloud to on-prem and minimize it. With the copy data activity, I already have the link services. Yes or no? I already have the link services to the two locations. I can use the same link service. I'll click on new. So this time my data starts from the source is going to be my data lake storage. Click on continue.
Yeah.
In binary format, click on continue again. Let it be P2 source, pipeline to source. So I'll use the same link service and I'll select the location of my file, which is present in this data container, right? And this is sample text.txt, right? So either I can select the file also, I can click OK here also. But if I click OK, then I'll have to give a wildcard. All right, how is wildcard given? Let's see. So as of now, I have not selected any file name that needs to be moved, right? So that is why when I come here, which file to move, I can say wildcard file path. So what is the wildcard name? I can give star dot star. So what it will do, it will copy all the files. If I do star.txt, it will copy all the files that have a txt.txt extension. If I do star.csv, it will copy all the CSV files, irrespective of their name. All right. If I do parquet, it will copy all the parquet files. So if I do star.star, this means CSV, Parquet, whatever file format you have, whatever name you have, all the files will be copied. So let's try this with star.star. All right. And then when I go to sync, I'll say it's a file system now. Click on continue in binary format. The link service already exists that I created, and the location that I want to copy it in. Let's see. It will take me to the root folder. If I want, I can create more folders inside it to show it to you here, but it will only take you to the folder, to whatever path you had put in the link service. It will only take you to that location. Yeah, so this is a root folder. I'll click on OK, right? So see data and it will be saved over here. If I want to give some other file name, I can do that also, right? Because this is where it's going to be saved, right? We'll let it be default. I'll click on OK. This is done. Let's publish the pipeline. Click on publish. Done. Let's trigger this. Trigger now. Okay. So from my C drive, right? I've already deleted the file. Now let's see what happens in the pipeline. The pipeline is running. Do the pipeline run? You just wait for it. Just wait for it. All right, so it says succeeded. So now if I open my virtual machine, so this is my virtual machine, I'll maximize it. So I'm within my VM. I'll go to C drive. I'll go to data. I'm able to see sample text. All right. Clear?
Got it.
Yeah. Right. Very simple process. So today we've completed what? How do you connect to on-prem and move your data? So now essentially what we have seen is all different ways to move your data, right? Cloud on-prem, right? Most of it done. From cloud to cloud, we saw different services moving the data, right? Now, for today, we'll stop here, right? I'm really sorry for the internet disconnectivity thing, but I think now it works fine. So I'll be using this machine only. So it will work. I don't think we'll face any issues later on, right? So from tomorrow onwards, very important. Please do not forget to join, right? We'll be starting with the transformations using data flows, right? We have to see various different transformations, right? What all are the capabilities of Data Factory, and then we'll move to tumbling window. Also, we'll move to, what do you call it? Incremental data loading, right? Using Azure Data Factory. How do you do incremental data loading with databases also, with files also in data lake, right? So if I want to do incremental data loading from one data lake to another location, or if I want to do incremental data loading from a database to another location, both of that also we'll need to see along with the different transformations. All right. So for today, we'll stop here. Tomorrow we'll continue from here. So I hope all of you are in sync with what we are doing and what we are covering, right? All of you have understood Data Factory at least as a extraction and a loading tool. You understood it. How does it copy data from one place to the other? What all is required? Creation of data set requiring a link service, right? That all is clear for everybody. Yesterday, I think we also did movement of data from on-premises environment to Azure and from Azure to on-premises environment using self-hosted integration runtime. For those of you who've not gone through it, please go through it. It's very important, right? Because as somebody who's working, with Data Factory, you have to know some of the basics, right? When it comes to connecting to different sources, and on-premises is a very important source to connect to, right? In a time where multiple organizations, when I say multiple organizations, right, majority of them are looking to move their assets from their on-premises environment to the cloud environment, right? Because when it is in the cloud environment, you get better data security, you get better data governance, you get, it becomes easier for you to integrate it with the data engineering tools that we have been covering. So along the same lines, we'll see more of it today. But before we go into that, right, my question today to all of you is, why Data Factory? Why do you want a low code or a no code solution where you could have gone and written, everything, all the transformations could be performed through code. The data movement could be performed through code. You can write scripts to move data from one place to the other. Then why, or what do you think is the benefit of using Data Factory? Anyone wants to try it out?
Complexity.
Complexity is one of it, yes. Writing scripts is a complex task. Absolutely. You need to have a lot of expertise in a particular programming language, right? That is one of it, yes. But what else?
Easy to use.
What could you
like
repeat?
development friendly.
I did not get you. Development friendly, yes.
No, development. I mean, easy to use.
Easy to use. Yes. Low code, no code solutions are always easy to use when you have drag and drop options, right? It's always better than your, conventional writing the code and writing those big scripts, right?
And reusability for the
Absolutely right. You build modular, uh, artifacts here which could be reused. Your link service could be used, right? Because when you're writing code and there's a different script for all the different transformations, then you have to define the same transformation again, right? You have to define the same connection again. You have to define the same logics also again. But here, absolutely correct. You can reuse a particular copy data activity, right? From the same source, you can reuse it in multiple pipelines.
And
Correct.
automation.
Multiple data processing,
Multiple data processing also, yes.
like data spark, PySpark, data.
That also you can integrate over here, correct? But that you can do through scripts also, right?
It's automation.
Automation also, yes. Let me tell you one thing. There's one more benefit to it. That is the major problem that multiple organizations faced. Let me share my presentation so that I can explain it to you. Or we can, no, let's go to PowerPoint also itself. Yeah. So there is one large problem that has happened. Now, all of you have worked in an organization, yes or no? All of you have some experience of working in an organization,
Yes.
correct? What is the most difficult code that exists for an organization? What do they call it?
Called security.
Security is there, yes. Security is, not what I'm asking about.
Okay.
Leave security aside. Uh, have you heard about legacy systems, legacy code, older
Yes.
code? What companies today fail to achieve is to modernize their legacy environments, correct? A code written in 2000s, early 2000s, may not be supported today, correct? That is why everywhere you go, people talk about Java code modernization, legacy code modernization, mainframe modernization. You heard about it or not? Somewhere or the other, you would have heard about it. Now, what does that mean? That means that whatever tools and technologies we are using today, whatever, not just tools and technologies, basically the code that you're using today may become obsolete in the near future. Yes or no? What do I mean by that? A code, what is the current version of Java? Does anybody know? The latest, I think it is Java 24 or something,
Yes.
24,
right?
yeah.
Java 24.
24
had
and
a
24.02.
Yes, right. We had Java 21 also. We had other versions also, correct? Now that means that these languages, they constantly evolve. Your scripts, or let me just use programming languages here, they continuously evolve. The functions, that's syntax, the libraries that you have today may not be supported tomorrow. Yes or no? Can happen because it's continuously evolving. The features and the libraries and the syntax that we had, let's say in very old version of Java, may not be supported today, correct? And that is the main problem for Java based modernization, right? Or any language based, right? I'm taking Java as an example here. We have nothing to do with Java, correct? So when you come to drag and drop tools, right? GUI tools, what does it offer? It gives you a visual interface. For example, when we defined copy data activity, did we write any code to copy the data anywhere? Yes or no?
No.
Did we write a single line of code anywhere? The answer is no. You don't have to. It's not required. Right? Just a simple, configurations, selecting from the drop downs. The most we would have given is, I think, in the wildcard, we had to write star dot star or star dot txt. That is the only thing that you had to set from your side, correct? When you define this copy data activity, do you think that it's just UI doing its thing?
No.
Can computer understand UI based elements? No. Computer understands only programming languages. Yes. Computer can only understand programming languages. It can only understand data in bytes or your binaries, correct? Ones and zeros. That is the only language computer understands. So therefore, I cannot say that these UI elements are actually performing the task. Each UI element has a backend code. We've just encapsulated this code into a UI element, correct? Do you understand this point? Every UI element has a backend code. What we select through configuration is nothing but giving parameters to those code, correct? So every UI element will have some code in the backend, but I don't have to write it. Who needs to write this code? Microsoft. It is Microsoft's job to convert my UI elements into the backend code, right? Now, if the language changes, let's say 5 years from now, there has been certain changes in the language, Microsoft will adjust the code accordingly. I don't have to change the UI elements. Does it make sense? Yes or no? For example, if I go to Data Factory, also I understood the reason as to why the data Azure Data Factory also we tried yesterday. It was running very slow. Virtual machines also we tried yesterday. It's running very slow, right? Azure portal. If I'm creating resources, especially in US regions, it's running very slow. Do you know the reason? Anybody here knows the reason? I'll show you one thing. Wait. So who was there in the last two classes? How many of you were present? Last, I think 2 to 3 classes. We are facing a lot of issues to connect with Azure services. You saw how difficult it was yesterday and day before yesterday for us to connect to Azure resources. And I was trying my internet connection. The internet was working fine. So it did not make sense to me at that time, but it looks like there has been a subsea cable cut. Is anybody aware of it?
Yeah,
No?
I'm aware of that. Yeah.
Model.
Yeah. So there was, as I have told you, that Azure has a global network, right? I'll show you Azure Global Network. So this is the global network, the backbone networking infrastructure for Azure, where if there is an image here, yeah, like this, right? This is, I think, the other continent, Europe and Africa, and this is your North America. And there are cable lines, which have been put into the sea. And these cable lines are basically carrying the network. And when we are trying to connect to Azure, there were some problems with it because there were an outage due to that. So if you go and Google, Red Sea cable cut, so you'll see it has affected, the Azure's internet connectivity. And that is why we were facing so much of issue to connect to our Azure resources, right? So that was one reason. Coming back to Data Factory now, what I'm trying to explain to you is, even though in the Azure Studio or the Data Factory Studio, we create UI or we use UI elements to create a transformation or to create a pipeline, in the backend, it is using code itself, right? So if I see a pipeline here, we created this on-prem copy activity, right? So this copy activity will have some code associated with it, right? In whatever language Microsoft understands, language is not important to us. But can you imagine if tomorrow the language changes, then it is not your headache to modernize your code, right? It is Azure's headache. It is Microsoft's headache to make sure that the current code, when the syntax has changed, when the libraries have changed, the functions have changed, it is Azure's headache now to change the backend code. Understood? Yes or no? Make sense? Now, whatever we create here on the Azure portal, also in the Data Factory, has a code associated with it, right? There is always a code. Why? You would have seen Git integration. If I go to manage section, you would see Git configuration, right? Git is nothing but a code versioning system. Yes or no? How many of you have heard about Git, GitHub, Bitbucket? Have you heard about it? GitHub, I'm sure everybody would have heard about it.
Yes. Yes, a repository.
Yes. What do you do in that repository? You back up your code.
Yes.
You create a central repository or you create a remote repository, and you make sure that whoever wants to work on that code has access to that repository and they can download the latest version, which is
merge it.
basically nothing. In their own local machines, they can create a local repository also, right? So if they make
Yes.
any changes to their local repository, that is, so it means like I have a central hub where my code is present. I'll show you. So it's like this is a remote repository. So this is where all your code is present, right? And this is let's say 3 developers are working on it. So they will have their own local repository, LR. right? So this will be their local repository. So whatever files are there, let's say in my code, I have only HTML file, let's say index.html. So everybody will have index.html. All will have this index file, all right, in their local repository. That is, they have cloned it from the remote repository. We call it clone. Yes. Or now what happens is, let's say developer 1, developer 2, developer 3. Developer 1 implemented a functionality. Let's say he added the nav bar to my website. Nav bar is the one that you see on the top where you have the logo, contact us, about us, all those things are there, right? Pricing and everything, home, login, profile. So that is a nav bar. He designed the nav bar. Now what he'll do, he'll push his code to the remote repository. That changes the remote repository, and now the code becomes code dash. Code dash means updated version of the code. What others have to do, they have to pull it again. And now their code, their local code will now become code dash, right? So this is how GitHub works. There's a remote repository where everybody is, pushing their code. Once it is approved, it is working fine. And then local repository, the same copy of the same file they will have in their local environment also, and they'll be working with it. So this is what GitHub does, right? It's one cloud platform that helps you manage your code versioning system, right? Version control also we call it. Why does my data factory need to connect to, let's say, GitHub or any other Git-based technology? If I go to configure, I can see what type of repository it is, whether GitHub or Azure repository. I can connect with both of them, right? CI/CD also you would have heard about. What code gets backed up? If I am in data factory, I am saying essentially I don't have any code, correct? I am using UI elements. Where is the code? So if the code is not there, what am I actually going to back up to this GitHub repository? So the answer is, whatever UI elements you create, they will have a corresponding JSON code. All right. This JSON code is basically used to describe that pipeline. So for this pipeline, this is the JSON code. So if I click on this button, I would be able to see the JSON code for my pipeline. Now pipeline will mention the data sets. So if I go to data sets now and I open this, even the data set will have a code, right? So this is the data set, right? So it mentions that it's a file server, link service, reference, right? What it is, correct? It's a data set. If I go to link services also, I'll be able to see this. So this is my link service. If I click on this code, I'll be able to see the link service. So this link service is created with my data lake. So I'll find that this is the name. The type of this link service is that it's a data factory link service, right? And the type is blobfs. That means it connects to the data lake. What is the URL? This is the URL to the data lake and the encrypted credential to the data lake. So basically, whatever UI elements you create, whether it's a link service or a data set or a pipeline or any other artifact for that matter, there is a corresponding JSON based code for it, right? Now, when I integrate my workspace, integrate this data factory workspace or data factory studio, whatever it is, right? I call it workspace. This will get backed up. This code that you see will get backed up to GitHub. All right. So it will mention things like linked services. So under link services, I'll find all the link services. See this one. This link service is for my, yesterday I had created the self-hosted integration runtime, right? So it connects using this self-hosted integration runtime. It connects to that virtual machine, right? It's the type is file server. It's using the link service. The user ID is this. I entered the password also, right? I entered the user ID and the password, everything I did that. So all of that data is saved in the JSON based format. So this is the code that gets copied onto the remote repository. Clear? Make sense? We'll be doing Git integration and we'll see how it works. For now, do you understand what your code is and what gets backed up to Git? But this is not the code that I was talking about previously, right? So for transformation, right, a code would have been written in a particular language, whatever language Azure uses. The connection strings would have been established. The entire infrastructure would have been created, right? So all of that happens through the backend here all itself. So now, we were discussing about data sets and pipelines are done. Now we move to the data flows. So you're working with Data Factory, and I had to show you, how the data flows work. So let me launch the studio. So now we'll start seeing the different type of transformation, right? And there's a lot that you can do with the, data flows. If I go to data flows, go to author and open data flows. So until now we've seen pipelines, we've seen data sets. All right. Now coming to data flow, if I create a new data flow, I can, have multiple sources for it, right? So let's add a single source here. I'll call it source one, and we'll create a data set for it. Okay, it does not exist already. So it's in my not blob storage, my data lake. Click on continue. Let me check my data lake till then. So demo data lake, data storage, I'll go to the container, data container here. And we have multiple CSV files here. We have text file also. We have CSV files also. I'll get rid of this text file. Or I'll just delete this because there's nothing actually within that file. And we wanted to work with these 5 files: customers, orders, products, stores, right? This is the data that we want to work with. So I'll select delimited text, click on continue, right? And so what I'm creating right now, let me show it to you, is a data set, right? Now, until now, we've seen various data sets, right? They are the standalone reusable objects that we are defining within the data factory, right? And it represents a schema, it represents a format, it represents a location as well, right? Data set is nothing but a combination of location, format, schema. Are you aware, Ravi? Is that clear? There's no confusion in that part, at least.
Yes, Reyes.
Correct? Because when we are defining the data set, we also include linked service. So therefore, location is there.
Yes.
After location, we define, the location is basically to the storage service. After defining the storage service, we define which database to select or which table to select or, which container to select. So location, we are already giving. Then we are selecting the type of the file, whether it is a CSV format or a Parquet format. And then we are defining the format. We are also defining the schema of the data, right? It's getting the schema from the connection itself. So data set is where I am defining the schema and everything, the location, right, of either the data source or my sink, right? It's either my destination or my source, right? It can be reused. Data set on the left-hand side can be reused, right? They are designed to reuse across multiple activities. You can use it in copy activities, lookup activities, right? And it connects to the same source data again and again, right? The schema also, it have a predefined schema where I can import the schema manually. I can define the schema, schema manually also, right? And they are managed as a separate object. So if I see here, my pipeline is here and I have a separate object, right? Data set is considered as a separate object.
Okay.
If I select inline, now, have you ever worked in web development, Ravi?
Web development, but I have idea. I don't get a chance.
Okay. Have you? Do you
Mostly
know that?
development and this.
Do you know that there is an HTML file and there is a CSS file?
Yeah, those I know. Yeah.
Right. Very basic.
Yes.
When I do not have a dedicated CSS file, I define something called as inline CSS. That is defining the styling within the HTML file itself. Correct?
Okay.
You're aware of that word, right? Inline means that you're defining it within the HTML file itself, right? I don't have a dedicated CSS file. So the same way, if I select inline dataset, right, that is basically defined within the source or the sink of the data flow activity. So when I'm creating a data flow, if I select inline, so that will be defined here itself within this source. It will be defined. It is non-reusable. Inline datasets cannot be reused. It will not be created over here. All right. Dataset, on the other hand, is reusable, right? So it's not created as a separate reusable object, right? It is very specific to the data flow where I'm defining the source, where I'm defining the data set. it will be defined there itself and used there itself. They are not intended for reuse outside the specific data flow that we are working with. All right. And they don't have a predefined schema also. The schema can be inferred or imported based on the source data that we select or the projection that we have selected. So I'll click on new. I'll select the data lake, click on continue again, select my delimited text file, click on continue. I already have a link service to the data lake, right? And I'll select a particular file. Let's say I want the data. Let me go to the data container. From which file shall we select? Let's select the order file. Okay. So orders.csv. Click on OK. So this is done. I'll click on OK. Now what it does, it will fetch the details of that file over here in this source. All right. So in data flow, the first thing that I'll always have is the source itself. Now you can do a lot of things with source. All right. There's something called as a source option. If there is a wildcard file path that I want to select from the source, I can do that. The main part is projection here. All right. So if you see, there is a column name that is being fetched from my source file itself, the type of that data within my source file, and then there is a format, right? So currently there is no specific format to this, right? If I want to give it some other format, all right, which activity or which function can I use? I can use this cast function, right? So if I select cast, right, there are columns which I can specify the format here now, right? I could have done it there also, right? Let me show you how to do it without this. If I, where did it go? Delete this. If I come here, right, in the source, I can change it from here. I can say that this should be taken, order ID should be taken as an integer, right? Customer ID should be treated as an integer, right? Store ID again should be treated as an integer. All right. Then when I do the data preview, I'll have to turn on the data flow debug mode. But before I turn it on, I'll have to tell you also what the data flow debug mode is. All right.
Okay.
Let me see. The projection is fine. Sorry. Let me open the PPT. Oh, 1 second. Before we go there, right? Let's talk more about the projection, right? So now here, if I go to optimize, I see something called as partition, right? Now partitioning is a concept that you would have heard about, a lot of time, correct? Yes or no? So why should we partition our data, right? Before you understand how the data flow runs behind the scene, you also need to understand a very simple and powerful idea, that is partitioning. Partitioning basically means that you are splitting a big data set into smaller pieces, all right, or smaller parts that we call as partitions or individual partitions. It's like cutting a very large cake into slices so that people can eat them at the same time, right? Without slices, only one person could start eating, and then when they finish, then the second person would come, and then when they finish, the third person. Or if you want to make a mess of it, everybody could join in together and eat the cake, right? But that would be really messy, right? So what we do, we cut the slices and we distribute it to people, and then within 5 minutes they're done, right? So with slices,
Yes.
people will eat in parallel. So partitioning also helps you or helps the system to process the data in a very fast and efficient manner, right? So a partition is nothing but a logical chunk of your data. It is not always a separate physical file on the storage, all right? Sometimes it will look like that it's a separate file in the storage, especially when we work with partitioning in Spark and everything, right? So you'll see in Delta table format also, multiple files are saved or multiple partitions are saved separately. So it's basically a way for, the processing engine, which is in our case going to be Apache Spark, because I've already told you that in mapping data flow, whatever transformation you define, gets converted into Spark code, and behind the scenes, there is going to be an Apache Spark cluster that is going to process my data. So Spark code to process the data on the Spark cluster. All right. Now Spark cluster is basically an architecture, right? So if I have to quickly show you what the Spark cluster looks like, let me open it. All right. So I'll give you a brief idea about Spark because it will be used in data flow. So I'm not sure how helpful it would be to talk about those concepts without you actually knowing what it actually is, right?
Mm.
So earlier what happened was we had Hadoop, correct?
Yes.
Hadoop was my initial big data processing system framework. Have you worked with Hadoop? Yes or no?
No, I haven't worked with Hadoop. I was a
All right.
development and DevOps only.
Oh, all right, all
Development,
right.
testing, and DevOps. Three variations I have done. Java development. After that, I was in Serena automation, and then
Mhm.
DevOps. Now I move to data analysis.
All right, understood. So now, when the big data processing started with the advent of Hadoop, right? So Google released these papers on Hadoop, and they created something called as a map reduce function or a map reduce framework. Now, this map reduce framework was basically how we try to process the data. What is this map reduce framework? It is basically a way of processing your data by actually creating your or distributing your data over multiple nodes. So for the first time, we discussed the distributing computing framework. All right, you understand what distributed computing is? No? All right. Distributed computing means that instead of using one single large machine, I use multiple smaller machines. All right. So rather than putting 1 TB of data here, I could give 10 GB to each machine, which can process it in parallel, right? And then they will all combine their results. So mapping was meant to be how you distribute this data onto multiple. These were called as nodes, right? So your distributed computing architecture would have nodes. Together, these nodes would create something called as a cluster, correct?
Yes.
Together, all of these machines are called as a cluster of machines. So map reduce is the way to process this huge amount of data. What they were doing, we know why it was created. So first was the map step. Map basically meant to break down the data. All right. The map function takes the big data and breaks it into the smaller chunks, right? Those smaller chunks will now be sent to these individual machines to process. All right. Each chunk is processed separately by different computers. The output of this step, the mapping step, right, once it is processed, is usually in the form of key value pairs, right? So if you want to count how many times a particular word appeared in the book, right? So each computer will look at only certain pages, not the entire book. All right. And every word it sees, it will say that, let's say how came. So there's a how, comma one. This one is basically the count of how many times this word appears, right? So label, comma, count. If how comes again, I will update this to how, comma, two, right? So this is how it used to do. So map function, you just have a lot of small, different data sets created out of your bigger data. The reduce step was basically when 20 computers are there in the cluster, and they have calculated how many times a particular word how appeared, right, individually. Now it's time we basically combine all of that, because if I want it for the entire book, I'll have to combine the results towards the end, right? For example, each node was taking a look at 100 pages and book was 1000 pages. So those 10 computers who performed the analysis on all the 1000 pages, in the end I will have to combine the result. So that was the reduce phase, where you would actually combine the result. All right. So that was the map reduce. But there were a lot of problems with Hadoop. All right. Hadoop had a lot of problem. First one, it was very difficult to write your map reduce jobs. It was very complex. All right. So it was a very complex task. People found it really hard uh, to basically write these programs to for the map phase and the reduce phase, right? Now, the second problem was that any intermediate data was being stored in the storage or disk. All right. Any data that had to be written was being written to the disk, and if it was had to be reused, it was being read from the disk as well. Now, reading and writing data again and again to the disk, is it a simple process? Is it a slow process or a fast process? Yes or no? Is it a simple process or a fast process? Fast or a slow process? So reading and writing from the disk is fast. So is a very slow process. All right. This is what we wanted to make fast.
Yes.
And that is where Spark or Apache Spark came into the picture.
So Spark means it distributing the.
Spark also uses distributed computing. Both Hadoop and Spark both use distributed computing. But what Spark introduced was that this Java code that you have to write, very complex Java code, it gave multiple options. You can interact with the compute using Python, that is
Python,
PySpark.
Scala.
You can write Scala code. If you know Java, you can write Java also. If you want, you can deal with it using SQL also, right? So now it is not required for you to only know Java to work with the distributed computing in Hadoop, right? So one problem it solved, correct?
Yes.
The next problem that it solved was that the slow process of reading and writing data from disk, it introduced something called as in-memory processing. All right. So now the data was processed in RAM, and getting or reading or writing data to the RAM, it turned out to be in some cases 100 times faster. All right. In some cases, it turns out to be 100 times faster than the MapReduce. All right, or the MapReduce framework. So using Apache Spark, we were able to achieve speed of data processing that was 100 times faster than Hadoop. All right. And what Apache Spark introduced? The same distributed computing. It had a cluster, right? The cluster would have multiple computers. It's a very simple architecture if you understand, right? And then it will have something called as a master also, or a driver computer also, right? So one computer was called as the driver. The rest were called as the workers. All right. And individually, these computers are called as nodes. Correct. So now the driver would get the code along with the data. It will break down my large piece of data into smaller pieces. These smaller pieces will now be sent to these individual computers.
Who is taking care to create small pieces?
This driver.
Nodes. Driver.
The
Master
driver will
driver.
be responsible. Yes. So we have a driver node here who will break this data down, send it to different workers along with the code.
Okay,
Code is
in
nothing.
PySpark, for example, if you take in Python, if we are in PySpark, we need to be write that differentiation in the code, right?
No, you don't have to select it. The system will define
Okay.
it. That's the job
Okay.
of the architecture. All right. That will happen in the backend itself. You don't have to select anything. If you have provisioned nodes, you will be provisioning one, driver node and multiple executor nodes. I'll show you. So this transformation logic was written through the code. My PySpark code is nothing but me telling, Apache Spark as to what processing has to be done, where the data is present, what is the format of the data, what you have to do, how you have to create the data frame, what transformations you have to do on that data frame, whether it's a filter, whether it's an aggregate, whether it's a sum, whether it's a max, whether it's a conversion or something. I will define all the transformation logic in the code. So along with code, the data was shared, and all of these computers would independently now process my data. And then once processed, this data will be sent back to the driver. All right. Understood? All of this data would be then sent to the driver, where the driver would combine it together as the output data. Clear? Make sense? And it will output the data. Now there are multiple more parts to it, but this is a very simple definition of how it does it. So all of this processing of the smaller data set, it happens in memory, in the RAM. I am not reading or writing data to the disk at any given state. All right. Everything is read from the memory, everything is written, intermediate data is written to the memory, and then eventually it reaches the driver. So this architecture where there is one master and multiple slaves listening to the master is also called as a master slave architecture. All right. It's called as a master slave architecture. Have you heard about it?
Yes, right.
All right.
Master is
Now
like
there
a driver,
master is who
master is the
controls
driver,
everything.
and
Yes,
slaves are
exactly.
like a nodes,
Workers, right?
workers. Yeah.
Now you would hear two things: workers and executor also. Sometimes these two words will be used interchangeably. What it actually is that a worker node, if there is a worker node, this node will run something called as an executor program. All right. This executor program is where the data will be processed and everything. Will get into the depths of it as to what this executor program is, what does the executor program do. The executor program is basically, interacting with the cluster manager, right? So when we get into the depth of it, you will realize that instead of driver directly talking to the workers, what we actually have here is something called as a cluster manager. You would have had some idea about Kubernetes, right?
Yeah, I have some idea.
Yes. So Kubernetes
Yes.
is also a cluster manager. It helps you manage your nodes, correct?
Yes. Yes, there is a
So
lot
the
of
same
containers.
Kubernetes could be used in Apache Spark also to manage this cluster of workers. All right.
Okay.
So there is a cluster manager who talks to these nodes and then lets the driver know that, okay, we have some empty nodes, we can utilize it. Please send me the data along with the code. The driver sends it to the cluster manager. The cluster manager will take a look. If, for example, any of the node fails, right? If any of the node has failed, cluster manager will inform the driver that this node has failed. Whatever data you had shared there, please send it again. I'll give it to some other node. So it's basically a communication that happens between the driver, the cluster manager, and the nodes, right? So there are many cluster managers. There's something called as Apache Mesos. There's Kubernetes. There's Yarn. By default, there is Yarn. Have you heard about Yarn? Yarn is nothing but yet another resource negotiator. It is used in Hadoop also. Yarn is
Okay.
used in Hadoop, right? So multiple are there. You have some native cluster manager also. You don't have to select a cluster manager dedicatedly. My Spark architecture will come with a cluster manager. So if I have to just show you quickly how the Spark cluster looks like. If I go here and let me see if I have a Synapse workspace ready. If not, I'll create one quickly to show it to you. What happened? Okay, this is the problem I'm facing with Azure. Let's create one because we'll be using it. Password for the SQL server that will be created to host the dedicated SQL pool. We've already seen this and we'll create it. let this deployment be completed. So I'll show you. Meanwhile, here, right, we are talking about partitioning.
Yeah.
So now you understand, right, why partitioning is
Yes.
important.
Shreyan,
Right.
for this, we can create all these for this free subscription also we can do.
Yes, 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 yes. You can do that.
But he's showing some charge, right? So that's the reason. Is there any amount deduction taking place or something?
Where is it showing the charge?
Okay.
No, I'm asking where did it show the charge? While creating the resource.
Yeah, while creating it,
To me, it will show, right? I don't have credits. So to me, it will show. For you also, it will show.
Okay.
But you have credits, right? It will deduct it from the
Yes,
credits.
yes. Okay. Got it. Thank you.
All right. Now the thing is, when the Spark does this partition, right? I told you that Spark will come into the picture because mapping data flows uses, Apache Spark under the hood.
Yes.
So you do not manage the Spark cluster directly. ADF will spin it up in the backend and help me with the processing, right?
Okay.
So you'll have, let's say total you have 8 cores, right? So it could be that driver will have 4 cores, workers will have 4 cores, right? Now, if you have, let's say 8 partitions of your data, right? If you have a single partition, if you use, or if you set partition, right, in the round robin manner, or if you want to have a hash, partitioning, dynamic ranges there, fixed ranges there, key based partitioning is there. We'll come to all of this, right? But when you do this partitioning, if let's say there are 8 partitions in total that you want to create, right, and there are only 4 worker cores. So what happens? Let's say one worker has 1 core. So first your 4 partitions will be processed, then the next 4, right? That is why, by default there are total of 8 cores. So that is why you'll have to select the number of partitions and everything very, uh, you know, uh, with a lot of consideration, right? Now there are two purposes. One is source partitioning, one is sink partitioning, right? So in data flows, under the optimize section, we'll see the partitioning. Now this partitioning could be done for the source also, for the sink also. Source partitioning will basically control how the Spark will read and process the data during any transformation, right? How does it impacts the performance? Sink partitioning will control how Spark organizes the output data, all right? In the folder, wherever I have, let's say I have the output location, wherever it is, wherever my destination is, how it will be organized in the destination. That is sink partitioning. Source partitioning is basically you telling Spark how to read this data, read it in partitions, don't read it all together, right? So source partitioning is done for performance during compute, whereas sink partitioning is done for structuring the final data. Make sense? Yes or no? Now, by default, it will always be under use current partitioning. All right, that is the default behavior. If your source, that is a file or a table, already has a partitioning information, if there is already a partitioning key, right, Spark can leverage that. If not, Spark may treat the entire data set as one single partition, especially if it's a small data set, right? Now, when to avoid, or what is this single partitioning? Single partitioning will force everything into one single piece. This will make sure that your source is read as one single input file. It is only nice when you have tiny data set, when you're testing, when you're debugging your pipelines, right? And when you absolutely must have a single output file name. For that case, single partitioning is fine. For large data sets, it will slow down the execution. Then you have, so main choices, you have use the current partitioning, where you do not do anything special. Whatever already exists is used. If there is a partitioning there, it will be used. Single partition will force everything into one single big data, right? It is bad for big data, okay for small outputs, right? And then there is finally something called as a set partitioning, where I have multiple strategies of partitioning, right? Round robin is basically it will evenly spread the rows across the n partitions. All right. If I say that my data should be read in 5 partitions, so the first row will be sent to partition number 1, the second will be sent to partition number 2, third to 3, fourth to 4, fifth to 5th, sixth again to first, seventh to second, eighth to third, ninth to fourth, 10th again to fifth one. So that is how the round robin works, correct? The hash partitioning, it uses a hash or one or more columns, right? Why it does that is, right, if I can select on which column do I want it. Let's say I want it on store ID, right? Now what happens is I can have, let's say, 5 partitions. So what it will do, it will try to group all the rows with the store ID similar into a single partition. All right. So identical values will end up together. It is really good for aggregations and joins, but it is also good when you have to search your data in the destination, right? So, and when I'm searching for the data in the destination and I know that it belongs to a particular partition because my store ID is this, then searching becomes easy. There is a key-based partitioning, right? It explicitly chooses a column, so rows with the same value go into the same partition, right? There is something called as a dynamic range also, where Spark will estimate a range for a column and group values into a balanced partition. All right. It is useful for numeric columns with somewhat even spread, right? So you can select the column which you want. And then there is a fixed range also, where you define an explicit value, right? Let's say from 0 to 999, right? Over here. You'll enter the expression, right? Where you will select values from 0 to 999, then 1000 to 1999, 2000 to 2999. So it's good, when you know the data distribution, right? So if you have, a table, let's say with customer name, city, and a region, and there are 10 million rows in total, right? And there are only 3 regions there. Let me show it to you. A table, let's say with customer name, city, and a region, and there are 10 million rows in total, right? And there are only 3 regions there. Let me show it to you. Let's say you had a table. That table has columns called customer name, customer city, and region. All right. Now let's say there are a total of 10 million rows here in my data, right? And the regions are spread. So for example, there are total 10 millions. I can write it as 10M, right? So in Europe, there are, let's say, 2 million people. In Asia, I have again, not 2, let's say it's 5 million. And then in the American region, I have again 3 million people. Like that, let's say. If you partition it by region, right? If I am partitioning it based on the region, I will get 3 partitions. One will be Europe, right? With why to write it with 2 million rows. I'll get another partition called Asia with 5 million rows, and I'll get another partition called America with 3 million rows, right? Understood? Partitions? Yes or no?
Yes.
All right. Now, so partitioning of data is important, right? I told you when you want to do it at source, it's more about the performance. When you're doing it at the sink, it's more about how you want to structure your data in the destination. So that is one thing. The other thing over here is, if I show you, right? So that is there in the inspect section of my source, I can see, the columns and the order of the columns, right? I'll show you how you can change the order of the columns also. I'll show you how you can change the name of the column also. And to go to the data preview, you have to turn on this data flow debug. What is data flow debug? Have you heard about it? I'm pretty sure you wouldn't have, because data flow is something that you're hearing about for the first time. So what is data flow debugging?
Debugging, data flow debugging, I don't.
Debugging is the same everywhere, right?
Okay,
So
in
that
Java or
you
anything. Yeah,
everywhere.
just
Debugging is
uh,
nothing but
debugging.
an active mode that basically checks for errors and everything, right?
Yes.
It's continuously. So data flow debugging also allows the users to observe and troubleshoot data as
Yeah,
the data
troubleshoot step by
progresses.
step.
Yes, as the data progresses through various transformations within the data flow. All right. Particularly in Azure Data Factory, right? It is present in Synapse also. So this feature will provide you an interactive way to understand how the data is being processed and identify any issues or unexpected behavior. What happens is, if I define any transformation here, right? Let's say I did a join. Now I'll have a left stream also and right stream also. Now that join cannot be performed until I put this activity into the table and run it. Yes or no? Yes. If I'm defining a transformation,
Yeah.
I can only tell whether the transformation works or not when the pipeline has been executed successfully. Correct?
Yes.
But what if I want to know whatever I have defined is correct without actually going and running the pipeline? Do you think we have something for that? Obviously, that is data flow debug. It is a mode
Yes.
that will help you run your transformation here itself without actually running the pipeline, right? Now I cannot, this is not a pipeline that I'm creating. This is a data flow. Data flow will have to be added as an activity in the pipeline. Do you remember? If I go to author section, let me open this over here. I go to pipelines, I select a pipeline. I'll have to add data flow as an activity. And when I add it as an activity, I have to select from the drop down. So I have a data flow one over here, right? So I have to select that this is the data flow that I want to run. And then the pipeline will trigger. So what you create here is not the pipeline. It's just an activity that you're defining. Understood? So data flow debug, this mode here, which is currently turned off, is an interactive testing and development mode. All right. Within Azure Data Factory, it is present within Synapse also, and it allows you to build, test, and verify your data transformation logic in real time. I don't have to execute the pipeline. I don't have to trigger the pipeline to see what the output is, right? Now, it's more like you've written a Python program, for example, Ravi, right? You've written a Python program. How will you know whether your logic is correct or not until you execute it? Correct? You'll have to execute it. Yes or no? Now, a simple Python program is fine. But what if the execution involves
Yes.
moving data from one place to the other, then saving it somewhere else, then reading from somewhere else? If there's a lot of overhead in that transformation, you wouldn't want to run it every time just for the testing purpose. Correct or no? Just for testing, why do I have to trigger the pipeline? So with the data flow debug mode, it is like a live preview of my data transformation. If I define the transformation here, what is the result that I'm going to get? I can see in data preview. Okay, so it's like step by step, you will get to know that what you did in this activity, what is it resulting into? Understood? Without actually having to run the pipeline.
Yes.
So let me open data flow debug over here. So time, I'll select 1 hour only. Click on OK, because it's a very costly resource also. This data flow debug mode is very costly. Let me tell you, don't just keep it running all the time. All right. So data flow debug, it will take some time, right? Because it uses compute. Because eventually, if it has to show you what your transformation actually does to the data, it will have to do the compute in the backend. Yes or no? So it's like a live preview of your data transformation. When you activate debug mode, Azure will provision a very small dedicated Apache Spark cluster just for my development session. All right. And this cluster will allow me to see how the data looks at every single stage of my data flow, from the initial source to the final sync. How this data flow debug works is, when you toggle the data flow debug button over here, right? in the user interface, there's a series of events which happen in the backend. First, cluster gets provisioned. You see, since it's a cluster provisioning, that is why it is taking so much of time. Compute is getting provisioned in the backend. Azure will spin up a live Spark cluster, based on the integration runtime settings that I have specified. And this process usually takes a few minutes to get complete. That is why, data flow debug is not like I switched it on, it will work directly. No, it does not work like that. It will take some time because in the backend, there is a compute cluster getting provisioned, right? And compute clusters getting provisioned is one of the longest steps within in data transformation, right? Then once the cluster is ready, your debug session begins. This cluster will remain active for a specific period that I'll be defining through the time to live, right? TTL setting. And it can be 60 minutes, it can be 2 hours, it can be 4 hours also, as you saw, right? After which the cluster will automatically shut down to prevent any unnecessary cost. And with the session active, once this data flow debug session is active, right, you can click on any transformation in your data flow canvas and select the data preview tab to basically see at this point, whatever source I selected, I did one transformation, then let's say I did another transformation, then I did another transformation, right? And then I did another transformation, right? Whatever I'm doing, multiple transformations I did here, right? So all these transformations together, right? At this point, when I come to the final select, right? So I did join, I did a union, I did an aggregate, I did a select. So at this select query, what does my data look like? All right. So this is what you will get to know through data flow debug. That is the compute that is getting provisioned in the backend actually. All right. So you can click on any transformation and it'll, if you go to the data preview tab, right, the debug cluster will then process a sample of your data, right, up to a point, and then it'll display the result directly in the browser itself here over here, and it'll give you an immediate feedback on your logic. So whatever, it's like, defining something and then immediately checking whether it is correct or not, right? So it's like a validation happening, debug session side by side you're doing, right? To debug each and every step. That is how you do it, right? Debugging a file, a piece of code, you go function by function, you see how the first function is being called, then how the second function is being called from within the first function, then the third function being called, right? So you will do some console dot log, right? If it's a web development, you will do some print statement, right? To see where it is taking me and what is the data that I'm getting there, correct? That is how you debug step by step. Same thing you'll be doing here also. It's very important, right? You can instantly validate your expressions, your join conditions, your data conversions. And if you make a mistake, you'll see it right away in the data preview section that will allow you to fix it on the spot, right? When a data flow isn't behaving as expected, the debug mode is basically your best tool. You can move from one transformation to the next. You can inspect the data preview at each stage to pinpoint exactly where the logic went wrong, right? For very complex transformations, seeing the before and the after state of your data is, incredibly insightful. So it helps you to build a very strong, mental model also. So for now, for example, it's done. If I have the rows here, right, I have my source. If I go to data preview, I refresh it. Let's see. If I'll not be able to see it, I'll have to go to projection also. Let me see the projection. This is fine. Still happening. Partition the data. Let me import the projection again from the source. All right, so it's successfully imported. Short string short. Let's go to data preview, and now I can see the data. Right. So I'm able to see some 100 rows over here, right? Currently you see order ID is integer, right? Short integer. If I go to my projection and I change it to, let's say, a double, right? I can refresh the data preview. All right. So now you see order ID is in the double format, right? So I got the projection, I got it, I changed the type, and I can see the data preview also based on the type that I have changed. If I run some other transformation, let's say I create a select query, right? And I only want to select specific columns. That is, I just want to know order ID and customer ID. Which customer placed which order ID, right? This is done. If I go to data preview now and I refresh it, I'll be able to see step by step what my data sets are here. So now you see in the select transformation, I made a choice that I want to select these two columns. So I selected a specific column. What name do I want? Let's say order ID new. This is the name of the column that I want to give. Let's say this column should be selected, but I want an alias for its name. Now I can go to data flow preview, refresh it again, and I'll be able to see a different column name altogether, right? So order ID new, right? Within select settings, it's, there's a lot more that we are going to do. We are going to write some expressions also. We are going to build some expressions, right? That is also something we'll see. So I think for today, we should stop it here, right? We've seen data flow debug and everything, and we saw how you're going to do the partition, what different types of partitions are, what is a projection, what is a data flow debug mode, how do you do the data preview in every step, right? Whatever transformation you define after every step, right? Whether you want to, let's say, filter this based on a particular value, right? That also you can define. Here, I can define filter on what value. So here you can use the expression builder. Now this expression builder is very important for you to understand. There's a reference documentation to it that I want you to read, right? So before you come to the next class, please read through this once. Just once, give it a reading. All right. What is expression? What is a factorial, right? What are these expressions? And if you click on them, right, you'll get more details. For example, column names. So column names, what is the expression that you give, right? And what does it do? It gets the name of the output column for a string. You can pass an optional string name as the first argument. The second argument is also optional. With false as the default, you will set the second argument to true. Data factory will return one column that are drifted via schema drift, right? So collect is there. Now there's a lot of different functions that you can use. There are date and time functions. There are expression languages, right? Expression languages basically over here, if you see aggregate functions, we'll see, right? If you want to calculate an average, that also you can do. If you want to do a count, that also you can do. It will give you an average of the column. All right. So we'll see what this is. So I can use something like average sales. There's a lot of it that can be done here. If I go to functions, I can see all the functions over here. If I go to input schema, I can see the columns that I have. I can change them. If there are any parameters to the pipeline, I can do that, right? Apart from that, there are logical operators also here. If I want to add something, if I want to subtract something, if I want to multiply, divide, or, and, not, power is equal to, right? I have everything. So I'll show this to you on Monday. We'll start building these expressions as well. All right. So you'll know how to build an expression and what does expression building here does. So we'll try and understand that as well. All right. Now, as every time, when you're closing your session, please make sure anything that incurs a lot of cost is deactivated or deleted. For example, this data flow debug, I'll just turn it off because I'm done with it, right? And that is what you also have to do every time you're working on the Azure platform. These are, small steps that basically go a long way in managing the cost of your environment, right? So you have to make sure that you're not just building solutions, you're actually building cost-effective solutions. All right.
Okay.
You have to think like an architect. When I say you have to think as an architect, right? That also means that, what does the architect do? He will plan everything, right? He will have the budgets and everything. He'll have everything in the mind. If I just tell somebody to build a wall for me, they can spend lakhs on it also. They can do it in thousands also, right? So that is as an architect, it'll be my duty to make sure that it is done in the best way with most, efficiently, with quality as well, but with the least cost as well. So you're doing it on all the three aspects. All right. It's done, I think. I'll close this. Thank you for joining in. Have a happy weekend. So now, when you talk about version control, right? You would have done it with your code, yes or no? When you work
Yeah.
with GitHub, and we will be mainly dealing with version control using uh, Azure DevOps. So have you ever worked with Azure DevOps?
Um, no stress.
No, right?
Yeah.
So it's exactly like you have it in GitHub, all right? It's actually more or less the same thing itself, right? How you have branches, how you create your repository, how you have a local repository, how you have a remote repository, right? All those things. So what we'll try and achieve today is, we'll see what is the benefit of doing that, right? How do you do that? First of all, how do you work with it? How do you create that repository? So what is version control? What is Azure DevOps? How does it help you with version control? What all things are there in version control? What is the local repository? What is remote repository? How do you create, or we'll see how do you create that remote repository on Azure DevOps, and then how to basically, what is the way in which you have the code in the remote repository? How do you pull it into your local repository? How do you push your code or the changes that you've made to the remote repository? All right. So these things we'll try and understand. So let me share my screen. All right. So you have to understand multiple things here, right? When we talk about, first of all, version control, what is version control, right? Now, version control in very simple language is a time machine for your code. All right. So let me write it here. So I know that you already know most of it, but then others who will go through the recordings and try to refer to it, for them I'm explaining, right? So it may sound a bit redundant, but then we have to cover it, right? Everything should be there in the recordings for others to visit and see. So what is version control? As I told you, it's a time
Time
machine
machine.
for your code, right? It helps you to keep a track of every change that was made to your code. All right. It can go back in that time machine. With that time machine, it can go back to an earlier version if something in the present breaks, right? Now, we all know we are today living in the present. If I could go back in the past and change something, that would hugely affect my present, right? And that is true for your code also. If you made a mistake in the past because of which your code currently is not working or has some problems and has some bugs, or let's say it's not working as expected, then you can always go back in time and revert those changes, right? So when you work with together with the team without overwriting each other's work, that is also something that version control helps you with. All right. Now, which is the most widely used version control system today? Are you aware? Which one do we use? The most widely used version control system is Git. All right. So we'll be using Git and we'll try and understand what is Git and then what is GitHub. Are they the same thing? What do you think? Is Git and GitHub the same thing?
No, I think so.
Yeah. Git is the technology. All right. GitHub is a tool that helps you implement that technology. Same is Azure DevOps. Same is Bitbucket, right? Same is GitLabs, right? It helps you implement version control. They are version control systems. All right. And what is Azure DevOps? Azure DevOps is a platform that is created by Microsoft, right? Uh, and it helps you to, plan, build, and test and deliver. Plan, build, test, and deliver your software. All right. The most important concept here is something called as Azure Repos. All right. So Azure Repos gives you the Git repositories, but on the cloud. All right. So you would be aware of Git repositories. You would have seen in GitHub how you have repositories. So same thing Azure Repos does with to help you on Azure platform. So when you talk about version control in Azure DevOps, we are talking about using Git repos, which is stored on Azure DevOps servers. All right. So Azure DevOps will store your code in a central place, right? That central place where the code is kept, we call that as your remote repository. All right. So this becomes your remote repository, right? And then it allows the whole team, right? So multiple people, somebody from one location, then the same person from the other person from other location, then another person from some other location, then another team member from some other location, right? They can all access this. They can all access this remote repository, right? And they can create a local repository on their system like this. They all connect to it. So it gives you a web interface. Azure DevOps will give you a web interface to view your code, to commit your code, to see the history of your code. It will enforce security also for you, who can see the code, who can edit, or who can merge the code. And it integrates with your pipeline so that you can automatically build and deploy your code after you are pushing it, right? So there are multiple things in the version control system. We'll take a look at each one of them. Now, there are certain things that are there in version control systems. One is a repository itself. Then you have commit, you have branch, you have merge, you have pull, you have push, you have clone. All right. So we need to try this. But where is this Azure DevOps present? It is present in your Azure portal itself. So if you open DevOps, you will see Azure DevOps organization. So the first thing that you'll have to create is a DevOps organization. You can go to my DevOps organization. So I'll have multiple there. I would have created multiple in the past. So we can create a new organization also. Within an organization, you have multiple projects. All right. So the first thing that you have to create is an organization. So you see, there are multiple organizations that I have here. All right. This is my Azure subscription, which is in question. All right. So within my Azure demo environment, this is the main subscription that I have. Within that subscription, I have these 3 organizations. All right. So I can show you how to create a new Azure DevOps organization. You can click on continue and you can give your DevOps organization a name. All right. You can say that this is the demo B8. All right. So batch 8 demo, and you can put in the characters here. Click on continue. And this will create a new DevOps organization for me. All right. Once that organization is created, I can create multiple projects inside it, right? So in an organization, as you can imagine, there would be multiple projects, right? There would be a project team for each of those projects. Each project will have their own specific code, their own code bases, and that is what you have to, work with. So now I can give the project name as, let's say, demo project, right? So it's a private one. Let's create it. So here it will create private projects for you. If you want to create public projects, you can go to GitHub. All right. On the left hand side, you will see multiple things: artifacts, test plans, pipelines, repos, boards, right? So repos is what we need to work with. All right. So you'll find here files, commits, pushes, branches, pull requests, advanced security, all those things. All right. So I can go to repos and I can create a new repository over here. All right. So I can clone this repository to your computer, right? Or I can just initialize a main branch and let's do it. This is fine. Do I want to add something? No, let it be. Let me initialize this repository. All right. So my demo project repository has been created and it currently only has a README file, which is a markdown file over here, right? You can preview the markdown file. So it's an introduction, right? Now, once your repository is ready, right, there are few terms that I would like to explain to you with terms of repository here, right? Now, what is a repository? It is just a folder that is going to hold your project files. All right. So a repository is something, that holds, it's a folder, right? That holds all your files within a particular project. All right. It also contains a hidden database. So there's a hidden database within your repository which contains, this hidden database will store every change ever made within your repository. All right. So it contains all the details of it. So think of it like a library. The files on the shelf are your, working copies, and there are some archives also that keeps a record of every version of your file. Why is it important? Is it's the place that stores the code history. All right. So you can go back to a specific version. You can compare two versions to see what is the change between the previous and the current version, or you can share it with others. I can share this repository with other if I want to share my code base with them. All right. There are two kinds of repository, as I told you. There's a local repository, which is created on your computer. So when you are initializing a repository, when you create it on your own computer, it is called as a local repository. When you have it on the cloud, such as Azure DevOps or GitHub, right, that is your remote repository. So what you see here on Azure is my remote repository. All right. When I get this repository, into my, let's say, local machine, that is the local repository. All right. So there are multiple commands. For GitHub, you can use something called as git init. We initialize the repository over here with a button. If you want to do it with GitHub, you can do git init. That will create a new local repository. You can use git clone, and then you get a URL to the remote, repository. You can copy the remote repository to local, right? So that is a simple repository. Once you have a repository, you will want to commit files, or you want to commit changes to the files to these repositories, right? So when you have a file in the cloud and you made a copy of that in your own computer also, sometimes how it works is, so this is your remote repository and this is your local repository, right? Now there is multiple things that happen like this. So this is you committing your changes, since this is the local repository, right? And this is your remote repository. This is GitHub or Azure DevOps, right? These are your remote repositories examples. And this is your local repository, which is nothing but your own computer. Let's, I can say your computer. That becomes a local repository. Once you make changes to this local repository, that is, you make some changes to the file in your machine, and you're running that code and the code is working fine, then what you do is you want to create a checkpoint. All right. Checkpoint on this remote repository, you want to push that. All right. You want to commit that. You want to tell this remote repository that now I have come to a checkpoint. I will like to save this. All right. So I'll put a commit message. I'll put the author details. There will be a unique ID also. So it's like taking a photo of your project at that moment with a caption that explains what has changed. Commits build the timeline of your project. They let you understand who changed what and who changed why. All right. So you have git add, git commit with a message. So you can make those changes. That is committing. Then let's say you have your code here, and this is running fine like this. All right. So this is a timeline, but you want to, let's say, make some changes to your code. So what you did, you create something called as a branch. This becomes a branch. Now here in this branch, what you do is you will add some feature. All right. Now what happens is, this branch that you see here, this is called as your main branch. All right. This is called as the main branch. All right. And this over here is nothing but a feature branch, right? So what I'm doing in the feature branch, I have the code, right? And then you would have within Azure DevOps Suite. Now, once you add the feature branch, right, You would want to implement a particularly new feature to your code, right? Whatever application you're working on, if you want to, let's say, add a particular feature to it. So you would want to make some changes to the code base, but this main branch is actually the code which is on production. Now, is it a good idea to touch your code in production? Yes or no? Is it good idea to change the code in the production itself? Yes or no?
No.
Never, right? Never make changes to your code on production. So what do? You create a branch of it. This feature branch will be based on your main code itself. It will already have all the code that you have. It will have a copy of this, all the code files in the feature branch. All right. So the code will already be there. Now what you do, you implement a new feature. Let's say it's a food delivery app and you want to add a new feature that gives you a notification, or let's say it's a new feature that allows you to change your address after you place the order, or if it, let's say it's a feature which gives you to give tip to the delivery partner, right? We have seen over the period how Swiggy was launched and what it is today, right? So they've continuously added new feature to the code. So that is what we also need to see, right? Or there is a website, they will keep on changing the website, they will keep on adding new features on the website, but they will never make edits to the production code. What they will do, they'll create a feature branch which will have the code. I'll make the changes, so this code now becomes code dash, right? So it's the updated code dash is nothing but updated code here, like this. And this updated code is then tested. It is tested heavily, it is validated, and once the tests are finished, I do something called as a, what do we call it? What is this called? What am I doing? Anyone? This was creating a branch. So what is this step?
Merging.
Yes, this is merging the branch to your main production code. And after this code changes after you have merged it, right? Now your code here becomes code dash. So your main production code now becomes code dash. That means your code has changed. So we never try and change the production code directly. We will create a branch, we'll change the code, and then when it works fine, if the new features are working absolutely fine, it is thoroughly tested, it has been validated by seniors, it has been validated by the, let's say, higher leadership, the authority, then it is merged into your main production environment. And that is how it happens, and that is what you do here also. All right, now let me show you. All right, if you see, this is my repository. So if I click on the repository, I'll come here. Then if I want the link to this repository, if I want to clone it on my machine, if I want this particular repository on my machine, I perform something called as a clone operation, right? So when I clone it, I'll get the URL, or I can just directly clone it on VS Code also. And then using the URL also, I can clone it. There is a command where I'll have to put this URL. Coming to my data factory, right? Let me launch the studio. Now here, if I go to author section, right, I have multiple pipelines, data sets, and everything. I had told you before that this is the code that gets copied onto any repository that you will create, whether it is in GitHub, whether it is on Azure DevOps. If I want to link this repository of mine to my data factory, what I need to do is I need to go to manage section, and within the manage section there is something called as git configuration. So I'll select git configuration, I'll click on configure, I'll select the repository type, this is Azure DevOps Git, I'll select the enter ID, this is my subscription, right? So I'll select the Azure demo environment, click on continue. Now I'll have to select the organization name. So demo B8 is the organization name that I had selected, and demo project is my project name. So this is how I can select the repository. If this repository is not in my account, I can use the repository link also. If I'm selecting repository link, I'll go to clone, I'll copy this link, I'll come to my data factory again and I'll paste this link. All right. So as of now, no collaboration branch, we'll let it be. There's one publish branch, ADF publish, right? I'll tell you what they are. And I'm selecting to import existing resources to the repository. So whatever you have created, what all pipelines you have created, what all data sets you will have created, that will be, imported into the repository. Let's click on apply. Wait, main is the collaboration branch. So that is like your main branch. Publish branch is not visible initially. That is published once you publish your, pipelines. All right. So I'll tell you what that means. First, let it get connected. So if I come here and I refresh this repository of mine, I should be able to see everything present here now. You see, just now, all of my resources got updated. If I go to datasets, I'll find all the datasets over here. These are all JSON files, right? I told you the JSON files are the ones that will go to the cloud. If I come to the factory, this is detail about my data factory itself. If I see the integration runtime, I have one extra self-hosted integration runtime. If I see the link services, I have two link services. One is to the data lake and the other one is the file system, which we use to connect, to the, what do you call it? The file system, the virtual machine that we created. And then there are two pipelines, right? The code for them also. And there is a publish config, right? Now, once these changes have been made, right, your data factory will look like a different place. Why? Because now on the top, you will see this main branch or live mode. So currently I am in Git mode. Git mode lets you, pull, push, merge, branch, all those things. If I go to live mode, I will not have all of this. All right. This is my normal mode where I don't have to worry about Git. I have to go to Azure DevOps Git mode in order to make sure that these changes that I'm trying to make, they get published over here. All right. Now, as you remember, there are two branches. One is the main branch over here. And as of now, there is no publish branch. I'll have to publish it over here. If you see, there's this publish button. Once I click on publish, then the publish branch will also be created. The main branch is there by default. If you see, I am currently to the main branch and there is an ADF publish branch also, which has not been created as of now because I have to publish over here everything that I have. After I have connected it to the repository, I need to publish it in order to make this publish branch available. What is the difference? The main branch, it is also called as a collaboration branch. All right. This is your collaboration branch in Git. All right. It will usually have names such as main or master, right? You can configure another name, but the default is main, right? When you create or edit pipelines in ADF Studio over here, your changes are saved in the JSON file over here, right? If you're creating a feature branch, right? You make changes, you may merge it to your main branch again through pull request in Azure DevOps. So main is your working branch. This is where you work. If you want to create a branch, if you want to merge it, if you want to clone it, whatever you want to do, you are going to use the main branch for it. It's a main branch for your development and collaboration work. Then there is this publish branch, which has not been published as of now. This is a special branch that is going to be automatically managed by ADF. This branch will be managed by ADF. All right. And by default, it will always be called as ADF publish branch. You are not going to work on the publish branch directly. The moment you click on the publish button, the publish branch or when you do it in the ADF Studio, the service takes whatever is in your main branch, right, and generates ARM templates for it. Who remembers what ARM templates were? Do you guys remember what the ARM templates were? ARM templates let you recreate your resources. These ARM templates that will be created in the ADF publish branch, they basically, or they are, what you will later use in your CI/CD deployment or higher environment, test environment, prod environment, through. So think of publish branch as your deployment branch, not for coding, but for storing the generated templates. All right. So developers will create a pipeline in ADF Studio, save the JSON, when you save it, the JSON goes directly to the main branch, right? Team will review your code through pull request, will merge it into the main branch, right? And then when everything is ready, someone will click the publish in ADF. ADF will generate the ARM templates, and the push is that pushes them into the publish branch. So Azure DevOps pipelines, when you create CI/CD pipelines, we are going to pick these ARM templates that will get created in the ADF publish branch. All right. So that will be used to deploy it into your UAT environment, prod environment, right? So main branch is your team shared notebook. Publish branch is a clean recipe book which is auto-generated from your notes used, by your chef to actually cook, right? So I hope that makes sense. Any doubts? Fine. Now let's see one thing. I'm currently in the main branch. I will create a new branch. I'll call it feature underscore auto trigger. All right. And I will base it on the main branch. Base means that whatever is present in the main branch will be created in this extra branch that you're creating, the feature branch that you're creating. All right. So it will have the same code. It's not going to be a new template where you're going to start from scratch. All right. So where am I now? I'm in the feature branch now. All right. I'm in the feature branch. If I go here, let me refresh. Here you will see the feature branch is there. If I go to the feature branch, it will have everything as it is in the main branch also. All of this I have in the main branch. All of this I have in the feature branch also. But let's see something. If I am adding a trigger here and I create a schedule trigger, let me create a new trigger, and I'll create a schedule trigger which will start on, let's say, from tomorrow, right? And it is happening, let's say, every one day it is running, right? I can mention the time that it should run at 10, or let me say 22, because I want to do 10 p.m., right? So it says it is schedule execution time is 2200. I can specify an end date also, but let it be. If I click on OK, I can save this, right? So now I have changes here. If I go back, see, if I open, let's say, over here I have trigger. Let me show you something. If I go to the main branch now, all right, I have this. Let me go to the feature branch now. You will see that there is a folder called trigger that got created. What is this trigger? Start time, today's time, hours 22, minute 0, that is the schedule, at every 1 day interval, right? So whatever trigger I created is present in my feature branch, but not presently present in my main branch. And that is because I have created it, in my feature branch. It's a change that I have created in my feature branch, right? So I'm here. Now, once this is done, I can create a pull request. When you click on to create a pull request, what this does is it will try to merge these two branches together. So if I create a pull request, it will open Azure DevOps. It will say the title is adding trigger. It will give an auto description also, right? Now here, you can see what you are going to do is you are going to merge this feature branch auto trigger into your main branch. All right. What files are getting added? This trigger file is getting added, and this is the commit because I made the changes there. So that is the commit on which this merging is based. So let me create the pull request. Once I do that, there is no merge conflict. There is nothing wrong with this merging. I can just click on complete. So what it does, merge, no fast forward, complete the associated work items. So this is for, those work items and everything that gets created. And I can delete the feature branch after the merging is complete. So let me complete the merge. So it's merging, pull request, and you will see something now. So merging is done. I can go back to my repository And now you will see that trigger is present in the main branch. Why? Because I merged the two branch. And if I click on the drop down, there is no feature branch at all. Over here, you'll see there is a feature branch right now. If I refresh this, so it says because earlier I was in the feature branch, it's asking me to go to the main branch because the feature branch does not exist anymore, right? So there is no feature branch now. Clear? If you worked with GitHub, does it look similar? Yes or no?
Yeah, it's a similar one. Yeah.
It's almost similar. It's the same thing. Essentially, it's the same thing, right? Everything is the same. The titles and everything, commit, push, right? All of it is same. So now, once this is done, right? Let's publish this. One question I have for you guys. Do you know the difference between commit and push? Can you tell me the difference between commit and push?
Yeah, commit is locally pushed, right? Commit is
Yes.
locally
And
saved and no, no,
push is
commit is
pull.
locally saved. Push is
Yes,
remotely
exactly.
saved. Am I right?
Exactly
Uh,
correct. Exactly correct.
okay.
All right. When I want to save the changes, let me move this here so that I can show you here. See, what happens is when you push the code, right? So moving the code from local to remote, is this push or commit? Is this push or commit? This is push. Commit is when you make changes to your code and save it to your local repository itself, right? So changes made in
Yeah.
the local repository is commit. Saving changes to local. All right, that is commit. Clear? Push is moving these changes which were saved in the local repository to the remote repository, to Azure DevOps, to GitHub. All right, that is push. Getting the code from remote repository to local repository, right? Is it pull or is it clone? This arrow is going up. My local code is going to the remote repository. This arrow is coming down. The code from remote repository is coming to my local repository. Is this git pull or is it git clone?
I think pull request.
Absolutely correct. This is pull. It fetches or downloads the latest changes that have been made to the remote repository because I told you, right? Multiple people are working on it. What if, let's say, this person made some changes and then pushed the code to your remote repository? Now you have, let's say, a version that is from date 15th of, let's say, September, and this guy made the changes on, let's say, today, 18th, right? So that means you have an older code. So you'll have to pull the code, pull the latest code from the remote repository to make changes. That is called pull. Clone is when you're initializing a local working copy of a repository which is not there on your system. It is present only on GitHub or Azure DevOps. Understood? So clone is when you don't have the repository, locally, you have it on the cloud, you have the remote repository, and you want to create a local copy of it. But once you have the local copy, if you want to import the changes, that is pull. Understood? Yes or no?
Right.
Correct?
Yeah. Normally, clone is the first copy of the repo, right? And
What?
pull is like a existing.
I did not get your question. Can you repeat it again?
No, no. Clone is nothing but you need to be first copy of that
First
repository,
copy.
right?
Yes. Yes. Setting up the repository, setting up the local repository. All right. So if let's say a new member of the team joins, right? So he will not have any code. So what will he do? Pull or clone? Let's say this is a
Clone.
new member. He will be
You remember first
clone.
is they can pull that because any existing is there are
Yeah.
right they have to take.
So he is going to clone it. Absolutely correct. But if let's say an existing member wants to get the latest code like this, they will have to pull like this. Clear? All right. Now, if you come here, I am going to publish. Let's click on OK. So I'm publishing my repository now, and this is where the ADF publish branch will be created. The moment I click on publish, the ADF publish branch will be created. Now, what is this publish branch? All right, why does it exist? ADF is going to separate the development and the deployment environment for you. The publish branch will contain ARM templates. So if I show you, let me go here, and now the publish branch will exist because I've already published the code. If I go to ADF publish, open an IC data factory, you see there are two ARM templates that get created, and they are very detailed. They contain everything about all the information about your entire Azure data factory and all the parameters. The VM admin is the name for your link service, right? Your data lake parameter, your file server that we had, C drive, right? So like that, name of the data factory itself, right? File server password, it's stored here. Everything is present over here, all the details, everything. So these ARM templates will describe how to recreate the entire factory and every object within the factory, all right, in another environment, let's say a test environment or a prod environment. So if I want to create a test environment for this data factory that I have and the pipelines that I have within it, I'll be using these ARM templates. All right. So what ADF does when you click the publish, step by step, it's very simple. It reads the collaboration branch, that is your main branch. It reads all the content from the main branch, all your pipelines in JSON, all your data sets in JSON, all your ring services, all your triggers, everything is read. All the artifacts are read in JSON format. Then ARM templates are created, right? And the supporting parameter file is also created. All right. This ARM template will represent the current factory configuration at a given point. All right. And then it commits those generated templates into the publish branch that we have, which is the ADF publish branch. All right. So inside publish branch, you will have one or more ARM templates JSON file. This is over here. You have global parameters for your data factory, right? I have not defined any parameters, global parameters. That is why I'm not able to see anything here, right? Clear? And these are very helpful in CI/CD. CI/CD will always use your publish branch. All right. Developers will merge any feature, any changes made into the main branch. Someone clicks publish in ADF Studio. The ARM templates are generated, and an Azure DevOps pipeline, right, build or release pipeline, is triggered by the changes made to the publish branch. All right. The pipeline will take all the ARM templates and run the ARM deployment and to whatever target environment you have, test environment, prod environment, right? That is where it is mostly useful. So whenever you commit anything, you will have all the history in this commit section over here. Let it open. So I made an initial commit where I changed the trigger. Then I published the code. So that is another commit that was made. Pushes, right? Initial commit was made, and then this ARM template parameter deployment that was also pushed. If you go to branches, ADF publish branch was created, main branch was there, right? So this will have both of your branches here. Clear? Pull request, it will show you the history. All right. If you go to completed, you can find the completed pull request also over here, right? So you can go see the details here. And here on your data factory, you will have now the main branch again, right? If you reload it, you'll be able to see. All right. If you do not want to work in this environment where you have the, see, one more thing I'll tell you. If I go to the live mode, just look at what I have here, publish and validate. Clear? Are you able to see? In the DevOps mode, in the main branch mode, or in your Git integration mode, what do you have? You have validate, save, and publish. If I create a new pipeline, and let me add one of the activities here, I can save this. Whatever half-baked pipeline I created, I have not initialized the source, I have not declared the sink, but I can save the pipeline and the information will now be saved here. If I go into my repository, let me refresh this. Let me go to the main branch that I have. Within pipelines, I will be able to see the current pipeline that I've created. It does not have anything. but I can save my intermediate request. All right. Let me show you the other way around. If I'm in the live mode, it will never allow me to save anything. If I see in the live mode, obviously the pipeline is not there. If I create a new pipeline and here I add a copy data activity. Now either I have to publish it and save it, or else I cannot save it. All right. If I close this pipeline, there is no button to save. If I close it, it will have to discard the changes. All right. So this is one difference between the Git integration mode and the live mode. That is, in Git integration mode, you can save your half-baked pipelines. It does not have to be validated. Over here, you have only one option to save your pipeline in the live mode, and that is the publish button. Until and unless you publish it, it will not be saved. But in the Git integration mode, I can save the pipeline midway without even having to complete it. Complete it as in without having to, save the changes that I made to the pipeline. Uh, you know, sorry, not without having to save, without saving, without completing the pipeline, I can save it. So please try it out also. If you're created your own data factory, I would strongly recommend you to check for version control also. See how you can, create these repositories and link your entire code base. And this is not just for data factory. Let's see if we have a Synapse workspace. The same service works for Synapse also. Same to same. No changes. I have an IC Synapse. Let me load it. Let me open this Synapse Studio. If I go to the manage section, there is going to be Git integration present over here also, called Git configuration, and you can configure it in the same manner. Select whichever one you have, Azure DevOps, then use the select my enter ID in which subscription I have it, and then select the organization name, select the project name, and select there is a repository also here. I can select that also and click on apply, right? But I won't do that because then it will just save whatever files we have to my same workspace, which I don't want. All right. So this is how you can integrate Synapse code also, because you will be developing a lot of scripts here, right? You will have a lot of scripts, you will have pipelines. Those scripts also need to be saved, right? Those are important scripts, SQL scripts that you have, right? Similarly, if you're running Apache Spark jobs, we've not seen Apache Spark jobs as of now, right? But if you create an Apache Spark pool and here you are creating the notebooks where you define the Apache Spark job, right, in PySpark. So that also needs to be saved into a repository. Clear? So with that, we'll stop here today.